Good morning, everybody. Are you guys ready for the session? Yes or no? Voice, everything is perfect, yes or no? And Marekama guys, right now itself you can just share this video with your friends, okay? We want more watching. And this is a long marathon session, correct? So we need more people. So just inform others as well, everybody. Everybody. Good morning, Lakshmi. Good morning, Hajar. Yes, Gandhi. Okay, I'm not, I can't able to write. Yes, princess of myself. Wow. Yes. So yeah, guys, as I mentioned, just share this video with your friends. You know, on the yes, I mean, if this is the watching, I won't be having energy and I will say bye-bye immediately. So, actually, what we have planned is like we will be covering class 12th completely, okay? In the session, you will feel like, ma'am, class 12th is perfect, pakka. That's in the comment box. And also, we will be starting with the high weightage, then eventually we will be going with the low weightage. Low weightage, in the class 12th, hardly 2-3 chapters. That's we will be covering at the end. So, this is what we have planned. Everybody is ready? Reshini, right? I'm pronouncing it correct. Yes, good morning, Vanakkam Shamida. Ishwara, okay Ishwara. Yes, Daya, good morning. Yes, Jayashree. Yes. So, if you guys are ready, okay, you should give me a fire right now. At this moment, you guys have to give me a fire. Hey, why this is not working? Something has happened, I guess so. Let's see. Okay, perfect. So first we will be starting with our favorite electrostatics. Actually we will be starting da. So electrostatics first we study electric charge. So quicker you guys can give the properties. Okay, properties of electric charge you people know better than, right? You people know better than anybody else. So correct and the 3 points quantization. So on the points you can just give it to me. I'm planning for 8 hours. 8 hours. Okay. And first a few chapters we will take a little bit more time. And already I have taken some chapters. That's precise I'm going to tell you. Okay. Yes, very good. Quantization, then additivity, then third one is conservation of charge. Purinjidada. So tell me, what is additivity of charge? What you will understand if I'm saying additivity of charge? Yenada and the additivity of charge? Yena very simple arkenda. Actually, nama charge. Okay, adukku munnadi charge scalar vector. Please let me know. Yes, and the question munnadi Shamida has given the answer. Okay, so actually idu oru scalar quantity da. Okay va. Appadina ipo oru -3 coulomb charge irukku plus 2 coulomb charge irukku. Appadina and the system total charge enada -3 irukku plus 2 irukku. Appadina total charge. What is going to be the total charge? Very good Manchu, very good Lakshmi, very good Soumya. Yes, Jayashree, I forgot your name. Reshini, correct. Yes, Daya. Hajar. Yes. Jayashree, I forgot. I'm really sorry. Okay, 0. Eppadi 0. -3 plus 2. So, -1 da actually vanda. Yes, good morning. Yes. So, yes, Ishwara. Okay, yeah, perfect. So, this is the additivity of charge. If we negative charge, we have to consider that negative sign. And also, what is conservation of charge? If we have an isolated system, the total charge remains constant. We cannot create charges. We cannot destroy charges. It's constant. And again, the other point is nothing but quantization of charge. Charge multiple of E value. What is E? Can you please let me know what is E? What is E? What is E? Please let me know what is E. It is nothing but, ma'am, 1.6 into 10 to the power minus 19, ma'am. Okay. Evlo what in the same question you are asking. Okay. And you will just put the minus 19 instead, you will put minus 17 or minus 31 and the madri you are going to do. Okay. That is why I am just repeating the same thing again and again. Okay. Guys, marakama like panikoda. I want more likes. I want more likes. Okay. So second thing is nothing but nama what to say Coulomb's law da. So can you please let me know what is Coulomb's law? What is Coulomb's law? Everybody tell me what is Coulomb's law? Coulomb's law na adu vandu electrostatic force, ma'am. Enada indha electrostatic force நம்ம two charges இருக்கேல, இப்போ வந்து இந்த two charges like charges na இவங்க வந்து ripple ஆகும்ல, இல்லனா இப்போ வந்து unlike charges na இவங்க வந்து attract ஆகும்ல. So அந்த attraction இல்லனா அந்த repulsion அதுக்காக இருக்கிற அந்த force, the force experienced by the charges da actually வந்து நம்ம electrostatic force. அதுக்கு வந்து we can find it out. Okay, we can find the value of it. Yeah, already it is there. Yes, very good. K q1 q2 divided by r square. So appave sollada, what is r? What is r? Don't say radius. Apart from radius you tell anything. Okay, what is r? Specific ah enakku vanda answer kadikanum. Okay, many times I have taught you என்னடா இந்த r. r na ma'am, அது வந்து சிம்பிளா ஒரு டிஸ்டன்ஸ் அல்ல மேம், சென்டர் டு சென்டர் டிஸ்டன்ஸ் தான். ஏன்னா நம்ம ஃபோர்ஸ் இல்லை மேம், இந்த எலக்ட்ரோஸ்டாட்டிக் ஃபோர்ஸ்னா அது வந்து ஒரு கன்சர்வேட்டிவ் ஃபோர்ஸ் தான். இந்த ஒரு கன்சர்வேட்டிவ் ஃபோர்ஸ்னு சொல்லிட்டேன்னா அது வந்து ஒரு சென்ட்ரல் ஃபோர்ஸ் தான். எப்போவுமே when I'm calculating this r, நாங்கள் வந்து we will always do the correct. இதுதான் வந்து I have told you, don't give me distance. Okay, சென்டர் டு சென்டர் டிஸ்டன்ஸ். ஓகே, இப்போ வந்து நம்ம பாயிண்ட் மாசஸோட, ஓகே, பாயிண்ட் மாசஸோட சென்டர்ல இருந்து தான் இந்த டிஸ்டன்ஸ் வந்து ஃபைண்ட் பண்ணனும். இப்போ வந்து if you are finding, ma'am, this is what the distance, இது வந்து wrong. Okay, this is wrong, this is what the right answer. புரிஞ்சுதாடா? Give me a yellow heart if you understood till now. Everybody give me a yellow heart if you understood till now. Okay, so this is what the first part. Let it be there. Now இப்போ வந்து I can just say that I have a charge q1 over here. இங்க வந்து ஒரு q2 இருக்கு. So இப்போ வந்து I'm just asking you, in the q1 will exert some force on q2, correct? Am I right or wrong? In the q2 will exert some force on the q1, correct? அப்படினா can I say that the force exerted by this one on this one, which is equal to the force exerted on this one due to this one? Can I say that? And that will be equal and opposite, which means my question is, can I say F12 which is equal to minus F21? Am I right or wrong? If you understood, give me a red heart quickly. Everybody, I need everyone's red heart. I'm starving for this heart. Very good. Okay, so this is what the another important point which we should understand. Okay, vada. So now we understood about, ma'am, force வந்து புரிஞ்சிடுச்சு. And இப்போ வந்து right now you are talking about the force K q1 q2 divided by r square, ma'am. ஆனா வந்து எனக்கு வந்து I wanted to keep the charge in some other medium. Okay, எனக்கு வந்து இது வந்து I need to keep it in another medium. அப்படினா இந்த forceல ஏதாச்சும் ஒரு change இருக்குமா ma'am? Can you please let me know da? Can you please let me know? இப்போ வந்து two charges இருக்கு. Okay, அவங்க வந்து they kept in air. Okay, அப்படினா what will happen? Loading any problem? Any problem? Loading. Please let me check the. Is it resolved now? Yes or no? Okay. Yes. Thank you, da. Thank you so much. Okay. So now going back to the question. Okay. So yes, what was the question? இப்போ வந்து same system I'm replacing. Okay, I'm just keeping in some other medium which is having a dielectric constant K. அப்படினா நம்ம force வந்து airல F தான். அப்படினா what will happen if I'm keeping in some other medium? Will it reduce or increase or remains the same? Can you please let me know? Everybody? Force in another medium apart from air or vacuum. Force decreases, ma'am. Very good, Ritik. Very good, Soumya. F by K da. Okay. இப்போ வந்து airல இருக்கும்போது நம்ம force வந்து F na, definitely what will happen da? 1 second, definitely what will happen? It will reduces to 1 by k times. Understood? Yes or no? Give me a fire if you understood. Yes, decreases, decreases, decreases. Yes, perfect. Okay, Vada. So this is what the things we need to study in the case of electrostatic force. Now, can we go for solving some of the questions? Some of the questions ready? And also, I just wanted to tell you one more thing. What is equilibrium? What is equilibrium? What is equilibrium? Equilibrium, I know ma'am, equilibrium na net force வந்து 0 இருக்கணும். So இப்போ வந்து I'm telling you ஒரு charge வந்து okay ஒரு charge வந்து equilibriumல தான் இருக்கு. equilibriumல தான் இருக்கேனா of course அதோட meaning என்ன? அந்த charge experience பண்ற net force வந்து 0 தான். புரிஞ்சுதாடா? net force வந்து 0 தான். Very good, okay. So right now another thing is nothing but இப்போ வந்து we understood the net force. So let us say இப்போ வந்து எனக்கு வந்து ஒரு charge இருக்கு, அது வந்து Q தான், Q1 இருக்கு, Q2 இருக்கு, Q3 இருக்கு, Q4 இருக்கு. So இந்த chargesனால definitely it will experience a net force, right? So this is what we are calling superposition principle. So what is the definition of that? What is the definition of that? So inga வந்து ஒரு charge Q இருக்கு, இங்க Q1 இருக்கு, Q2 இருக்கு, Q3 இருக்கு. What I wanted to find, I wanted to find what is the net force on Q. Okay, how I'll be finding it? I will find the vector sum of individual forces. Individual forces சொல்லும்போது இந்த Q1 will exert a force on Q. அதுதான் வந்து நம்ம F1. Q2 will exert a force on Q. அதுதான் வந்து F2. And Q3 will exert a force on Q. That is what F3. So on the individual forces we will find. அதுக்கப்புறம் we will be mark the direction. அதுக்கப்புறம் we will be finding the vector sum. Understood? Give me a yellow red combination. Okay. Red heart everybody. Now we are moving on to the first question. Everybody. Not from scratch, of course, da. So இது வந்து I mean scratchல இருந்து teach பண்ணனும்னா I will take at least 1 month da. Okay, that is not anyway possible. இது வந்து revision da. ஏனா re-NEET இல்லையா? Already you people have studied. My heart to you, ma'am. My heart is also to you, da. So now let us say we are going for hey why this is happening? ஏனா இன்னைக்கு வந்து there is a lots of slides, so that might be the reason this is not coming. Hey, it is checking our patience. Why it is happening so? Okay. So yes, here we are going for the first question. 3 neutral balls A, B, C எல்லாமே வந்து identical தான் are taken and then ball A, B are charged positively and negatively respectively. Okay va? A வந்து positive da, B வந்து negative da, and C வந்து change எதுவும் இல்ல, அது வந்து neutral da. Arrange the balls in the increasing order of their final mass. Now quickly tell me da. இப்போ வந்து I'm saying இது வந்து okay I'm வந்து negative charge da. Okay, negative charge. So இப்போ வந்து negativity நமக்குள்ள இருக்குனா என்னடா feel பண்ணும்? We will feel more weight. Okay, we will feel more weight. Okay, physical weight இல்லடா, actually வந்து நம்ம mind will be always stressed. Correcta? So அந்த மாதிரி negative charges accumulated or more negativity na அதுக்கு வந்து definitely அந்த number of electrons added இல்லையாடா, more negative charge which means more number of electrons இருக்கும். அந்த more electrons ஓட mass வந்து actually அதுல வந்து அதிகமா இருக்கும். So definitely A, B, C ல which one will be having the highest mass? Highest mass இருக்கிறது எதுக்குடா? Definitely நம்ம negative charged body க்கு தான். கரெக்ட்டா? So negatively charged body na இந்த கேஸ்ல B தான். கரெக்ட்டா? Next my question is obviously you guys know it. இப்போ வந்து A இருக்கு, C இருக்கு. C na neutral da, A na actually வந்து it is positive da. What is the meaning of positively charged body na adoda meaning enna? Negativity வந்து less da. Correcta? I have removed a lot of negativity and I become positive. Okay, which means எனக்கு வந்து அவ்ளோ number of electrons இல்ல. Okay, என்கிட்ட less number of electrons தான் இருக்கு. So அந்த electrons ஓட corresponding mass கூட reduce ஆயிருக்கும். எனக்கு வந்து அவ்ளோ weight feel பண்ணாது, ஏனா நான் வந்து எப்பவுமே positive. So definitely what will happen da? What will happen? In the A க்கு வந்து there will be less mass da. So which is going to be the right option? Can you give me the answer in the chat box? Which is going to be the right option? And let me ask you one more question. So in here, we will be covering class 12th completely. Till the end of the session. Yes, very good. See that. Okay. Till the end of the session, who all will be there? Okay, ma'am. ஏதாச்சும் ப்ராப்ளம் இருந்தாலும் ஐ வில் கிவ் ப்ராப்பர் பிரேக்ஸ் பிகாஸ் ஏன்னா உங்கள் லேப்டாப் உங்கள் மொபைல் ஃபோன் எல்லாமே வந்து சார்ஜ் பண்ணணும்ல அதுக்கு வந்து ப்ராப்பராக பிரேக்ஸ் கிடைக்கும் லஞ்ச் பிரேக் ஸ்நாக் பிரேக் எல்லாமே இருக்கும் ஸோ டோன்ட் வரி அபவுட் இட் பட் டெல் மீ promise me ma'am I will be there till the session. Promise me. Hi ma'am, Akash here. Yes, hi Akash. Yes, I'll be there. I promise you ma'am, I'll be there. So let me just check all the names. Okay. Yes, nama Rashini, right? Rashini is there, Manchu is there, and Divya is there, Shamida, yes, Kashifa, Hajir, Srimukhi, yes, Saumya, Triyan. I'm pronouncing it wrong, I guess so. Okay, all the names were going. Okay, Varsha, I got it. Manju, yes, very good. So I will check all these names in between, okay? And whenever I'm asking any response, you people have to, okay? This is a promise. Yes, Yokita. 1 to 4. After that, I'll join, ma'am. I couldn't, ma'am. Okay, fine. Okay. Okay, so yes, perfect. So now let us go for the next question. In the question la yarakavadu doubts irukada irukka maate ena vandu avlo easy ana oru question. What is the number of electrons in 1 coulomb? Hey, idu vandu ma'am, it is not required for us to calculate. Ena eppovume இந்த chapter start பண்ணும்போது ask பண்ற ஒரே ஒரு question இது ma'am. So tell me now what is going to be the answer for this question and how we will be finding which equation we can use it here. Which equation we can use here? Which equation? See ya. Do the calculation. Yes, very good Abhinaya, very good. So in the case we will be doing Q is equal to plus or minus NE. Nama quantization of charge, correct? So ipo vandu what we needed? We need N. So appadina I will go for Q by E. So Q enada 1 coulomb da divided by what is E value? This is what the E value. Now tell me, do this calculation and tell me what is the answer. Do this calculation and tell me. Yes, very good Daya. Very good Varsha, right? Love learning Varsha, right? Yes, Roshini, very good. Rashini, right? Why I am making mistakes? I have to note it down. Otherwise, again I will make mistake. You people will give me, what to say, punishments also. Yes, Jia, how are you? Yokita. Yes, perfect. Let me write it down. Okay. So yes. We are going for the next question. In the question oda answer enna? Option A da actually vandu nama answer vara porom. We are going for the next question. Ready ada? Give me a fire if you are ready for the next question. Give me a fire. Idu vandu avlo simple ana oru question. Avlo simple. You people will definitely give me the answer. Perfect. So yes, இப்போ வந்து பார்த்தேனா two charged bodies இருக்கு P and Q. Okay, P and Q இருக்கு. இது வந்து attraction either P will be positive, Q will be negative. So let me just start with this is positive, this is negative. Okay, if you want you can just take P as negative and Q as positive. There is no issues. Okay, va? Now body Q and R repel. So இது வந்து negative na, இது வந்து same charge ஆ இருக்கணும்ல. This is actually repelling. Okay, and if I am bringing this R over here, what will happen? Tell me. P வந்து positive, R வந்து negative. அப்படினா those who have given answer A. Okay. So what is the answer? இது வந்து option B da. இப்போ வந்து question you are feeling like it's very easy ma'am nalum definitely da, please do solve the question, at least just try one more time. Okay, so immediate the answer you are not supposed to. Last time la kuda you understood, right? Major in the mistakes when the many students has done. Purinjidada everybody? Give me a heart if you understood. Give me a heart if you understood everybody. Now we are moving on to the next question. Yes, let us go for this question. So in the question, what is happening? We just need to know the net force on 2C charge placed in the figure. Okay. So nama 2 coulomb charge, not 2C. 2 coulomb charge experience pandra force actually we need to find it. So in the madre questions, first what we should do, we should find the individual forces. Individual forces in the 2 coulomb charge, definitely in the 4C will apply some force. And in the minus 2C will also apply some force. Appadina 2C la experience pandrathu vandu 2 forces da, correcta? There will be 2 forces acting on it, correcta da? So appadina now the second thing is like what happens, Srishti? Let me know what is happening. Okay, so appadina in the question la first we understood 2 individual forces irukum, and the 2 individual forces oda vector sum da namma net force on 2C. Understood? Give me a red heart, everybody. If you understood this statement, give me quickly a red heart. Okay, so in the 2C definitely there will be 2 forces. One is due to this 4 coulomb, another is due to minus 2 coulomb. Next one and the direction da find pannanom. Okay, so ipo vandu naan da sorry da. Okay, so ipo vandu paathena naan da vandu inda 2 coulomb. Okay, I'll just stand at 2 coulomb. Okay, so ipo vandu paathena enkitta 4 coulomb irukku in the side la. I'm just focusing on in the 4 coulomb mattum da I'm just going to focus. So 2C na positive da, 4C na positive. 2 and 4 vandu positive charges da. Appadina, my question is, in the 4 coulomb nala, I will feel repulsion or attraction. In the 4 coulomb will attract me or repel me, which means if I am marking the force direction, it will be towards 4 coulomb or it will be away from the yes, of course, Srishti, of course you can. Okay, in the 2 coulomb charge, okay, I'm just focusing on the 2 coulomb charge. In the 2 coulomb charge, will it experience a force away or towards 4 coulomb? It will away. Yena repulsion. 2 like charges definitely repel. So in the 4 coulomb nale, it will be experiencing a force in this direction. Purinjidada, everybody give me a heart. Okay. Now another thing, minus 2 coulomb and 2C. This is attraction, correct? It will move closer to it, or let's say move towards or away from it. In the minus 2C, minus 2 coulomb nale, in the 2 coulomb will move towards illa away. Definitely, ma'am, this is attraction dana. So it will definitely move closer to this. So I'm getting 2 forces. Okay, I'm getting 2 forces in the same direction. So let me just write, due to this 4 coulomb, I'm writing 4C. Due to minus 2C, I'll be just writing like this. Okay, Vada. Now the thing is like we have to find the magnitude. Okay, we have to find the magnitude. Very good, very good, very good, Leksha. Very good, Manju. Yes, Abhinay and Diya. Very good, Daya. Very good, baby, right? Yes, very good. So, இப்போ வந்து magnitude தான் find பண்ணணும். Individual forces, which means the 4 coulomb நால இந்த 2C ல இருக்கிற force. So, definitely K இருக்கும் 4 தான் நம்ம charge and Q2 na 2 தான் divided by what is the distance? It will be 1 square. Next one is due to the minus 2C, there will be a force experienced on 2C, which is nothing but K into 2 into 2 divided by 2 square. Can you find the sum of this one? Yeah, now both are in the same direction. So definitely you can just directly add this two vectors. Can you find the answer? Can you find the answer? Option A, B, C, D. Tell me which is the right answer. And guys, don't forget to like the session. Don't forget to like the session, everybody. These many people who are watching. Okay, these many people were watching. But like is rumba selfish. I don't know why. Yes, option C, option C, option C. Very good, very good, very good. So option C da vandu nama right answer. Now we are moving on to the next question. Ready now, give me a fire. Yes. Okay. So actually how I have planned the sessions is like ஒவ்வொரு டாபிக்லுமே மேக்ஸிமம் பாசிபிளான டிஃப்ரெண்ட் டைப்ஸ் ஆஃப் கொஷின்ஸ் அதுதான் வந்து we are going to do it. இது வந்து அவ்வளோ டிஃபிகல்ட் ஆகாது, அவ்வளோ டிஃபிகல்ட் கொஷின் ஐ டிடன்ட் ஆட். ஓகே, ஆனாலும் கொஞ்சம் மாடரேட் லெவல் கொஷின்ஸ் எல்லாமே இருக்கும். டிஃபிகல்ட் கொஷின்ஸுக்கு எல்லாமே வந்து செப்பரேட்டடாக டெடிகேட்டடாக we can do a session. ஏன்னா வந்து if I started any difficult question, you people will say மேம் ஃபிசிக்ஸ் என்னால் முடியாது, இந்த கொஷின் வந்து அவ்வளோ ஐ மீன் அவ்வளோ பிக்காக இருக்கு மேம் என்னால் முடியாது அந்த மாதிரி சொல்லி you people will leave. ஓகே ஓகே. Yes, perfect, 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 everybody. Now can we move on to the next question? Ready? No writer is not required. While you are finding the magnitude, you can. Okay, wow. So now, in the one question, 2-point charges having equal charges. So let us say this is Q, this is Q. Separated by 1 meter. Okay. And experiences a force, adu vandu directly given. Hey, what we need to find then? What will be the force experienced to them when same distance da ana vandu medium different ah irukku? You already given the answer for me. What is f dash then, or what is the force in medium? What is the general expression? It is nothing but the force in air divided by k. Correct? அப்படினா what I will write here, airல இது வந்து 8 Newton da, k value வந்து it is already given in the question. So tell me what is the right answer for this question everybody? Option A, B, C ல D ல which is the right answer? Tell me da, which is the right answer? Tell me everybody. Tell me everybody da, please 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 quicker you can tell me. Very good, very good, very good. We will be getting option C as the right answer. So now let us move on to, I have a heavy question here, but currently I'm not going for it. I was expected many students will be there. So on the time if let us say 10 or 20 students are leaving also fine. And I was this was unexpected. Why I don't know. You don't want to study or what? Re-NEET hardly 20-25 days da irukke. Okay. Hardly 28 days, correct? Okay. So, on the time, I don't know why you people are becoming like this, but let us see. Okay. So, yes, right. So, now the 2 charges irukke. Okay. And what is this? 2 charges or a magnitude is given. And minus 10 to the power minus 6. Okay, 2 charges or a magnitude da. Okay. Minus root 3 into 10 to the power minus 19 ta Q1. Okay, I was also getting confused. Q1 na minus 10 to the power minus 19 coulomb. Q2 na minus 10 to the power minus 6 coulomb. Okay, are placed at 0, 0, 0, 1, 1, 1 respectively. Find the force on the second charge in vector form da we need to find it. Correct? Okay, so appadina what happened? Option C lanna same answer ma'am, option C. Illada different ah irukke. Okay. Okay, previously, okay, I understood, okay. So right now the thing is like you have to find the R12, okay, nama position vector, yena nama answer varumbodhu we know that we will be having the equation like k into q1 q2 divided by R12 square da nama vanda required ah irukke, correct? So appadina first you have to find R12. So what is going to be R12? It will be nothing but 1 minus 0 I cap plus 1 minus 0 j cap plus 1 minus 0 k cap. Correct ada? So this is what our nama R12 vector. Okay va. Now next one is idoda magnitude thevaiya irukke. Okay, what is going to be the magnitude of this one? Can you find me the answer for this? What is the magnitude for this question? What is the magnitude for this question? Tell me. How we will be finding it? How we will be finding it? Everybody tell me. Everybody, how we will be finding it? We will be going for the 1 square. Magnitude of I cap. Adu vandu 1 da. J cap 1 square. So I'll be getting root 3. Okay va? So right now, nama force order expression enna k into q1 q2 divided by R12 square into R12 cap. Am I right or wrong? Am I right or wrong? Till this understood, now give me a yellow heart everybody. Till this understood, give me a yellow heart everybody. Understood till. This is our vector part. We didn't even started the electrostatics part. First one our equation we know that we need R12 and R12 cap. Okay, so R12 boda magnitude we found it. How we will be finding R12 cap? What is going to be that? What is going to be that? It is nothing but nama R12 vector divided by magnitude of R12, which means I will be getting I cap plus j cap plus k cap divided by root 2. Q1, Q2 is already there. R12 oda square sollumbodhu adu vandu 3 da. Now can you find the answer for this question? Yes, Manchu. Yes, guys. Smash the like button, guys. Just make sure your attendance. I don't know why you people are becoming this much. 2 more 4. Oh my god, 2 likes. Can't you give 2 likes? So tell me now, what is the answer for this question? Everybody tell me. Option C. Very good. We will be getting option C as the just one can choose more. Okay, just leave it. Okay, anyway, even 0 can choose. Very good. We have achieved first target. Okay, perfect. So we will be getting option C as the right answer. Can we move on to the next question? You will feel like it's a difficult question, but in the madri niraya questions we have done. Correct? Yes or no? So this first what we should do, we should make it into components. Now the components in the FE is actually, okay, in the x-axis, mg in the y-axis, in the t the actually in between, or let's say in xy plane. So definitely what I will do, I will make this into components. So this is nothing but namma t, this is sin theta, okay, and this one will be t cos theta. Understood this part? Everybody understood this part? Okay, right now the thing is like, in the case, okay, what is the question? I forgot. Okay, find the magnitude of charge on the sphere. Actually, we need to find it. Adikaga first what I will do, I will be writing, okay, I will be going for making the forces into components. Yella forces I need it in x, y axis. Okay, understood till everybody? Understood? Yes, we need to reach 100 likes immediately. Everybody. No guesswork. Just do it. Okay. So right now I'm going to write few equations. Okay, I'm going to write few equations. Can I say Fe which is equal to t sin theta? Can I say this? And what is Fe da? What is Fe? Nama charges the same da. Appadina it will be coming as kq square divided by r square. So ipo in the r square or at the end we can find it out. Okay, r square which is equal to t sin theta. Understood this first equation? Yes or no? Everybody understood this equation? Everybody understood this equation? So right now t sin theta inga irukku and it will be like charges illa, so repulsion da irukum. So Fe will be acting towards this direction. So Fe will be equal to t sin theta. So we will be getting kq square divided by r square which is equal to t sin theta. Can you please let me know what is going to be t cos theta? What is going to be t cos theta? Tell me what is going to be t cos theta. It is upward and it will be cancelled by mg. Correct? Now I'll be just divide both the equation 1 and 2. So what will happen? T will be get cancelled. So on the right hand side I'll be getting tan theta. What I'll be getting in the what I'll be getting in the left hand side? What I will be getting in the left hand side? Tell me what I will be getting on the left hand side. I can say that I will be getting kq square divided by r square mg. Am I right or not? Am I right or wrong? Please let me know. Please let me know. Yes, very good, very good. So right now, I just wanted to replace r. R is not given. I need to write in terms of the length of the string. So purinjikoda, this is what the final equation we got it. Let it be there. Let it be there. Now I just wanted to find this distance between the two charges. Okay, I just wanted to find the distance between these two charges. Okay, so let me see. So now inga vandu paathena, this is how the diagram, correcta? This is how the diagram. I need to know this distance. Pakka? So now I'll be drawing a perpendicular over here, and this is coming as theta, this is coming as L. Appadina, can I find this length? Can I find this length? Can you please let me know what is going to be this length? What is going to be that? Let me just write A, B, C. I want AB. Okay, that is what my what is a agenda. I just wanted to find AB. So in the diagram paakumbodhu, I'm just going to find sine theta. What is going to be sine theta da? AB, which means opposite side, divided by the hypotenuse. So what will be AB? AB will be L sine theta. Now tell me da, what is going to be the distance of separation? What is the distance of separation? According to this, I understood AB na L sine theta da. So what is going to be AC? AC na, it is 2AB da. So I'll be getting 2L sine theta. Understood? Give me a red heart. Understood? Give me a red heart. Yes. Hi Praveena. Yes, yes, yes. So what is going to be AC? It will be nothing but 2L sine theta. Understood na? Give me a heart. Quickly give me a heart. Everybody. Yes. So right now, definitely da Kashifa, we will be discussing on 29th, class 11 we will be discussing on 29th. And nalayku kuda oru session edukada, marakama join panniko, sharp 10 o'clock we will start. Okay, so now I'm just going to replace here. Okay, I'm just going to replace here. So what I'm going to replace? KQ square divided by mg irukku, r square ku instead of what we got? 4L square sine square theta. Correct? Sorry, yes, which is equal to tan theta. So in the equation la irundha, can you find the q value? Yes or no? Quicka you can find it da. Quicka you can find it, everybody. So q square ku vandu idhila irundhu you can find the expression. Adukapra you can just take the root of it and tell me what is going to be the answer for this question. So kq square divided by 4L square sine square theta mg, which is equal to tan theta. So idhila irundhu we have to find it for the q, expression for q. Yesterday it was this session was scheduled at 11 only da, not at 10. நாளைக்கு ஷார்ப்பா 10 o'clock க்கு, ஏன்னா வந்து நாளைக்கு 3 sessions இருக்கு, chemistry, physics, biology. So 10 o'clock க்கு ஷார்ப்பா we will start. Okay, so what will happen? இங்க வந்து q square I will place. So already அங்க வந்து tan theta இருக்கு. So mg 4L square sine square theta divided by k it will come. So now you can just take the root of this one, and what is going to be the answer for this? K you can just write it as 4 pi epsilon naught. 4 pi epsilon naught. K value na 4 pi epsilon naught da. Now tell me what is going to be the answer. And guys, give more likes. Everybody. Everybody give me more likes. So yes, perfect da. Everybody is giving the answers. Very good. We will be not B da, we will be getting option A. 4 irukella. Okay, so you will be getting option A as the answer. Yeah, option A will be the right answer. 4L sine theta root of pi epsilon naught mg tan theta. If you understood, give me a red heart quickly. Everybody give me a red heart quickly. I need red heart. Okay, so let us go for the next question. Okay, so let us see what is in the next question. Yes, let us see here. Find the net force on 2 coulomb charge placed in the figure. Where is the 2 coulomb? On the top. Okay, so ipo vandu paathena, okay, Of course, you can watch for 2027. We have already done the videos, right? Okay, live sessions we didn't even started. That is the only problem. Okay, so you can just watch all the rest of the videos. So in the 2 coulomb charge, we will be experiencing 2 forces it will experience. Correct? 2 forces it will experience. So now tell me, how will be the 2 forces in the 4 coulomb and 2 coulomb? Will be a repulsion or attraction? Will be a repulsion or attraction. I will mark the 2 forces, this one and this one. Let me call this as A, this as B. So which direction it will be? Can you please let me know? So in the 4 coulomb nala, in the 2C will experience a force. The direction will be A or B. A or B. Adu vandu repulsion. Perfect rida. Okay, repulsion da. Yena vandu like charges da. My question is, which is going to be the right direction? Repulsion na, obviously ma'am, it will be A da. Correct. Okay, so now we will be get to know this is going to be the direction due to 4 coulomb and this is going to be the another one. And can I say that, let me call this as F1 and this as F2. Can I say that magnitude of F1 which is equal to magnitude of F2? Can I say this and tell me why? What is the reason for it? Okay, what is the concern? What I have mentioned, இப்போ in the 2 coulomb la 2 forces da act பண்ணிட்டு இருக்கு. அந்த 4 coulomb charges இல்ல, அதுதான் வந்து அதுல force experience பண்ண போறோம். Okay வா? So அப்படினா definitely what will happen? இதுதான் வந்து 2 forces. Now I am telling இந்த 2 forces ஓட magnitude வந்து same தான். Okay, ஏனா charges வந்து same தான். Also distance of separation also same தான். Correct? Distance of separation is also same. அப்படினா I can say that magnitude வந்து same தான். Correct? Now tell me, what is the angle between them? What is the angle between them? What is the angle between them? Can you please let me know? What is the angle between them? So what is this angle? This is an equilateral triangle da. So this is 60. So obviously this is also going to be 60. What is the next step? We need to find the net force, which will be coming as F square plus 2F1, or let's say 2F square cos 60. It will come as the magnitude. And what is going to be the direction? It will be just upside. Okay, 2 equal forces da. So definitely it will be making 30 degree. I mean the resultant vector will be making 30 degree. So obviously it will be upward. Can you find the magnitude of this one? Can you find the magnitude of this one? Yena F oda value vandu, I'll write it over here. K into Q1 na 4 da, Q2 na 2 da, divided by 2 square it will come. So now tell me, what is the answer? Now tell me guys, don't forget to like the session. Very good. We will be getting option A as the right answer. Understood? Give your favorite heart to me. If you understood this question, give me a favorite heart. You can give your favorite heart. We are going back to the electric field again. Okay? Yes. Now we are going for the electric field. Electric field na adu vandu the force experienced at a particular point. Okay, for a unit charge. That is what the only difference. Okay, so it will be, generally I can say that it is nothing but force by charge. So now my question is, there will be 2 charges here, right? We used to say Q1, Q2, correct? So idhula vanda I'm just talking about Q1. Okay, so in the Q1 inala edachu oru point illa. Okay, edachu oru point illa, I need to know and the force oda intensity. Okay, adukku vanda if I am keeping a 1 coulomb charge illana 3 coulomb charge illana 4 coulomb charge na exact ah enakku vanda I cannot find it. So actually vanda what I should do? Yes, definitely ipo vanda indha oru source charge irukke, and the source charge nala experience pandra force intensity find பண்றதுக்கு to any point I will place a test charge over there. What is test charge? Give me, tell me, what is the test charge? test charge na ma'am adu vandu test charge. Okay, so adu vandu unit charge ah irukum. Then also it is not going to be 1 coulomb, it is going to be a very small charge. That is why q tends to 0. So adu vandu small charge da, anta charge vandu we will place it at a point and then we can find the electric field at that point. Due to point charge நம்ம electric field வந்து kq by r square da. And also let us say இப்போ வந்து 2 charges இருக்கு. Okay, in the 2 charges நால at some point it will experience a zero electric field. Okay va, zero electric field. And the zero electric field if you need na, and the one point la you can, if you need to find that na, you can just use this expression. Okay, x is equal to d na and the separation da divided by q2 by q1 plus or minus 1. In the questions one we will do it, so on the time you will get to know. And also ipo vanda I have a positive charge. Okay, I have a positive charge, anga irukkiradhu oru positive field da. Okay va, இப்போ வந்து electric field E இருக்கு, இங்க வந்து ஒரு positive charge Q இருக்கு. அப்படினா if I am talking about the direction, okay, if I am talking about the direction, what will happen? Okay, my question is very simple. On the in the external electric field la I am placing a charge Q, அது வந்து ஒரு positive charge தான். அப்படினா அதில் experience பண்ற force வந்து how you will define that? Will it be in the same direction of electric field or in the opposite direction? Simple இருக்கிற question da. External electric field அங்க வந்து ஒரு charge place பண்ணியிருக்கேன். So அப்படினா இந்த charge will experience a force in the direction of field ah இல்ல opposite direction of electric field ah. Positive charge na definitely it will be along the same direction of electric field ah irukum. Purinjudada? Give me a yellow heart if you understood. Give me a yellow heart if you understood. Tattva material na nama Vedantu oda study material da. Okay, so tell me. Yes, same along the same direction. Now if I am placing a negative charge, okay, I am just placing a minus q charge na, how you will say about the force? Can you please let me know how you will be talking about the force direction? Ipo vandu positive charge ku instead I am placing a negative charge na, what will be? You just check in the description box, you can just see different what is the links, right? Edachu or link la you just click da, definitely you will be getting a call from the Vedantu team. Okay, they will let you know. Okay, please don't spam here da, please unga details idu vandu lecture class illa da. We will again schedule some different sessions for you people. Andha oru session la join panniko, anga vandu you can just ask anything. Okay, illana in the description box la irukna edachu oru link la you just click, definitely you will get a call from this. Okay, yes, definitely what will happen? So ipo vandu what will happen na, when you people are asking something else, I will be get distracted, I will lose the flow. That is why please don't, please, otherwise I'll ignore the whole messages apart from electrostatics. Okay, so please do try to understand. So ipo vandu nama electric field ipdi da irukke, inga irukkiradhu oru positive charge na, nama force will be QE da, and adoda direction vandu same as, okay, same as electric field. இப்போ வந்து the same electric field la I am placing a negative charge na, force oda magnitude வந்து QE da, ஆனா வந்து ஒரு negative charge இருக்கும். ஏனா force வந்து opposite to, okay, opposite to நம்ம electric field da. புரிஞ்சுதா everybody understood? Yes or no? Please let me know. After the session only it will upload da, after the session. Okay, paravilla, so you can just come back after that. Okay, you know, definitely what will happen, we will be switching to different chapters da. By the time when you are coming back you will be getting it. Okay, so now guys, don't forget to like the session. Okay, mood e poichuda, okay, and the flow e poichu. Okay, so yes, so ipo vandu we have to study the different electric fields. Okay va, so ipo vandu oru finite wire irundiruchuna, okay, finite wire na இப்படி தான் நம்ம finite wire இருக்கும். Okay, so இந்த ஒரு point la I just wanted to find the field na, what I will do, I will check the perpendicular distance to that point. Okay, அதுதான் வந்து R. Okay, அதுதான் வந்து R. next வந்து I will be going for finding this angle. Let me just say this is theta 1 and this is going to be theta 2. These are the things, and also nama charge density, nama linear charge density lambda idu kuda you have to, okay, if you know all these things, okay, eppovume while you are studying any equation na adoda diagram illana what is the, I mean each of the term vandu you should know da. Inga vandu paathena k lambda divided by r into sin theta 1 plus sin theta 2 da. So now I am asking you what is r. You should know what is r, okay. What is r? It is nothing but the perpendicular distance from this finite wire to the point where we need to find the field, avloda, okay. And theta 1 and theta 2 we understood from the figure. Understood everybody? Yes or no? Please let me know. Please let me know everybody. Yes or no? Yes or no? Next one, the electric field due to circular arc. Adu vandu 2k lambda divided by r sin theta by 2. Sin theta by 2 na theta is actually and the arc vandu. Ipo vandu if I am just marking, this is how the arc. Appadina idudha vandu nama theta. This is what r, and inda oru arc oda charge density da vandu nama lambda. புரிஞ்சுதாடா? next வந்து நம்ம ring, okay. So ring ஓட what is a field வந்து kqx divided by r square plus x square all to the power 3 by 2. So அப்படினா what is this x? X na nothing but in the center ல இருந்து இந்த axis ஓட axisல தான் ஒரு point we are considering. ஏனா அது மட்டும் தான் syllabusல இருக்கு, okay. Axisல ஒரு point இருக்கு. So definitely what will happen da? So in the center ல இருந்து இந்த p point ல இருக்கிற distance தான் actually வந்து நம்ம x, and in the ring ஓட radius தான் actually வந்து நம்ம capital R, okay va? So kqx divided by r square plus x square all to the power 3 by 2. புரிஞ்சுதாடா everybody? Yes or no? Give me y or n, give me y or n everybody. Everybody, so nama field due to ring vanda expression vanda kqx divided by r square plus x square all to the power 3 by 2 da. So now my question is, at the center of this ring, okay, at the center of this ring, what is going to be the field value? At the center of the ring, what is going to be the field value? Can you please let me know? Can you please let me know? Can you please let me know at the center point la? Center point la, very good, 0. ஏனா x value வந்து 0 இருக்கும், கரெக்ட்டா? X value at the center of the point சொல்லும்போது x value வந்து 0 தான், and we will be putting the x value over there, we will be getting 0. Now another question, okay. இப்போ வந்து இந்த x ஓட value, if this value na definitely நம்ம field வந்து maximum இருக்கும், okay வா? Are you guys getting what I'm saying? Okay, இப்போ வந்து ஏதாச்சும் ஒரு point, okay, I'm just considering நம்ம x, I mean இந்த சென்டர்ல இருந்து இந்த p point வரைக்கும் I'm just considering any point, and at a particular point I'm getting the maximum field, and the value வந்து r by root 2, okay, plus or minus r by root 2. இப்போ வந்து x value வந்து r by root 2 na definitely I will be getting the maximum field. புரிஞ்சுதாடா everybody? Yes, 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 everybody understood? Give me a yellow heart if you understood these fields. Everybody, everybody. Guys, don't forget to like the session, everybody. So this is what the electric field do to different cases. Another thing is nothing but nama spherical shell irukke, solid sphere irukke, okay va? So ipo vanda spherical shell sollumbodhu, what is the meaning of spherical shell? What you will understand, if I am saying spherical shell na, what you will understand, okay, spherical shell, okay, that is nothing but nama holosphere da. Holosphere na ennada? And the inside vanda mass illa, empty da. Mass வந்து எப்பவுமே இல்ல, சார்ஜ் வந்து எப்பவுமே மாஸ் கிட்ட அசோசியேட்டடா இருக்கும், ஓகே. இப்போ வந்து மாஸ் இல்லனா சார்ஜ் இல்ல, இப்போ வந்து மாஸ் இருந்துருச்சுனா சார்ஜ் இருக்கிறதுக்கு சான்ஸ் இருக்கு. அப்படினா டெஃபினெட்லி இப்போ வந்து இந்த ஸ்பெரிக்கல் ஷெல் பாக்கும்போது இன்சைட் மாஸ் வந்து 0 தான். அப்படினா எலக்ட்ரிக் ஃபீல்ட் இன்சைட், what is going to be that value? Electric field inside, what is going to be that value? Everybody tell me. Electric field inside, what is going to be that? Very good, very good. We will be get it as 0. Yes, Yogita, correct, correct. I remember everything, okay. Yes, so now inside வந்து 0 da. Now surface la சொல்லும்போது it is nothing but இப்போ வந்து இதோட இருக்கிற charge q இது வந்து radius r னா it will be kq divided by r square தான். Okay, it will be kq divided by r square தான். And outside வந்து it is again simple kq divided by small r square. So இதுதான் வந்து r. So அப்படினா outside வந்து kq by r square. Next வந்து நம்ம solid sphere தான். இங்க வந்து mass இருக்கு. So அதனால electric field inside will be coming as kqx divided by r square, and surface la vandu same as that kq by r square, outside also same kq by small r square. Understood ada? I have written all the equations here, so you can just take a what to say ஒரு screenshot மட்டும் போதும்டா. So இது வந்து yes, this is going to be cube. Okay, so this is what the important what to say equations. Okay, everyone should study all these important equations. ஏனா வந்து இது பேஸ் பண்ணி we can expect many questions. Okay வா? And next வந்து electric field due to, okay, electric field due to இப்போ வந்து we have discussed onnoda. இப்போ வந்து ஒரு finite wire na and the field order expression what we have mentioned it is nothing but k lambda divided by r sin theta 1 plus sin theta 2. Am I right or wrong? Yes or no? Am I right or wrong? Everybody, this is what I told you na. Ipo vandu if you are what to say distracting me, I will also get distracted. Okay, so please guys, if you are ready to study, please stay back, otherwise please leave the class. It's a request. Okay, please. So now idha vandu nama field order expression, and what we said about this theta 1 and theta 2, this is what theta 1, this is what theta 2. Now I am telling you, let me just increase the length of this wire. What will happen? Theta 1 will increase or decrease? Theta 1 will increase or decrease? Everybody please let me know what I'm just talking about. இப்போ வந்து theta 1 இருக்கேல, இப்போ வந்து if I'm just increasing the length na, what will happen? Theta 1 will increase. இப்போ வந்து இது infinite ஆச்சுனா நம்ம theta 1 ஓட value வந்து 90 degree ஆகும், and here also theta 2 will also come as 90 degree. So what will basically happen? I will be getting an equation sin theta 1 plus sin theta 2. What is going to be that value? Very good Lakshmi, very good Yogita, very good Leksha. Okay, Leksh. Okay, lection are right. Yes, very good. Okay, so definitely idla vanta sin theta 1 plus sin theta 2, sin 90 plus sin 90, it will be coming as 2, which means I'm just going for 2 lambda divided by k in a 1 by 4 pi epsilon naught r ida. Correct? So I'll be getting lambda divided by 2 pi epsilon naught r, or otherwise I can say 2k lambda divided by r. So this is what the infinite what to say wire order electric field order expression. புரிஞ்சுதாடா? Another one is இப்போ வந்து we have a plate. Okay, we have a plate. Okay, so in the plate nala experience பண்ற field order expression, what is going to be that? It is nothing but sigma by 2 epsilon naught. What is sigma? Sigma is nothing but the surface charge density. If you understood all the equations now, everybody should give me a yellow heart quickly. If you understood all these equations, please give me a yellow heart quickly. Everybody. Very good. So now can we move on to the next part? The question part. Ready now? Give me a fire, everybody. Yes, Kutti, yes, Jia, yes, Amiksha, yes, Lakshmi. So now we are moving on to the next question. So let us see what is the first question coming in the electric field. Okay, we did many questions based on the Coulomb's law and everything. Now we are moving on to the yes. So first question. The magnitude of electrostatic force experienced by a charge of 1 into 10 to the power minus 6 coulomb is given as 1.5 into 10 to the power minus 3. Find the magnitude of the electric field at that position. Simple ana or question, correct? Okay, so idhula vanda force is given, charge is given. What is electric field? F by Q. So simple or question, give me the answer quickly. Give me the answer quickly. F by Q will give you electric field, and let me know which is the right answer. Which is the right answer, everybody? Very good, very good. We will be getting option C as the right answer. Now we will be going for the next question. Let us see what is in the next question. At a particular point, electric field depends upon. At a particular point, electric field depends upon. Can you give me the answer? Can you give me the answer? At a particular point, electric field depends upon. What is the answer? A irukku, B irukku, C irukku, D irukku. Which is going to be the right answer? Check again, check again. At a particular point, electric field depends upon. Very good, Yogita. Very good, Padmav. It is nothing but source charge. Yena nama electric field oda expression ennada. It is nothing but KQ by R square. Correct? So Q na enna? Adu vanda source charge da. Correct? Q na source charge da. So definitely this will be at a particular point, electric field will be depending upon only the source charge and also the distance of separation. Okay, and the charge irundhu wherever we need to find the field illada, and the distance, that is what the R. So in the options paakumbodhu you can see source charge Q only. Purinjudada? Give me a yellow heart, everybody. If you understood, give me a yellow heart, everybody. Everybody give me a yellow heart. Everybody. Now we are moving on to the next question. Ready? Ready na? Give me a fire. Yes, perfect, perfect. So we are going for the next question. What is in the next question? Yes, magnitude da we need to find it. Okay, so adukku electric field is given, the distance also given. Okay, so what is the equation we will be using here? What will be the equation? E is equal to KQ by R square da. So E into R square divided by K will give you the Q value. So please let me know which is going to be the right answer for this question. Everybody. Yes. What is the Q value? What is the Q value? Very good, Soumya. Very good. Electric field is nothing but 2 Newton per Coulomb. The R is 60 centimeters. So 60 into 10 to the power minus 2 the whole square divided by 9 into 10 to the power 9 will give you option A, 8 into 10 to the power minus 11 Coulomb. Purinjadada, everybody? Give me a yellow heart, everybody. Now we are going for the next question. I hope everyone is getting. That is why I'm just quickly going. Yes, Rashini. Okay, so இப்போ வந்து பார்த்தேன்னா ஒரு ஸ்மால் ஸ்பியர் இருக்கு, அதோட மாஸ் வந்து 1 கிராம் தான், அதுக்கு வந்து சார்ஜ் கூட இருக்கு. The sphere is suspended on a string of electric field 400 which is acting downwards. Calculate the tension on this string. So let us just understand this scenario. Okay va? So idhula vandu paathena what are the forces acting da? What are the forces acting on this in this small sphere? Can you please let me know the forces acting on it? What are the forces acting on it? Obviously in the string irukadanaala tension irukum and definitely nama mg irukum. Vera edach oru force irukka? Can you please let me know? Any other force here? Please let me know. Any other force here? Any other force apart from mg, apart from tension, any other force? So definitely they have mentioned 400 Newton per Coulomb, electric field is acting downwards. So, appadina downward direction la we will be having another force which is nothing but QE. Appadina tension will be equal to mg plus QE. All the values were given. Mass is given. G you can take it as 10. Q is given and that is 6 into 10 to the power minus 6 and E is nothing but 400. Can you please let me know which is going to be the right answer, everybody? Give me the right answer for this question. Which is going to be the right answer? Very good, Yogita. Yes, we will be getting option A as the right answer. Unit conversion is very important in this case. You can see 1.24 into 10 to the power minus 2 is there, minus 3 is there. If you are not converting the unit, you will be getting the wrong answer. Inga vandu 1 gram da, adu vandu you have to convert into kilogram. Purinjudada, give me a fire if you understood. If you understood this question, give me a fire, everybody. Everybody give me a fire. Now we are going for the next question. Okay. So, two charges irukku, 1 microcoulomb and 2 microcoulomb and placed at 10 centimeter apart. What distance in centimeter from the 1 microcoulomb charge is the electric field 0? So, inga vandu paathena 1 microcoulomb is here, 2 microcoulomb is here. Okay va? Ipo vandu like charges na definitely vandu this will be in between the two charges. Let us say it is both are positive charges or both are negative charges na definitely this will be in between. Namma what to say? Thank you so much for the fires da. So, இப்போ வந்து பார்த்தேனா in between the point லதா இந்த null point இல்லனா நம்ம field வந்து 0 ஆக போறோம். கரெக்டாடா? இப்போ வந்து unlike charges na it will be obviously outside this two charges ஆ இருக்கும். கரெக்டாடா? அப்படினா now the thing is like I'm just taking this distance as x. Okay? ஏனா they have asked from 1 microcoulomb. So, I'm just assuming this is what the x distance. So, now tell me what is going to be this distance. Can you please let me know? What is going to be this distance? Everybody please let me know. And the over distance one, can you please let me know? Total one they have given 10 centimeter and the unit conversion is not required in this case. Okay. Very good, Padmav. It is nothing but 10 minus x. So, null point. Okay. If I'm saying in the over point, let me say in the over point, electric field one the 0 na, in the 1 microcoulomb nala irukra field and this 2 microcoulomb la irukra field வந்து it should cancel each other. Correct? Which means இது வந்து equal and opposite ஆ இருக்கணும். So definitely tell me what is the field due to 1 microcoulomb at the point A? Can you please let me know? Can you please let me know? இப்போ வந்து 1 microcoulomb charge இருக்கு. I wanted to find the field at A. அப்படினா tell me what is the field due to 1 microcoulomb. So K into நம்ம source charge na 1 into 10 to the power minus 6 divided by x square. Understood till? Please give me a yellow heart, everybody. Everybody till understood na give me a yellow heart. Quickly you can give. Okay va? Next is in the 2 microcoulomb nala in the A point la experience pandra electric field da find pannanom and that should be equal to this and opposite to it. Correct? So K into 2 into 10 to the power minus 6 divided by 10 minus x the whole square. Okay vada? Next step is nothing but K irukka 10 to the power irukka, K irukka 10 to the power irukka. I have cancelled everything. Okay? So next step பார்த்தேனா இங்க வந்து 1 by x square இருக்கு, இங்க வந்து 2 by 10 minus x the whole square இருக்கு. I'll be doing one thing. I will just find the square root on both the sides. So I'll be getting 1 by x which is equal to root 2 divided by 10 minus x. So இதில இருந்து can you find the x value? Can you find the x value? Root 2 ஓட value என்ன? What is root 2 ஓட value? Everybody please let me know. Everybody please let me know. Thank you guys. Thank you for the whole hearts. Everybody. Very good. Now find what is the answer for this question. Yes, 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 yes. Very good, Praveena. Very good, Yokita. Very good, Divya. Yes, 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 Lakshmi. Of course, da Lakshmi. Okay, you guys have to. Lakshmi, Ravi, I have to specify. Okay. So please, நீங்க வந்து ஸ்டார்டிங்ல இந்த செஷன்ஸ் வந்து பார்க்கணும்ல. Every time we can't just say the same things. It will be boring for the other students. So that is what the reason. Okay. Please do try to attend from the beginning. Clear in the beginning la I'm telling all those things, right? So option C da vanda நம்ம right answer. Can we move on to the next question? Give me a fire if you're ready for it. Everybody give me a fire if you're ready for it. Perfect, perfect, perfect. Yes, everybody got the answer. And do try to do the calculation. Don't use the calculator, don't use the Google and all the other resources. Please do try to do by yourself. ஏனா இது வந்து practice time. Okay va? So ivlo students irukke, so this is going to be little competitive. So that will give us more energy. So please utilize this time da. And also idhula vande what you can understand. Okay, ipo vande enakku vande I am taking this much of time. Ana vande 10 students vande enna vida faster they are doing. And the idea you will get it na. So can we go for the next question? Simple or question we can do it da. Okay, and guys don't forget to like the session. Yes, let us do this question. Let us do this question. Everybody. Simple, again, very simple question. What is the equation we can use it here? Can you please let me know? Which equation we can use it here? Which equation we can use it here? Everybody. Yes, tell me what is going to be the answer for this question then. A, B, C, D, which is the right answer? Very good, very good. We will be getting option B. K cube by R square da. All the values were given. Only the unit conversion is required. 80 centimeter da. That we need to change. Purinjidada everybody. Let us go for one more question from this field. The question there is a problem and the answer is already there. Okay. So let us do it. Two parallel infinite line charges. Okay, infinite line charges. So, this is the line charges. Okay, this is plus lambda da, and this is going to be minus lambda. Okay, va? Are placed at a distance 2r in free space. What is the electric field midway between them? So, this is 2r da. So, we need to find the field at this point and the distance will be obviously r. Correct, Ada? Yes or no? So, now this is what we got it. Correct? So, first of all, I just wanted to mark the field order direction. Field order direction is a positive charge. Okay. So, obviously, what is going to be the direction? In the point I will be keeping the test charge. Test charge na adu vandu positive da. So in the positive and this positive. So how will be the direction of field? Towards this right side or towards my left side? Can you please let me know? Towards my right or left? Please let me know. Please let me know what is going to be nama field order direction. Due to this plus lambda. This is the test charge, this is the positive charge da. Plus lambda definitely that is also going to be very good, very good. We will be getting this direction. Okay, due to nama plus lambda. Now it is the turn for minus lambda. Minus lambda irukke, q naught irukke. Minus lambda this is minus q da. Minus q and nama positive test charge. Again I am going to ask you towards my right side or towards my left side. Nama field order direction. Field order direction towards right or left. Yena idu q da negative da. Idu test charge adu positive da. So again that will be coming as positive. Okay, Vada. So right now, what the thing? We will be finding this two fields, E1 plus E2. We will just add it. Magnitude will be same, correct? Magnitude will be same. Why it is coming as same? Distance of separation. Nama perpendicular distance the same for both the cases. And nama magnitude of charge kuda same da. Illana linear charge density. So lambda by 2 pi epsilon naught r plus lambda by 2 pi epsilon naught r it will come. So can you find the answer for me? Can you just tell me? Everybody? Yes, very good, very good, very good. Everybody, please let me know the answer for this question. Yeah, I'll show you. Okay. Tell me what is the answer. Very good, da. We will be getting option B as the right answer. Very good. So now we are moving on to the another set of this chapter. That is nothing but nama potential. Ready, Ada? Ready na? Give me a fire, everybody. Potential, ma'am. Potential ki nama vanda ready da, ma'am. Okay. So tell me. Give me a fire if you are ready. And guys, drink some water in between. Yes, set. So now potential. What is the potential? That's first I wanted to know. Okay, can you please let me know what is potential, ma'am? Potential na idudha. Okay, appadina what is that? So ipo I'm just bringing a unit test charge. Okay, anga oru infinity la test charge irukku. And the test charge I am bringing towards another charge. Okay, inga another oru charge irukku. Let me call it as capital Q. Okay, in the capital Q order nearby I am bringing another charge. அதுக்காக I should do some work, right? I should do some work. அந்த இன்ஃபினிட்டியில் இருக்கிற டெஸ்ட் சார்ஜ் I need to take it here. கரெக்டா? அப்படின்னா I should do some work, right? அந்த work divided by unit charge. இல்லைன்னா அந்த work done per unit charge தான் ஆக்சுவலா நம்ம potential. புரிஞ்சுதாடா? Understood, everybody? So definitely and the infinity if I am bringing a charge closer to another charge, so the work done I have done divided by the unit charge. Very good Padma, very good Yogita, very good. So right now I'm just talking about potential energy. Okay, in the statement mattum you have to study da. Okay, just study this will help you in all the cases. Okay, this will help you in all the cases. So right now just understand the work done. Okay, the work done against any, okay, the work done against any conservative force is stored as the potential energy. Okay, stored as the potential energy. So அப்படினா இந்த ஒரு கேஸ்ல we know that conservative force நம்ம இந்த சாப்டர்ல இருக்கிற conservative force என்ன? It is nothing but நம்ம electrostatic force தான். Okay, electrostatic force தான். அப்படினா I can say that the work done against electrostatic force is stored as the electrostatic potential energy. புரிஞ்சுதாடா? Yes or no? Please let me know. Everybody tell me. So the potential energy, I can say that the work done by the conservative force, which means in the case work done by electrostatic force. Understood or not? Yes or no? Please let me know, everybody. Okay, important ஆன ஒரு statement தான். ஓகேவா? இந்த potential energy per unit charge தான் actually நம்ம potential. Okay, so potential energy சொல்லும்போது whenever we are doing any work against conservative force, அதுதான் potential energy. இந்த chapterல specifically சொல்லும்போது it is nothing but the work done against electrostatic force. அப்படினா அதுதான் நம்ம potential energy per unit charge தான் நம்ம potential. Everybody understood? Give me a yellow heart if you understood. So this is the very important statement. And now let us say இங்க ஒரு charge இருக்கு Q1, நம்ம infinity ல தான் நம்ம Q2 இருக்கு. Okay va? நம்ம இன்ஃபினிட்டில பொட்டென்ஷியல் எனர்ஜி இல்லனா பொட்டென்ஷியல் வந்து எப்பவுமே 0 தான். Okay, it will be எப்பவுமே 0 தான். So when I am bringing this charge towards here, this is at a distance r. Right now q2 ஓட position தான் இது. Okay va? So இதுக்காக I should do some work, right? In the q2 to bring at this point I have to do some work. அந்த ஒரு work தான் actually வந்து potential energy. So அந்த potential energy I will write it as k into q1 q2 divided by the distance of separation. And in the ஒரு q2, okay, if q2 is the unit positive test charge, then this potential energy will become potential. Okay, then this potential energy will become potential, which means in the u become v if I am bringing and the q2 வந்து நம்ம test charge na definitely in the potential will become potential energy will become potential. Understood? Please give me a fire, everybody. Everybody give me a fire if you understood till this. Everybody. I want more fires. I want more hearts if you understood this thing. Okay, so this is what the potential and this is what the potential energy work done to bring a unit positive test charge from infinity to a particular point da nama potential. And in the potential for different cases we have to study. Okay, so potential for the ring, it will be coming as kq divided by r square plus x square all to the power 1 by 2. Okay va? And due to a point charge it will be kq by r. Okay, and also you should study about the what to say shell. So shell oda inside la எப்பவுமே அது வந்து கான்ஸ்டன்ட் ஆ இருக்கும். ஏனா field வந்து 0 தான். அப்படினா potential வந்து constant ஆ இருக்கணும், and that will be same as at the surface. So which will be coming as kq divided by r, and surface la it is again kq by r da. Outside சொல்லும்போது அந்த capital R it will be replaced as small r. Okay, and solid sphere oda I have mentioned over here, இது வரதுக்கு chance வந்து கம்மி தான். You have studied everything. அதுக்கு அப்புறம் உங்களுக்கு வந்து time, okay, எனக்கு வந்து again I have little bit more time ma'am. அப்படினா you can just study these equations as well. Okay vada? And also another important relation connecting nama field and potential vandu E is equal to minus dV by dr. Okay, another important concept which is coming as sharing of charges ida, which means we know that whenever we are keeping two bodies together, okay, இப்போ வந்து இந்த two bodies இருக்கு, அதுல வந்து charged bodies தான். இப்போ வந்து if I am just bringing them together na definitely அங்க ஒரு charge flow இருக்கும், கரெக்ட்டா? அந்த charge flow, okay, அந்த charge flow will continue till, okay, அந்த charge flow will continue till the potential remains same. So அப்படினா after some time till the potential remains same, each of this will be getting some charge, and the charge oda value da inga vandu written பண்ணிருக்கேன். Okay, capital Q1 and capital Q, what is that? Capital Q1 and capital 2. Very good kutti. Yes, along the electric field potential will decrease. Adha vandu in the equation la we will get to know. Now my question has been changed. Okay, charging. Okay, இப்போ வந்து two bodies இருக்கு. Okay, so அந்த two bodies வந்து whenever we are keeping it together, definitely அங்க ஒரு charge flow இருக்கும் till the potential remains same. So after that what is going to be the charges on both this what to say bodies? இதுதான் வந்து question. அப்படினா you can just use this equation. Capital Q1 and capital Q2 na initially before coming into contact, okay va? So இப்போ வந்து individual இருக்கிற அந்த டைம்ல இதுக்கு இருக்கிற சார்ஜ் தான் Q1, capital Q1, இதுக்கு இருக்கிற சார்ஜ் தான் capital Q2. இதுக்கு அப்புறம் தான் we are just bringing them together. So total charge into R2 divided by R1 plus R2 will give you the charge later after this contact. What is the charge on the second sphere one, you will be get it like this. If you need to find Q1 na, this you can replace it as Q1 plus Q2 into R1 divided by R1 plus R2. In the equation you can study da. Yena many times they have directly asked this. So to derive all those things will consume a lot of time. So please study these equations immediately. Purinchidada everybody? Yes or no? Yes or no? Please let me know. Please let me know. yes. Okay, so next one வந்து நம்ம equipotential surface தான். Okay, equipotential surface. Equipotential surface சொல்லும்போது definitely equipotential surface அந்த surfaceல இருக்கிற ஒவ்வொரு பாயிண்ட்லுமே நம்ம potentialோட வேல்யூ வந்து சேமா இருக்கும். ஓகேவா, பொட்டென்ஷியலோட வேல்யூ வந்து சேமா இருக்கும். அண்ட் ஃபீல்ட் அண்ட் இந்த equipotential surface வந்து எப்பவுமே perpendicular to each other இருக்கும். அண்ட் இந்த ஒரு equipotential surfaceல இருந்து if you are trying to bring one charge from one point to another point na potential remains same நால what is going to be the work done da? If in the equipotential surface la I'm taking one charge from one point to another point na definitely அங்க ஒரு work done இருக்கும்ல, so அதோட வேல்யூ என்ன ஆகும், 0 ஆகும். ஏனா வந்து q into delta v தான். so இந்த கேஸ்ல delta v னா 0 தான். புரிஞ்சுதாடா? so next one வந்து இந்த two equipotential surface வந்து it will never ever intersect each other. and point charge க்கு வந்து equipotential surface ஓட shape வந்து concentric spheres ஆ இருக்கும். and line charge க்கு வந்து coaxial cylinders தான். and long sheet க்கு வந்து parallel plates தான். Understood? Are you people are feeling hungry? Should we go for a lunch break right now? Or can we do some questions? Please let me know in the chat box. Please let me know in the chat box, everybody, what we should do right now. Lunch break illa can we just go with the questions? Questions definitely. So let us go for the first question. Ready na? Give me a fire. Yes. So now we are moving on to the first question. Write the potential energy of the, yes, everybody is on, but I don't know why you people are not attending the session. Okay, don't think like, okay, a few questions will give you some marks. Just you should revise the concept. எனக்கே தெரியும் அந்த again to revise the concepts எல்லாமே வந்து கொஞ்சம் difficult தான். ஆனாலும் we have to do this da. Okay, write the potential energy of the system. So potential energy சொல்லும்போது இங்க வந்து 4 charges தான் இருக்கு. So how many pairs it will be there? அதுக்கு வந்து we can just use this equation n into n minus 1 divided by 2. 4 charges now, 4 into 4 minus 1 by 2. So what is going to be this one? So 4 into 3 by 2. So this will be coming as 6. Correct? So now 6 pairs should be there. Definitely, visibly we can say this is the first one, this is the second one, this is the third one, this is the fourth one, this is the fifth one, and this is the sixth one. Understood till this? Yes or no? Understood till this? Yes or no? Please let me know, everybody. Understood these pairs? Yes or no? Yes or no? Please let me know. Now we have to find the potential energies. Okay, wow. So now let me just focus on this one. Okay, இங்க ஒரு plus q and minus q இருக்கு. Potential energy and potential வந்து scalar இல்ல vector ஆடா? Scalar or vector? Scalar or vector? Potential energy and potential வந்து scalar தான், no issues. So let me call this as u1. So tell me now what is u1? What is u1? So k into plus q into minus q. So I can just write minus q square divided by r. Am I right or wrong? Am I right or wrong? Very good da Padma, very good Divya. So it is actually scalar da. Now this pair, what is going to be that u2? K into minus q will be plus q square. Distance of separation again same r. Another one is here. Okay, another one is here. Minus q and plus q again. So it will be same like here. Okay, u1 and u2 will be same da. Okay, இது வந்து u3. இது வந்து u3 தான். ஓகேவா? So இது வந்து same as u3 தான். Minus kq square divided by நம்ம r தான். Again this is what u4. Okay, this is what u4, which will be same as u2. ஏனா kq square. Okay, plus q into plus q again it will be coming as kq square divided by r. Till this understood, give me a yellow heart, everybody. Till this understood, give me a yellow heart, everybody. Everybody give me a yellow heart quickly. Everybody. Yes, perfect. So அப்படினா now the thing is like we have two more potential energies, but just understand இதோட I mean u1 plus u3 வந்து minus 2kq square by r தான். U4 and U2 வந்து KQ 2KQ square divided by R இதா. Can I say that இதோட sum வந்து 0 ஆக போரும்? Correct? Now I wanted to know the potential energy due to this one. Let me call it as U5. What is U5? What is U5? And the fifth systemத்தினால I can say it as minus KQ square. What is the distance of separation? What is the distance of separation? Can you please let me know? It is nothing but root 2 R da. Correct? It is nothing but root 2 R da. Next one is nothing but nama U6. Okay, U6. Tell me what is the expression for U6? Can you please let me know the expression for U6? What is going to be that? Inga irukkiradhu oru minus q, inga irukkiradhu plus q. Appadina minus kq square divided by again distance of separation vandu root 2 r da. Now the thing is like you have to find the total potential energy which will be U1 plus U2 plus U3 plus U4 plus U5 plus U6. Okay, so now I'm substituting those values. KQ square divided by R plus KQ square divided by R minus KQ square by R minus KQ square by R plus, not plus, okay, KQ square divided by root 2 R minus KQ square divided by root 2 R. Can you please let me know what is the answer for this question? Can you please let me know the answer? Can you please let me know the answer? Everybody tell me. Very good, very good, very good. We will be getting option C as the right answer. Understood everybody? Please let me know. Are you guys feeling confidence in the potential energy question? Please let me know da. Otherwise we can just go for another question. We are going for the next question. Okay. So the interaction energy change of the system if 2q charges moved from A to O. Okay. So initially vandu idudha vandu nama system. Okay. Initially idudha vandu nama system. Okay. After that what happened? I'm just bringing this 2q over here. So what is going to be the potential energy or a change? Let me just call this as U1 and for this system it is U2. So basically speaking we should find U1 minus U2 the actual one we need to find it. Can we go for it? Can we go for it? Ready? Give me a fire if you are ready for it. Give me a fire if you are ready for it. Everybody give me a fire. Please everybody. Yes, perfect. So appadina first case la potential will be due to this plus q as well as this q. Correct ada? The interaction energy. Okay va? So now you have to find the potential energy due to this three charges. Three charges irundiruchuna definitely anga vandu evlo terms irukumda. Evlo terms irukum. Definitely we can go for 3 into 3 minus 1 divided by 2. So appadina we will be getting 3 terms should be there. Correct ada? And also in the distance of separation idu vandu 4 da, idu vandu 3 da, appadina this is going to be 5. Correct ada? So definitely I can say that the initial potential energy vandu K into 2q square divided by 5 plus we will be having this two charges is there, right? So kq square divided by 8. Correct? Plus 8 into 2q square divided by 5 again. Understood till this everybody? Understood till this everybody? Please let me know. Give me a yellow heart if you understood till this. So இப்போ வந்து initially இருக்கிற ஒரு சிஸ்டத்தோட, okay, initially இருக்கிற சிஸ்டத்தோட total potential energy தான் நம்ம வந்து find பண்ண போறோம். So இதில் வந்து பார்த்தேன்னா இந்த QQ will be having potential energy, in the Q and 2Q will be having a potential energy, in the Q and 2Q will be having a potential energy. That is what I have written over here. Now coming to U2. So what will happen there? I have, okay, in the Q and 2Q nala, okay, so K into 2q square divided by, in this distance one the 4 da, it will be having 4. Okay, next plus in the q and that q, so which means kq square divided by 8 again it will come. Okay, again plus k into 2q square divided by 4. Till this understood? Okay, so in the both the system nala we understood potential energy inga vandu 3 charges oda we have mentioned over here. Here also q, 2q, q and 2q. So in the madri 3 pairs irukum. So we have written everything. Now it is the time to subtract both the part and tell me what is going to be the right answer. Tell me what is going to be the right answer. So, in the kq square by 8 will be cancelled from both the sides. So, on the u1 we will be having 2k 2q square divided by 5 will be there, and u2 will have 2k 2q square divided by 4 will be there. Subtract and tell me what is going to be the answer. Everybody. Very good, Samiksha, very good. Very good. Others? Just you need to subtract u1 minus u2. Very good, Lakshmi. Others, I'm just waiting for your response. Yes, Lakshana. Yes, Divya. Yes, Hajir. Very good. So we will be getting option A, kq square divided by 5 as the answer for this case. Let us go for the next question. Ready, Ada, everybody? Everybody is ready? Yes or no? Okay. So, இங்க வந்து பார்த்தேனா we have 3 charges, minus q இருக்கு, plus q இருக்கு, plus q இருக்கு. Okay, va? Placed at the straight line. இங்க வந்து they have given the figure also. If the total potential energy of the system is 0, then what is going to be q by q? So, very simple. Let us write the potential energy. So, what is going to be the potential energy? K into, in the minus q and plus q. So, minus q divided by x plus in the q and that plus q. So, again my plus is not required. I can just keep the minus. K q square divided by, it will be 2x. Again this q and that plus q. So, that will be coming as k q square divided by x. What is the value? What is the value? This will be coming as 0. Correct, Ada? So, now the thing is like, you can just find, okay, you can just find q by q ratio. What is going to be that? Can you please let me know? So, we will be getting minus kq by x minus kq square divided by 2x, which is equal to 0. So, appadina minus kq divided by x, which is equal to kq square divided by 2x. So, k will be gone, 1q and this q will gone, x will be gone. Now, you can just take the ratio and tell me which is going to be the right answer for this question. Everybody. What is going to be the answer for this question? Sorry, I have written it wrong. Correct. Sorry. Okay. So, here we have kq square. Another one is having k into this q. I have written this small q square, which is going to be wrong. Divided by x. This is equal to 0. Okay. So, now you can just find out. Now you can just find it out. Minus kq divided by x minus kq divided by x minus kq square divided by 2x. What is going to be the answer? Yes, Padma, very good. Others, you can give me the answer quickly. Yes, everybody is getting option C. So we can just go for option 4 as the right answer. Now, let us go for the another question. Okay, a globe is fitted with identical charged particles of charge Q on the equator at an angular separation of 30 degree. The radius of the globe is given as R. Find potentials at the north pole of the globe. This is the question. So just try to understand or just try to visualize what is happening. Okay, so now this is what the globe. Okay, and here we have the equator. Okay, here we have the equator. So now what they are saying, 30 degree angular separation we have placed the charges, correct? Appadina my question is total 360 da. Appadina how many charges will be there? How many charges will be there? Can you please let me know? Now, on the globe, on the equator, we placed some charge. Okay. Over charges, 30 degree angular separation. How many charges will be there? Can you please let me know? Everybody. Can you please give me the number? Can you please give me the number? Everybody. What is going to be the number I want? Very good, Samiksha. It will be coming as 12. Very good, very good, very good. Okay, super. Okay, so right now we are going for the, okay, we understood this is coming as 12. Okay, this is coming as 12. So right now the thing is like, we know potential order expression and it is nothing but KQ divided by R. Okay, idhila K value is fine, Q value small q da. Next step is what is R? Over charge in the north pole varakku distance actually we need it. How we will be finding that distance? Okay, how we will be finding that distance? Okay, so this is how the globe is, and here is our equator. So now this is what the center portion. This is going to be capital R. This is again going to be our radius capital R, and we need this distance. What is going to be that? What is going to be that? Can you give me the answer? So this is going to be in the equator we need to find this distance. So we know that towards the center this is going to be radius, and over a point this is also coming as radius. So definitely this length will be the distance of separation. I can say that this is nothing but root 2r. So I will be going for KQ divided by root 2r as the potential due to 1. Appadina we have 12 such kind of potentials. So 12 into KQ divided by root 2r will be the answer for this question. Purinju that everybody? Yes or no? Please let me know. Everybody please let me know. Everybody please let me know. Quicka you can just let me know. Very good, very good. So now let us go for another simple question. Okay, two plates irukku 2 centimeter apart tha, potential difference 10 volt da. The electric field between the plate, which equation we can use it here? Electric field between the plate, which equation we can use it here? Two plates da irukku, 2 centimeter da distance of separation. Potential difference is also given 10 da. Appadina electric field order expression, it will be coming as dV by dr. In the case I am just going for, yes, very good Hajar, very good. So which is going to be the right answer? Tell me which is going to be the right answer? Which is going to be the right answer? Very good Abhinaya, very good Saumya. Yes Rida, very good. Sia. Think about the units. 2 centimeter da given. 2 centimeter it is given. So you have to convert. Okay. V it is nothing but 10 da. divided by 2 into 10 to the power minus 2 it will come. So which is going to be the right answer? Don't forget about to convert the units, okay? Equation whatever you have said is correct, but definitely the final answer should be, unit should be converted. So we will be getting option B as the right answer. Now let us go for the next question. Again, which is the equation? Which equation we can use it here? Which equation we can use it here? So potential is given, field at x is equal to 1 meter. We can go for electric field which is equal to minus dV by dr da. So differentiate and tell me. So instead of r you can go for x. It is the variable of x or a variable da. So tell me what is going to be the answer. Everybody tell me. Everybody tell me which is going to be the answer. Everybody. Yes, we will be getting option A as the right answer. Purinchidada everybody, give me a fire if you understood this one. Simple or question, just we need to know the differentiation part. The rest is all cool. Can we move on to the next question? Ready? Yeah? Yes. Perfect, perfect. Thank you so much for the fireflies. Okay. What will be the work done on moving a charge 5 microcoulomb from point A to B? Okay, A to B da we need to find it. Okay, so this is what A, this is what B. So which equation we can use it here? We know that work done is nothing but charge into delta V da. So Q into V2 minus V1, or let's say VB minus VA. Okay, from A to B, right? So Q order value one the 5 into 10 to the power minus 6, and B one the 2 and 5 one the, sorry, V1 one the 5 da. So tell me which is going to be the right answer. Give me the right option. Yes, 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 yes. Very good. We will be getting option C as the right answer for this question. So, we can just do one more question. Adhikapuram we can just go for the lunch break. Okay. Determine the electric field strength vector if the potential of the field depends upon x and y coordinate. Again, we will be going for electric field which is equal to minus dV by dr. So, இப்போ வந்து பார்க்கும்போது we can just see that minus dou v by dou x I cap plus dou by dou y j cap. Correct? Okay. So this is what you need to do. First one, you have to go for dou by dou x of v. Then you have to go for dou by dou x of, sorry, dou by dou y of v. Then tell me which is going to be the right answer. Do it again, Hajir. Do it again. Samiksha, do it again. Yes, Soumya, very good, very good, very good. Yes, perfect. So we will be getting, while we are differentiating, we have V as 2x square minus 2y square. So dou v by dou x will be coming as 4x minus 0. Dou v by dou 2y square will be coming as 0. Next is dou v by dou y, which will be coming as minus 4y. Okay. So you will be substituting these values and you will be getting the answer. Hence option C will be the right answer. So now we are going for the lunch break. Okay. Adhikapuram we will be starting with the Gauss's law and all those things. Okay. So now tell me how much time you guys need it. When we can just meet again. Everybody tell me. Yes, partial differentiation. Yes, 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 exactly. 20 minutes. Okay, so can we just come by 1:20? Okay, Yes, we can just come back by 120. Okay, I want you people to be here. I want everyone's attendance, then only I will be going for the class. Okay, otherwise I'll just finish it. Okay. So see you guys. We will be just continue with Gauss's law. See you, da, bye. Hello, hello everybody. Am I audible? Hello everybody. Are you guys here? Yes or no? Everybody please let me know. Your attendance is very important, guys. So I was thinking like, why should I chat in the, chat box? I can come here and I can talk, right? Yes, we are here. Yes, Kritika. Yes, Soumya. Yes, perfect, perfect. So we can just continue with the Gauss's law. I didn't had anything. It's actually on the way. I should wait for some more time. But I felt like in the next break I can. So everybody had lunch, right? That's just special, anything? Anybody? Anything special? Good afternoon, Nirmala. Good afternoon. But Nirmala's name is something different. I know you have reminded me someday, but I forgot. I'm sorry. Thank you. Oh my God, Praveena, same pinch. Let us have it for the next break. Yes, Dhanushia. Yes. So let us continue, da. Are you guys ready? Ready, everybody? Ready na? Give me a fire, everybody. Everybody give me a fire if you're ready for it. If you're ready, give me a fire. Quicker, you can give me a fire. Hey, this is very slow. This is energy kadakkalada. Only this many people are there. What about others? Yes, Ojal. Yes. I do remember. But I will again make the mistakes. Again, I will forget. Where is the fire? Is it something coming from here? Another one is coming from here. Quicker, you can give me some fire, right? Let me get some energy. Otherwise, the class is going to be quite boring. Because I've told you in the marathon session, actually, I have expected many more students. Okay, 1 second. 1 second, guys. Okay. Yes, thank you so much, da. Thank you so much. So let us just continue. So now we will discuss Gauss's law. So tell me what is Gauss's law. Thank you so much. Okay. Yes, thermal energy of photon is overloaded. Okay. I'm going to escape from here. Yes. Okay. Yes, da. Actually, that is what disappointing me, Gautam. You people are not attending. Meanwhile, this got stuck. 1 second, da. 1 second. Everybody just give me a second, da, because this is not working. It's got stuck. Okay, anyway, let us just continue. Let us see. Today nobody will be here also. Okay. So let us just continue with the Gauss's law. So Gauss's law la actually we know that we should know about the flux. What is flux? Flux na it is actually நம்ம electric field lines da. Okay. ஆனா அந்த field lines la கொஞ்சம் ஒரு சேஞ்ச் இருக்கும். ஓகே, அந்த ஃபீல்டு லைன்ஸ் ஷுட் பாசஸ் த்ரூ த சர்ஃபேஸ். இந்த சர்ஃபேஸுக்கு பெர்பெண்டிகுலராக பாஸ் பண்ணணும். அப்படின்னா மட்டும்தான் we will call it as what? We will call it as flux. ஓகே, ஃப்ளக்ஸ்னா ஃப்ளோ தான். இங்கே வரும்போது ஃப்ளோ ஆஃப் எலக்ட்ரிக் ஃபீல்ட் லைன்ஸ் தான். ஆனால் அந்த ஃபீல்டு லைன்ஸ் ஷுட் பாசஸ் பெர்பெண்டிகுலர் டு த பிளேன்னா we can say that definitely this is nothing but yes. Hi Sanjeevani. Yes, so this is nothing but the electric flux. So on the flux order equation da E dot A, it is depending upon three factors. First is electric field, second one is area, and third one is in the electric field and the area vector make pandra on the angle illiyada. It is depending upon these factors. Purinjidada? So now tell me, now you guys have to tell me what is the, okay, what is the, what is in nama area vector order direction. How we will define the area vector order direction? Can you please let me know? Can you please let me know? எனக்கு வந்து chat அங்க கிடைக்கல, ஏதோ ஒரு ஸ்டக் ஆச்சு, ஏதோ ஒரு ப்ராப்ளம் இருக்கு. Okay. Can you please let me know what is going to be the direction of area vector? It is nothing but perpendicular to the surface da. Correct? It is nothing but perpendicular to the surface da. Purinjidada everybody? So எப்பவுமே you can just say that the flux will be nothing but E dot A da, which means EA cos theta. EA cos theta சொல்லும்போது we can say that theta is nothing but the angle between electric field and the area vector. Area vector வந்து எப்பவுமே perpendicular to the field ஆ இருக்கும். புரிஞ்சிடுச்சுனா give me a yellow heart quickly. Till this understood, give me a yellow heart. Everybody give me a yellow heart. Okay, so இப்போ வந்து இந்த electric field வந்து okay non uniform electric field னா ஒவ்வொரு பாயிண்ட்லயுமே ஃபைண்ட் பண்றது வந்து கொஞ்சம் டிஃபிகல்ட் தான். அது வந்து ஓவர்கம் பண்றதுக்கு தான் ஆக்சுவலா வந்து நம்ம Gauss's law இன்ட்ரோ듀ce பண்ணியிருக்கேன். மறக்காம லைக் பண்ணிக்கோட everybody. So அந்த Gauss's law என்ன? இந்த லெஃப்ட் ஹேண்ட் சைடுல நமக்கு இருக்கிறது ஃப்ளக்ஸ் தான். ஃப்ளக்ஸ்னா என்ன? closed integral E dot ds. Okay, and right hand sideல it will be nothing but q by epsilon naught. q னா அந்த ஒரு Gaussian surface இருக்கிற total charge தான் நம்ம q value. So in the total charge enclosed in the Gaussian surface divided by epsilon naught தான் நம்ம flux ஓட value. So we can say that the flux closed integral E dot ds, which will be equal to the charge enclosed divided by epsilon naught. And in the applications of Gauss's law இருக்கிற electric fields எல்லாமே வந்து we already discussed previously. இந்த electric field topic வந்து discuss பண்ண pointல we have discussed everything. புரிஞ்சுதாடா? So right now நம்ம Gaussian surface ஓட கொஞ்சம் properties எல்லாம் கொஞ்சம் misunderstanding இருக்குல்ல. So அதுதான் வந்து actually வந்து I have written over there. So you should understand each and every point. So right now the thing is like this, every student, okay, எப்பவுமே whenever we are doing questions na students வந்து கேக்குற ஒரு கேள்விதான், மேம் Gaussian surface ஓட ஏரியா வந்து it is very important மேம். இல்லடா, ஆக்சுவலா வந்து Gaussian surface னா அது வந்து you can just choose any shape, any volume, anything. ஆனா வந்து ஒரே ஒரு கண்டிஷன் தான் இருக்கு, அது வந்து க்ளோஸ்டா இருக்கணும். அண்ட் ஆல்சோ செகண்ட் பாயிண்ட் இஸ் நத்திங் பட் க்ளோஸ்டு மட்டும் இல்லை, அது வந்து 3 dimensional இருக்கணும். ஓகே, அண்ட் யூ கேன் சூஸ் எனி ஷேப், யூ கேன் சூஸ் எனி சைஸ், எனி திங். ஆனா வந்து the problem is we know that எதுக்கு we are using this Gauss's law. Gauss's law எதுக்காக we are using that? Can you please let me know? எதுக்காக we are using the Gauss's law? Gauss's law யூஸ் பண்றதுக்கு ஒரே ஒரு ரீசன் தான் இருக்கு, இந்த எலக்ட்ரிக் ஃபீல்ட் ஈஸியா ஃபைண்ட் பண்ணணும். கரெக்ட்டா? இப்போ வந்து எஸ் ஐ வாண்டட் டு டேக் a random shape அப்படினா அதோட ஏரியா வந்து நீங்க வந்து ஃபைண்ட் பண்ணணும்ல. So that is what the problem. புரிஞ்சுதாடா? So Gauss's lawல it is not it is not something you have to be careful about. இப்போ வந்து நம்ம லீனியர் infinite wire ஓட length find electric field find பண்ணும்போது மேம் எனக்கு வந்து I just wanted to take a random shape. You can take it, ஆனா வந்து how you will be solving it? ஒரு problem வந்து solve பண்றதுக்கு இல்லனா ஈஸி ஆக்குறதுக்கு தான் we have done all those things. Again we cannot make it complicated. Let us do some questions. Ready ஆடா? Let us do some questions. நம்ம first question இங்கே இருக்கு, so you can just let me know the answer for this question. Quick, give me the answer for this question, da. Quick, give me the answer for this question, everybody. Think and tell me what is going to be the answer. Very good, Soumya. Yes, very good, very good. We will be getting 0. What is the reason? இப்போ வந்து field lines is entering into the surface na அது வந்து negative da. Okay, field is coming. Okay, sorry, நம்ம field lines is coming inside na நம்ம flux வந்து negative da. It is going out na it is actually plus da. So இப்போ வந்து பார்த்தேனா when it comes to when it is entering into the Gaussian surface, it is coming as negative. Same number is leaving, so it will be coming as 0. Okay, minus total flux will be coming as 0. புரிஞ்சிடுச்சுனா give me a yellow heart, everybody. Give me a yellow heart, everybody. Everybody give me a yellow heart. I need everyone's yellow heart. I need everyone's yellow heart. Okay? Yes. So now we are going for the next question. So இப்போ வந்து பார்த்தேன்னா இந்த questionல E is equal to x square I cap plus root y j cap தான். Okay, find the flux passing through a cube of side A. Assume a cube of side A is placed one of the corner at the origin and the side represented by x, y, z. Okay, how to do it? What we need to find here? We need to find the flux. So flux oda expression ennada? It is nothing but closed integral E dot ds da. Correct? So E is given. So can you just find it? Can you just find it? Just you need to integrate. Everyone should do integration for this one. Everyone should do the integration for this case. And limit வந்து 0 to a da varaporo. Okay. How we will be doing it? Flux will be integral 0 to a, ஏனா side வந்து a தானா, so it will be 0 to a ex dx, okay, plus integral 0 to a ey dy, okay. So இதில வந்து பார்த்தேனா e na x square I cap, okay, x square I cap plus y square root to y j cap da. So can you find it? Can you find it? Can you please let me know? Find it, everybody. One second. Option B, check again, everybody. How it will be option B? So integration la we will be going for 0 to a x தான் இங்கே இருக்கு, கரெக்டா? Sorry, x square dx I cap, correct, plus integral 0 to a ey சொல்லும்போது y to the power 1 by 2 dy j cap. Now this side will be x cube by 3 integral 0 to a plus y to the power 3 by 2. Here we will be getting 2 by 3, 0 to a. Now can you give me the, yes, very good, very good. We will be getting option A. While we are giving the limit, we will be getting a cube by 3 plus 2 by 3 a to the power 3 by 2. புரிஞ்சிடுச்சுனா give me a yellow heart, everybody. Give me a yellow heart, everybody. Everybody give me a yellow heart. Give me a yellow heart. So another question. We have plus q charge. at the center of the hemisphere, find the flux through the hemispherical surface. Now we know that in the charge Q, if it is in the closed surface, okay, in the charge in the closed surface, definitely we can say that will be Q by epsilon naught. Correct? That will be nothing but Q by epsilon naught. So now half of the surface so we will assume that it is closed with another hemisphere. So definitely what will happen? The total flux will be Q by epsilon naught, and half of the portion definitely it will be. Very good, Soumya. Very good, Sri. Yes, it is nothing but Q by 2 epsilon naught. Purinjidada? Everybody, yes or no? Please let me know. Everybody, please let me know. Everybody. So now we are quickly going for the another set of concept, which is nothing but what is a dipole, okay, electric dipole. So now electric dipole we know that, okay, electric dipole we know that it is nothing but two charges separated by a very small distance, correct? So dipole it is nothing but two charges separated by a very small distance. So idoda strength indicate pandradhukku we are introducing a quantity which is nothing but dipole moment. Can you please let me know what is dipole moment? Can you please let me know what is dipole moment? Can you please let me know what is dipole moment? Adoda expression. Can you please let me know? Everybody. What is dipole moment? Cubular சொல்லும்போது definitely if it is, okay, if it is at the one corner, okay, so cubular definitely we will be having few cases. I have to draw now, it will consume a lot of time. So let me do one thing. So let us say idudha vandu nama cube irukke, okay, so in the cube la paathena இதுக்குள்ள தான் இருக்கு நம்ம சார்ஜ் inside தான் இருக்கு, okay, inside na definitely it will be coming as Q by epsilon naught தான் நம்ம flux வர போறோம். The charge enclosed is Q. இப்போ it is at any position நாலும் Q by epsilon naught தான். Now let us say I am telling you, okay, இப்போ இந்த charge I am keeping at one of the corner. Okay, so now you have to make sure one thing, we can apply Gauss's law if it is closed. In the charge enclosed shape it should be enclosed. So definitely what will happen, in the charge close to keep it in a closed surface I have to keep few more cubes here. புரிஞ்சுதாடா? So let me just say இங்க தான் நம்ம cube இருக்கு. So இதுதான் one side. இங்க தான் நம்ம charge இருக்கு. So definitely இந்த ஒரு charge cover பண்றதுக்கு already இங்க ஒரு cube இருக்கு. Here also I will keep a cube. Here also I will keep a cube. Here also I will do. Same I will be doing on the top. So now what will happen? This will be closed. Correct? So now I can say that almost 8 cubes will be shared. Okay, in the small charge cube to make it in a closed surface, we have to keep 8 such cubes. Okay, appadina 1 cube it will be coming as Q by 8 epsilon naught. Purinjidada? Understood, Soumya? So this is one of the case. Another one is again we can just go for inga again we have the cube, okay, we have the cube irukke. This is how the cube is, okay. So now I'm just keeping it over here. Now just imagine inga da nama cube irukke, inga da I kept it, okay. Again what I should do, I should keep more cubes to keep this inside. Okay ba? So right now I can say that inga already or cube irukku, angada I have kept the charge. Now I'll be keeping another one. Now I'll be keeping on the top. So what is going to be the charge enclosed? I mean, yeah, what is going to be the flux? Can you please let me know what is going to be the flux? Everybody please let me know. இப்போ இந்த ஒரு சைடுல தான் இருக்கு, இந்த ஒரு side cover பண்ணனும். So அப்படினா how many cubes we need it? That is what the question. Then you will be get to know. Everybody tell me quickly tell me da. Quickly tell me. 3 bodumada, 3 more is required. So which means almost 4 cubes were there to cover that. Appadina definitely it will become Q by 4 pi epsilon naught. So I mean in the madri or question kadachena, you should do only one thing da. You just keep it in a closed surface. And the closed surface, I mean, to make it closed surface, how much things needed? That number will be get divided. Purinjidada? Can we go for the dipole part? Ready? Ready now? Give me a fire, everybody. Give me a fire, everybody. I need more fires, more fires. Everybody. Yes. Yes, Srimukhi. Yes, Rita. Yes, Soumya. Yes, yes, yes. Dhanushya. Right. Yes. Yes, Sri. Very good, very good. Lakshmi, Patmav. Yes, Lakshana. So now we are moving on to the dipole part. So dipole we said we have two charges, two small charges, equal and opposite charges separated by a distance. Adudha vandu nama electric dipole. Adu vandu to indicate the strength of the dipole we have introduced. Okay, namakku vandu oru quantity kuda irukku. That is what the dipole moment. And the dipole moment na it is actually vector quantity da. Adukku direction irukku. It will be always from the negative charge to the positive charge arukum. And also adoda magnitude vandu charge into distance of separation da. Purinjidada everybody? Give me yellow heart if you understood what I was saying. The dipole moment oda value, how to find it, and also the direction q into the distance of separation da. Next one is nothing but in the dipole moment illa we can find the field. Okay, at any point you can find the field using that equation. Kp by r cube root of 1 plus 3 cos square theta. இப்போ வந்து ஒரு கன்ஃபியூஷன் இருக்கு மேம், என்ன மேம் இந்த theta? Okay, theta na nothing but நம்ம dipole moment and the position vector க்குள்ள இருக்கிற angle தான் வந்து நம்ம நம்ம theta angle. Okay, so let us say இப்போ வந்து if I'm just marking like this is what minus q, this is what our plus q. So இங்க தான் வந்து field find பண்ணனும். So this is the center point. In the center point ல இருந்து I will draw a line. So now you know negative charge ல இருந்து positive charge தான் நம்ம dipole moment ஓட direction. So this will be making an angle theta. புரிஞ்சுதாடா? Now the thing is like for the axial and equatorial. Axial position சொல்லும்போது what will be the theta value? What will be the theta value? இப்போ வந்து field at any point வந்து இந்த equation use பண்ணி we can find it. Now my question is axial point சொல்லும்போது, okay, if I am talking about axial point na, what is going to be the theta value, which means along this axis, what is the theta value? Very good, Shri, it is nothing but 0 da. So now you can just put the value over here, 1 plus 3 cos square theta, which means root kulla 4 da varaporom, root 4 will be coming as 2, so you will be getting 2 kp by r cube. Purinjidada everybody? Please let me know. Adukapram equatorial. Okay, equatorial what will happen? In the theta value will become, what will be the value of theta? It will be equatorial nu sollumbodhu ippadi da varum. So this angle will be nothing but 90 degree. So cos 90 is 0 da. So we will be getting kp by r cube. புரிஞ்சுதாடா? And also in the potential value kuda important da. You should study kp cos theta divided by r square da. Okay, kp cos theta divided by r square da nama potential at any point. So now tell me axial சொல்லும்போது இங்க வந்து cos 0. So kp by r square. Equatorial சொல்லும்போது cos 90 0. So what is the potential at equatorial? What is the potential at equatorial? Why you people are not responding da? Are you people after lunch, ma'am, feeling tired, going for a sleep, a power nap? Apadiya? Please give me some fire. Let me just check how many of you are here. Everybody. Yes, Dhanushya is here, Soumya is here, Srimukhi is here. Yes, Lakshana, Padmav, Lakshmi, very good. Okay, so others I think they went for a sleep, power nap. Yeah, let me see. Anyway, okay, so these are the things. Yes, creative art ideas. Really? Yes, I know. Okay. Maybe the what is it, chats are coming little late, adanala I couldn't get it. Fine. Okay, so this is what the important things you should study. Now the thing is, like, in the electric field in the electric dipole I am keeping inside a external electric field. Appadina in the dipole actually it will experience a torque, and the torque oda expression da P cross E, and potential energy will be minus P dot E. Work done will be PE cos theta 1 minus cos theta 2. And when it is given, I mean when it is in a external electric field, இது oscillate பண்ணும். Okay, it will go for oscillation. அப்படினா அதோட angular frequency it is nothing but root of PE by I da. Time period will be 2 pi into root of I by PE da. புரிஞ்சுதாடா everybody? Yes or no? Yes or no? Please let me know. So these are the important things that you should study in the case of dipole. Now we are just quickly going for some of the questions, and adukapram we can just go for the next set of concept. Okay va? So dipole moment da. So inga we have a structure, correct? In the structure la irundhu we should find the net dipole moment. Okay, we should find the net dipole moment. So adukkaga paakumbodhu inga pathena inga oru plus q irukku, inga minus 3q da. So in the plus q oru dipole form pananumna I just need one minus q, correct? So I'll be going for inga oru plus q irukke, okay, adukkaga inda minus 3q la irundhu I will be going for one more minus q, and the dipole moment oda direction it will be coming like this. Understood everybody? Understood? Yes or no? I'm watching your first laws of motion, huh? Adukapra you can go for second also da. Okay, so now ipa inga paathena how much left da? Already one minus q is gone, right? So I have minus 2q over here. Inga plus 4q irukku, ana dipole form pandradhukku I just need a plus 2q only. Okay va? Plus 2q only. Again, as per direction negative to positive, I will be getting like this. Till this understood, give me a yellow heart. Till this understood, give me a yellow heart. Till this understood, give me a yellow heart. Okay, so now in the plus 4q paakumbodhu already plus 2q is gone, so I have minus 2q here also, sorry, plus 2q here already I have minus 2q. So direction paakumbodhu ippadi da nama dipole moment varaporum. Okay vada? So now I'm just considering, okay, P dipole moment I'm saying it is q into a. Okay va? Dipole moment I'm just mentioning it as P is equal to Q into A. Now tell me, ipa paathena inta oru structure illada, the minus 2q plus 2q, adoda dipole moment can you tell in terms of, okay, in terms of nama P term la, can you just let me know what is going to be P dash? What is going to be P dash in terms of P? Yena P na Q into A da. So on the case P dash sollumbodhu it is nothing but q into, it is actually 2q da into a. So can I say that this is nothing but 2p? Can I say this is 2p? Please let me know. Please let me know. Please let me know. So this is nothing but 2p. Okay, here also I'll be getting 2p. Now I'm going to draw the structures. Okay, idellame the vectors da. I got 3 vectors, magnitude p, here 2p, here again 2p. Okay, so now I'm just going to arrange the, this is what our p. Okay, another one is there on the top, it is 2p, and here we have again another one which is also 2p. Understood till na? Give me a red heart. Understood till? Please give me a red heart. Till this understood, give me a red heart. Everybody, okay? So just we have found the dipole moments of each of the pairs, whatever they are giving. Adukapram what we did, we just kept in the vector form, right? So idu 2p da, and p is in the downward direction. So what is going to be the equivalent? We will be getting on the top it will be p, and here you will be getting 2p. Two vectors mutually perpendicular. Appadina what is going to be the net dipole moment? What is going to be the net dipole moment? P square plus 2p the whole square. So I'll be getting 4p square, which means I'm going to get root of 5 P square, which means root 5 into P. And P value, we already know it from here. Can you please let me know what is going to be the answer for this question? Can you please let me know the answer for this question? Everybody, please. Very good, very good, very good. Yes, perfect. So this is nothing but root 5QA, the option B, the number right answer. Now we are moving on to the next question. Let us see what is in the next question. We have electric intensity at a point on the axial line at certain distance from a dipole is E. Along the equatorial line for the same dipole at a distance, the field is, okay? Axial line la irukkiradhu vandu E da. So can you just give me the equation for axial line? What we have studied for axial line? It is nothing but 2kp by r cube da. Adoda value vandu question la given, it is E. Correct? Along the equatorial line for the same dipole at the same distance, the field vandu, okay, equatorial line la irukkiradhu vandu we have to find in terms of this axial line. So what is for equatorial? It is nothing but kp by r cube da. Am I right or wrong da? Am I right or wrong? So tell me what is going to be the answer for this question. Just compare and let me know what is going to be the answer for this question. Very good, very good, very good. We will be getting E by 2. Yena kp by r cube ingerundu we will be get it as E by 2. So we can just substitute E by 2. If you understood, give me a yellow heart. If you understood this, give me a yellow heart. Now we are going for the next question. How do B? B is not possible, right? Okay, B in a 2 times E. Equatorial, it will be half only. Okay, just understand in the equation lerunda, I'm just going to find the expression for kp by r cube. Yena inga vanda I need kp by r cube. Purinjidada? Yes or no? Yes or no? Those who have made mistake, please let me know. So now we are going for the next question. 2-point charges 3.2 into 10 to the power minus 6 separated by some distance. Find the electric potential due to dipole at a point which is at a distance 3 centimeter from the center of dipole. The position vector P with respect to center of the dipole make an angle 30 degree. So what is the equation for dipole moment? Potential due to dipole? It is nothing but Kp cos theta divided by r square. Correct, Ada? So, ipo on the path, P is not given. So, we can just go for Q into A. Q in a 3.2 into 10 to the power minus 6. Da. And tell me, Ada, what is going to be A? What is going to be A in this case? Can you please let me know what is going to be A? Question they have given, it is separated by 2.4 into 10 to the power minus 10. Correct? So, you can just substitute A in a distance of separation. Da. So, you can just substitute the value. And what is the value of R? Hey, Rida, it is not. Why we should go for 1.2? Why we should go for 1.2? I have told you, okay, dipole moment na charge into distance of separation da. Okay, va? In the two charges minus Q plus Q. In the two charges separation da actually number A. You have studied 10 to the power minus 10. So, now the question they have given, okay, center one of the charges distance da in the value. Appadina you should do twice of it, okay. So, appadina mattunda you will be doing it twice, okay. So, can you just loading up? Any problem da still? Can you please let me know any problem right now? Yes, perfect. Okay. So right now, yes. So right now you can find the dipole moment. Adukapra you can just substitute theta vandu 30 degree da r square, the distance from the center of the dipole to the point where we need to find. So adu vandu clear they have given. Okay, clear they have given as 3 centimeter. Can you just let me know what is the answer for this question? Please let me know. So k value vandu 9 into 10 to the power 9 da, and nama q value vandu 3.2 into 10 to the power minus 6 into 2.4 into 10 to the power minus 10 divided by 3 into 10 to the power minus 2 the whole square. Everybody tell me what is going to be the answer for this question. Do the yes. Very good. Yes, we will be getting option B as the right answer. Understood? Give me a fire, everybody. If you understood, if you are ready for the next question, give me a fire quickly. So next question, an electric dipole of dipole moment P is placed parallel to uniform electric field E. The work done required to rotate the dipole by an angle of 180 degree will be. So work done oda expression ennada, it is nothing but PE cos theta 1 minus cos theta 2. So idhula vandu theta 1 na it is nothing but 0 degree. Theta 2 na it is nothing but question la given 180 degree. So can you just substitute and please let me know the answer for this question. Tell me what is going to be the answer. Very good. We will be getting 2PE as the answer for this question. Can we move on to the next question? Da, ready? Give me a yellow heart if you are ready for the next question. Okay. So inga vandu paathena 2 point charges irukke, 3.2 into 10 to the power minus 19 and minus 3 point, which means it is going to be a dipole. Okay, equal and opposite charges, and distance of separation is also given. The dipole is situated in a uniform electric field. Adu kuda given. What is the work done? Okay, what is the work done? Okay, so right now initially dipole moment was parallel to the direction of electric field. So there is no issues. Again, work done vandu already we know it is nothing but 2PE. Previous case order continuation da in the question. Okay, work done for rotating 180 degree vandu we already understood it is 2PE. Now the thing is like previous question we have already found what is P. Now you can just substitute for E value and please let me know what is the answer for this question. All have purple hearts. Yes, now tell me what is the answer for this question. Everybody? Yes, very good. So already the fresh hour question you have to find what is the work done. Ana the previous question we already found it 2PA. Okay, sorry, 2PE. So P வந்து Q into A da, that is also we have done in the previous question. Okay, just before this question we have done this, and other multiply பண்ணனும் with the electric field and 2. That's the only thing. Yes, Manchu, welcome back. So others, give me the answer quickly. Give me the answer quickly. Everybody give me the answer quickly. Give me the answer quickly, everybody. Perfect, perfect. We will be getting option B as the right answer for this question. Now, let us go for one more question. Okay. So, in the question, what they have mentioned, let us see. Two spheres irukku, radius வந்து 3r and r idha. Okay, after switch has been closed, which means they are in contact. Okay, what will be the final charge on these spheres? Okay va, so initially வந்து இதுக்கு மட்டும் தான் charge இருக்கு q. Okay, so right now we know that the potential on 3r should be equal to the potential on r. Correct ada? So இப்போ வந்து initially இருக்கிற charge வந்து q தான், the charge will be always conserved. So after some time what will happen, இதில இருந்து some charge will be taken to the small one. Okay va, understood ada? So right now you can just let me know what is going to be the potential due to 3r and the potential due to that small r1. Okay, so what is going to be that? What is going to be that? On the surface, tell me, what is this? K into, now the charge is k q minus q, okay, divided by 3r should be equal to kq divided by r. So kr got cancelled. Can you just find the value of small q in terms of capital Q? Everybody, simple ஆன ஒரு question da. Simple ஆன ஒரு question, you can just give me the answer quickly. Very good, very good, very good, very good. We will be getting q by 4 as the answer for this question. Now, can we move on to the capacitance? Are you ready for the capacitance? Let us just quickly revise capacitance. Ready, Ada? Everybody is ready? Please let me know. Everybody is ready? Everybody? Yes, perfect. So, capacitance, okay, capacitance na, we know that adoda expression vandu q by v da, correct? Capacitance will be q by v da, and ipo vandu in the capacitor la usually vandu we will say there should be two. Okay, ipo vandu or spherical shape na two spheres irukkanum, two concentric spheres da vandu to make the capacitor. Two plates, I mean ipo vandu plate type na, definitely we can say two plates supposed to be there. Cylindrical na two coaxial cylinders should be there. ஆனாலும் now the thing is like, let us say இப்போ வந்து நமக்கு வந்து ஒரு ஒரு capacitor வேணும், ஆனா only one conductor மட்டும் தான் இருக்கு. ஓகேவா, அப்படினா can we make a capacitor? What is going to be your answer? Yes or no? Yes or no? எப்பவுமே வந்து we should have plus q and minus q, கரெக்ட்டா? இப்போ வந்து ஒரு whenever we are talking about the capacitance, we should have plus q and minus q, கரெக்ட்டாடா? அப்படினா my question is, can we just make a capacitor using only one spherical conductor? Is it possible? Of course it is possible. Okay, and we will assume that the second one, okay, the second one is at the infinity la da irukke. Okay va, appadi assume பண்ணிட்டேனா we will be getting a capacitor, an isolated spherical capacitor. அதோட capacitance ஓட value வந்து 4 pi epsilon naught r da. So இப்போ நீங்க வந்து you will be thinking about what is this r ma'am? So we have mentioned ஓடா ஒரே ஒரு sphere தான் இருக்கு, அந்த ஒரு sphere ஓட radius தான் நம்ம capital R. Okay va, so we can say that this is nothing but 4 pi epsilon naught r. Understood everybody? Yes or no? Please let me know. Everybody please let me know. So இதுதான் வந்து நம்ம first point. Next வந்து the energy stored in the capacitor, that is nothing but q square by 2z, illana you can say half qv, illana you can say half cv square, depending upon the question you can just do it. Okay vada. And also let us say if I'm just talking about work done by the battery, இப்போ வந்து we have a capacitor, அது வந்து we have connected with a what is a battery, அப்படினா அந்த பேட்டரியோட work done வந்து q into v தான். But definitely we can see that நம்ம capacitorல இருக்கிற charge இல்லனா அதுல store ஆகிற energy வந்து half into qv மட்டும்தான். So what happened for the another half qv? Okay, total work done by the battery na qv da. So right now energy stored வந்து half of its value da. So where is that another half energy? It is actually there is a loss which is happening, and the energy loss is actually half qv da. Okay, the half of the work done by the battery is losing, or let's say while the charge is flowing through the wires and all, due to heat and everything, the energy will be decreased, and the energy stored in the capacitor will be half of the total work done by the battery da. Purinjidada till this? Please let me know, give me a heart till this. If you understood, give me a heart. Next வந்து நம்ம energy density தான். Energy density na work done per unit volume, அதோட வேல்யூ வந்து epsilon naught e square divided by 2 தான். புரிஞ்சுதாடா? Next வந்து specifica we are going for the parallel plate capacitor. Okay, parallel plate capacitor சொல்லும்போது அதோட capacitance ஓட வேல்யூ வந்து it is nothing but a epsilon naught divided by d தான். ஆனா வந்து இந்த parallel plate capacitor சொல்லும்போது, thank you so much for the hearts da. Okay, இந்த parallel plate capacitor சொல்லும்போது if I am keeping some dielectric medium, okay, in the two plates kulla I am just keeping a dielectric medium na, in the capacitance oda value vandu it will change. And what is going to be that value? What is going to be that value? It will become k times, it is going to be more than that of the capacitance in air, because the thing is like many students used to make a mistake. ஏனா electric field force எல்லாமே வந்து டிஸ்கஸ் பண்ணும்போது it is actually decreasing da. So capacitance க்கு கூட அப்படிதான், I mean that is how it will happen. அந்த மாதிரி நினைக்காதடா. Actually வந்து நம்ம capacitanceல when we are keeping a dielectric medium in between the plate na, it will increases k times. Okay, dielectric constant da nama k value, it will increases k times. Now the thing is like in the two plates irukkelada, in the two plates, so idu vandu plus q ana, definitely idu vandu minus q da. Now tell me, what is the net charge on the capacitor? The net charge on the capacitor. Very good Padma, very good. Okay, so ipo vandu two plates irukke, in the two plates or plates da capacitor irukke, appadina net charge will be on the capacitor. Can you please let me know? And guys, likes are very less. I need more likes, guys. I need more likes. What is going to be the net charge on the capacitor? Hari, what is that? It is nothing but plus q and q is coming, right? Plus q and minus q it's coming, correct? அப்படினா the net charge வந்து நம்ம மொட்டை. Okay, நம்ம மொட்டை தான் வர போறோம். Okay, why you people are not listening here, or what you are doing? Two plates தானடா இருக்கே. One plate will be having plus q, another plate is having minus q. Appadina what is the net charge on the capacitor? Zero dana. Why for the silly questions you are giving wrong answer? Message delete pannina, I have already seen that. Okay, so don't delete it, and the mistakes appadiye irukattum. Okay, so net charge will be always வந்து 0 தான். Okay வா? இப்போ வந்து இங்க வந்து 3 coulomb இருந்துருச்சுனா அந்த next plateல வந்து minus 3 coulomb தான் இருக்க போறோம். So next வந்து இப்போ வந்து 2 plates இருக்கு. இந்த plate இங்க வந்து plus q charge இருக்குல, இந்த plus q will definitely exert a force on the other plate. இப்போ வந்து இங்க minus q இருக்கு. So definitely இந்த minus q will exert some force on this plus q as well. And the force ஓட expression வந்து q square divided by 2a epsilon naught தான். இந்த equations எல்லாமே வந்து very important. You guys have to study all these equations. And இப்போ வந்து I have a question. Okay, எனக்கு வந்து I don't want to fill the dielectric completely. I wanted to I wanted to give it for small segments. I'll just let you know. So ipo vandu idha vandu nama capacitor oda plates. Okay, I will keep a dielectric medium over here. I will be keeping a dielectric medium over here. Okay, so idoda dielectric constant na K1 da, idoda dielectric constant na K2 da. Purinjudha? So right now, if I'm just thinking about, this is what the distance of separation D. Okay, and this is what the thickness of this one. அப்படினா நம்ம capacitance value will be definitely changes. அதோட value வந்து it will be A epsilon naught divided by D minus T plus T by K it will come. Okay, இப்போ வந்து இந்த மாதிரி தான் நம்ம arrangement. Okay, we are not completely, okay, in the two plates குள்ள we are not completely giving the what is a dielectric medium. கொஞ்சம் portions la different what is a dielectric medium da எனக்கு வந்து place பண்ணனும். அப்படினா how will be the capacitance changes? அதுதான் வந்து I have written over here A epsilon naught divided by D minus T plus T by K. புரிஞ்சுதாடா everybody? Yes or no? Please let me know. 9 more likes. Okay, let me see. Few more confuse will be definitely there. Let us see. Okay, so yes, so this is what the first part of this one. Okay, so next வந்து இந்த dielectric சொல்லும் போது, okay, you will be get confused. இந்த insulators and dielectrics வந்து same இல்ல what to say, இதுக்கு வந்து ஏதாச்சும் ஒரு difference இருக்கா? How we will be identify insulators and dielectric? அப்படினா அதுக்கு வந்து the few things இருக்கு. Okay, do you know the major change? இப்போ வந்து ஒரு insulator இருக்கு, dielectric இருக்கு. அப்படினா அதோட major change வந்து, can you just let me know? Can you please let me know what is the major change? What is the major change? Insulator irukku, dielectric irukku. So simple ah sonitena, ipo vandu insulator we are keeping in an external electric field. Dielectric kuda we are just keeping in an external electric field. So appadina in the dielectric will be get polarized. Illena adukulla oru induced electric field will be formed. அப்படினா I will call that specific material as dielectric. ஆனா வந்து இந்த insulator, even if I am keeping in the external electric field also, அதுக்கு வந்து changes எதுவும் இருக்காது. Okay, it cannot be polarized, it cannot induce an electric field, it cannot align in the direction of electric field. Okay va? So this is what the major difference between dielectric and insulators. The only major difference which is coming is in the dielectric வந்து if I am keeping in the external electric field na, it will be get what is the electrons will be electric field will be induced. And dielectric field illa there will be two categories, polar and non-polar. Till this understood? Can you give me a yellow heart? Can you give me a yellow heart if you understood till this? Okay, so yes, very good. Smash the like button, guys. Okay, illana Srimukhi will become Chandramukhi. So yes, so இப்போ வந்து இந்த polar என்னன்னா அதுக்கு வந்து net permanent dipole moment இருக்கும். non polar சொல்லும்போது அதுக்கு வந்து permanent dipole moment இருக்காது. ஆனா வந்து external field ல introduce பண்ணும்போது definitely we will be having the dipole moment. So இதுதான் வந்து changes. அதோட example கூட it is very important. Now can we go for solving some questions? And series and parallel is also important. I hope you are aware about it. So let us do some questions. Ready now? Give me a fire, everybody. Ready now? Give me a fire, everybody. Ready? Give me a fire. Yes, perfect. So we are going for the first easy question. Okay, give me the answer. See, capacitance is given, potential is given. So now tell me, what is the answer for this question? Yes, half into 2 into 10 square. So you will be getting 100 joules as the answer. Now let us quickly go for the next question. Imagine a parallel plate capacitor with plate separation 1 centimeter. Plates are both right angle. of 2 centimeter on two sides. What is the capacitance of the capacitor? Very simple. It is nothing but A epsilon naught divided by D. Can you find the answer for this question? Everybody, can you find the answer for this question? Epsilon naught value you can just simply take it as 10 to the power minus 11. Then we have to find the area. This is triangle da. So definitely half into BH da. So half into 2 into 2 into 10 to the power minus 4 it will come. Tell me what is going to be the answer. Everybody do the calculation and give me the answer da. Do the proper calculation and give me the answer. Check the powers, check the powers. We will be getting option A as the right answer. Area will be half into 2 into 2 into 10 to the power minus 4 into 10 to the power minus 11 divided by number 1 into 10 to the power minus 2. That is centimeter lada, so we have to convert. So we will be getting option A. So now we are going for the next question. Let us see what is in the next question. Okay. So now find the force between. Okay. We have just now only we have discussed about the force order expression. Do you remember the equation? Do you remember the equation, number force order equation? Do you remember the equation? Please let me know. What is the equation? Q square by 2A epsilon naught. Q is given 5 millicoulomb and number area is also given 1 centimeter square. Epsilon naught again you can just take it as 10 to the power 11 and substitute and please let me know what is going to be the answer. Which is going to be the very good Lakshmi, very good, Q square by 2A epsilon naught, very good. Give me the answer, give me the final answer. Everybody do the calculation and please let me know. Very good. We will be getting 14 into 10 to the power 9 Newton. So that is nothing but 14 G Newton. So now we are going for the another question. So that equation we know. What is the equation? Do you remember this? Z dash will be A epsilon naught divided by D minus T plus T by K. Can you just do this question? So idhula pathena nama what is a thickness sum pannanom. D 20 centimeter da and T it will be 2 plus 2 plus 2 it will come and we have to find the sum of T by K as well. T by K sollumbodhu we will be having 2 by 2 plus 2 by 3 plus 2 by 4 it will come. So just substitute and find the answer for this question. Epsilon naught again if you wanted you can just take 8.85 into 10 to the power minus 12. Illanalum paravalada you can just take 10 to the power minus 11. That will also work for this question. Then we will be having the area. Area it is not given, right? So just let us put it as area. Okay, area should given. Okay. Okay, so area, let it be there. Let us just see what is going to be the answer we will be getting. Then D, it is nothing but 20 minus T, it is nothing but 6 minus sum of T by K. So what is going to be that? What is going to be that? 2 by 2 plus 2 by 3 plus 2 by 4 it will come. Can you just find it? But from sigma also we cannot find it, no. How we will be finding it? Sigma is equal to Q by A. Okay, let us just try that. Sigma is equal to Q by A. So sigma into, then still Q is not there, no. How we will be finding it? It's not possible, no. So let it be, just keep A and then just let me know. It should have given at least the charge or something they should given. So area actually vandu no way. Okay, you can just take it as 1 into 10 to the power 2. In a solution they have given that. So now you can just go for it. Adu vandu or electron oda charge danada, we cannot just go for it na. So now I'll tell you how to do it. Maybe that is enough for right now. Okay. So this is how we will be doing it. 10 to the power minus 11 in the area vandu we cannot just find it from here. Then D value vandu 20 da, and sum of thickness 2 centimeter, 2 centimeter, 2 centimeter. So that will be 6. And T by K oda sum we have just substituted. Understood? Ada? Give me a yellow heart if you understood the steps. Everybody give me a yellow heart if you understood the steps. Everybody. We can move on to the next question if you are ready for it. The solution they have given actually 1 into 10 to the power 2. Okay, so maybe that was supposed to be in the question. So next question, all the capacitors are identical and the effective capacitance between P and Q is 1 microfarad. Find the value of each capacitance. So please let me know in the capacitors ellame vandu series la illa parallel la illa combination, how you are feeling it. How I mean, what is your kind of analysis? Ma'am, idu vandu paakumbodhu series madri theriyudhu illa na ma'am, the first two illa ma'am, adu vandu parallel, adukapra adutha next vandu it is actually series and the madri. How you are feeling it? How you are feeling it? Please let me know. Idu vandu almost 3 capacitors irukke. In the 3 capacitors vandu series ah illa parallel ah combination ah. How we will check series? How we will check series? We will just start from here. And without any problem, there is no branches, there is no branches, there is no branches. We could just simply reach us here. Okay. Appadina I can say that all these 3 capacitors are in series. Correct, Ada? Appadina 1 by CS. Correct, Ada? This will be coming as, all are identical. So this will be coming as 3 by C. Sorry, C by 3. Okay. So we know that the equivalent capacitance will be coming as C by 3. Yena idellame vandu identical. Am I right or wrong? Am I right or wrong? All are actually vandu identical da. So in the equivalent capacitance is already given in the question. What is that? 1 microfarad. Appadina this is going to be the answer. Can you please let me know which is going to be the right option? Which is going to be the right option? Very good, very good. We will be getting option C as the right answer. Very good, very good. Let us go for the next question. Ready now? Give me a fire, Ada. Give me a fire if you are ready. Yes, next question. In the equivalent capacitance across AB is given 0.5. You have to find the C. Engada in the C irukke? Yes, here is the C. Okay, fine. Okay, so ipo in the diagram it is actually a combination da. Okay, there will be series and parallel combination. So now I am just focusing on these 2 capacitors. What about the speciality of these 2 capacitors? They are in parallel, right? Yena potential across both the capacitance one the same da. So ipo vandu inda oru plate oda potential vandu ipdi da, and here also it is coming as same. Appadina can I say that adu vandu I mean parallel da? Yena the potential across this capacitance are coming same na. We should understand adu vandu actually it is what? It is actually I forgot. அது வந்து parallel தான் இருக்கு. அப்படினா parallel connection. So இதோட equivalent capacitance we will be get it as what? 2 microfarad. So I will be remove this and I will be replacing this. Exactly the similar way, I could just say this is also coming as 2 microfarad. Till this understood, can you give me a yellow heart? Till this understood, can you give me a yellow heart? Everybody? Till this understood, give me a yellow heart. Okay? So, on the 2 capacitors பார்க்கும்போது அதோட potential வந்து same தான். So, definitely அதுங்க வந்து parallel தான். Correct? அது வந்து parallel தான். So, I found this as 2 microfarad. Very good. Now tell me, what about this 2 capacitors? What about this 2 capacitors? Is it in series or parallel? Is it in series or parallel? I'll redraw here. Okay, I'll redraw here. So you will be get better clarity. Okay. So this is how it is. Okay, this is what our B, this is what our A, this is what C. Okay. Now tell me what about this 2 capacitors? Can I say this is in series? Very good, Padma. Very good, Yokita. Right. Yes, yes, Sri. Very good. So this is coming as 2 microfarad, 2 microfarad, which is in series. Appadina equivalent capacitance will be series la da irukke. Equivalent capacitance will be 1. Here also it will be coming as 1. So now again we are going for it. So idha vandu A, this is what our C. Right now we have 2 capacitors like this. Okay. So this is our B. This is 1. This is also 1. What about these 2 capacitors? What about these 2 capacitors? Can I say that idoda potential difference and in the capacitor oda potential difference one the same dana? Okay, let me just put it as A1 here. Here it is B. அப்படினா on both the sides வந்து பாக்கும்போது we can say that the potential வந்து same தான். அப்படினா I can say this is again coming as parallel. Correct? This is again coming as parallel. அப்படினா the equivalent circuit will be coming as. Okay, இதுதா வந்து A, this is what our C, this is parallel, so this will be 2 and here is our B. Now can you just let me know what will happen here? What will happen here? We know C and this 2 microfarad is actually in series. அப்படினா நம்ம C equivalent will be coming as 2C divided by 2 plus C. ஆனா வந்து இதோட value is already given. It is nothing but 1 by 2 microfarad da. Now can you please let me know the right answer for this question? Can you please let me know the right answer for this question, please everybody? Very good, very good. We will be getting option, yes, option C as the right answer. Guys, don't forget to like the session, okay? Don't forget to like the session. I want more likes. Let us go for one more question. Ready? Ready na? Give me a fire. Give me a fire if you are ready for the next question. Yes, here is the question. Okay, so in the மாதிரி ஒரு question கிடைக்கும்போது they have mentioned all are identical. அதோட value வந்து 2 microfarad தான். You should find the potential across AB. Sorry, capacitance across AB. இதுதான் வந்து find பண்ணணும். கரெக்டா? So first I'm looking at this. So I'm just folding it. Okay, about this axis I'm going to fold it. So what I will be getting similar pattern. In the left side வந்து actually வந்து இதோட copy மாதிரி இருக்கு. அப்படினா whatever is coming along this symmetry line. Okay, in the symmetry line la இருக்கிற அந்த junction வந்து you can remove it. அப்படினா what will happen da? What will happen? So my circuit will be like this. Okay, my circuit will be like this. Just observe da. So inga வந்து another one will be here. Okay, so right now I will be having, I'm just removing the junction. So now I'll be getting the circuit like this. Okay, Vada? Till this understood everybody? Till this understood everybody? Please let me know. Please let me know everybody. So right now, ninga vandu paathena, these two are in actually they are in series. Correct? In the two vandu, it is actually in series da. அப்படினா what is going to be the potential da? Sorry, what is going to be the capacitance? அதோட equivalent capacitance ஓட value. Okay, we know that 2 microfarad da. Correct? அப்படினா can I say that this will be 1 microfarad? Can I say that? Yes or no? Please let me know. Understood till? Give me a yellow heart. Everybody. Give me a yellow heart if you understood till. And the junction remove பண்ணும்போது அந்த ஒரு branchல இருக்கிற two capacitors வந்து actually வந்து they will be in series. Okay, அப்படினா 2 microfarad and 2 microfarad in series, which means அதோட equivalent வந்து 1 ஆ இருக்கும். Now here we have 1, here we have 2 parallel. What is the equivalent capacitance? What is the equivalent capacitance we should add? Correct? We should add. So definitely we will be get it as this as what? 3 microfarad. Now tell me what about this 3 capacitors? இங்க வந்து ஒரு 2 இருக்கு. Here we have 3, here we have 2. அப்படினா 3 capacitors which is in series or in parallel, or how you will be defining it about this 3 capacitors? How you will be defining it? Can I say this is in series? Can I say this is in series? And 2 equal da, so definitely அதோட equivalent வந்து 1 da, so 1 and 3 is again in series, so we will be getting 3 into 1 divided by 3 plus 1, so we will be get 3 by 4 as the capacitance. Am I right or wrong? What is the equivalent capacitance you are getting with this 3 capacitors? So இங்க வந்து 2 இருக்கே, this is also 2 equal capacitors. Okay, அப்படினா அதோட equivalent capacitance வந்து 1 da. So 1 and 3 again in series, which means equivalent capacitance will be coming as 3 by 4. Understood till? Please give me a red heart everybody. Give me a red heart everybody if you understood till. Give me a red heart quickly. And guys, don't forget to like the session. Don't forget to like the session. Everybody. Yes, perfect. So அப்படினா right now in the 2 capacitors இருக்கு, which is also in series, so I'll be getting 1. Now I'm going to draw the equivalent circuit over here. So right now this is how it will come. This is what 1 microfarad and this is what 3 by 4 microfarad. Can you please let me know the final answer for this question? Can you please let me know the final answer for this question, please? Everybody, please let me know. Very good, very good, very good, very good, very good. Should I explain this again? Anybody needs it? Yes or no? I hope it's clear. So option A will be the answer for this question. Okay, can we go for the current electricity? Can we go for the current electricity? Ready? Should we go for a 10 minutes break? Not 10 minutes, 5 minutes is enough, right? But I don't know, you people will be come back or what? Okay, so before going for the next chapter, should we have a very small break? Please let me know. Yes. So let us go for a 5 minutes or 10 minutes. How much you want? இது வந்து capacitance da. Next வந்து current electricity. Break is needed. Who is going deep concept? I am not going for deep concept. ஏன்னா அது வந்து I mean we cannot finish da for sure. Okay, so let us go for a 10 minutes. Okay, so what is the time now? 2:50 will be fine. So see you guys after the break. We can just meet again. Okay, but everyone should come on time. Okay, don't cheat me. Hello, hello, hello everybody, am I audible? Yes, yes, yes. So right now we are going for the current electricity. So let us just start with a very small quick revision. Okay. So right now the first part we will be discussing about the electric current and drift velocity. So the electric current it is nothing but the charge by time. The charge we have already know it. Okay. The charge on a body will be nothing but plus or minus NE. And next one is nothing but graph da. Okay, so let us say if I am plotting, okay, if I am plotting charge versus the time graph, okay, charge versus time graph. What is the area under the charge time graph? What is the area under the charge time graph? It is nothing but the, we know I is equal to dq by dt da. So integral I dt will be coming as integral dq, which means it is nothing but the total charge. Are you guys here? Please let me know. Yes, not current. Okay. So, this is the charge, the current and time da plot panna porom. Now, area under the current time graph we got it. Next one, I am just going to, okay, now the charge irike, time irike. Okay, wow. So, right now I am plotting it. What is going to be the slope? What is going to be the slope? Can you please let me know? Everybody, I am not getting the answers. Why? Initially the energy yes Soumya, yes bio with Anu, right? Yes, so it will be coming as the current. Okay, next one is nothing but drift velocities. Basically speaking, what is nama conductor kulla free electrons irukku, adukku vandu or velocity kuda irukku, adha vandu what we used to say thermal velocity. In the thermal velocity paakumbodhu, the sum of, or let's say the average of this thermal velocity will be coming as 0. Let us say whenever we are giving a external field in the electrons or in the free electrons in the conductors will move in the same direction. Okay, wow. So definitely what will happen so it will leads to a current, and that velocity, that particular velocity is known as the drift velocity. Adoda expression E by tau. Can you please let me know what is tau? What is that tau? What is that tau? Can you please let me know? It is nothing but the relaxation time da. Yena vandu two collision, okay, two successive collision la irukra time da actually vandu namma relaxation time. Purinjudada? Everybody got it? Next vandu namma current and current density. Current vandu as we know, adu vandu oru what to say scalar quantity da. Adoda oru vector form da vandu namma current density. Adoda expression vandu current divided by area da. Okay, current per unit area da actually vandu nama current density. Next one is nama current and nama drift velocity oda relation da, which is nothing but n is equal, sorry, I is equal to n into E into A into Vd. N na number density da, A na area da, E vandu 1.6 into 10 to the power minus 19, Vd is nothing but the drift velocity. In the equations ellame vandu very important. Okay va? Next one vandu mobility. Mobility is nothing but the modulus of drift velocity. Okay, modulus of drift velocity divided or per electric field da vandu nama mobility. Purinjidada everybody? Yes or no? Please let me know. Please let me know everybody. Yes, very good, very good. VD by E da vanda nama mobility. So let us just go for the first question. Idu vanda I'm not going to explain. You people will definitely explain and let me know what is the answer. What is the answer for this question? T at T is equal to 2, what is the current? So which equation we will use it here? Which equation we will use it here? And guys, don't forget to subscribe the channel, okay? It is nothing but I is equal to dq by dt. Am I right or wrong? Am I right or wrong? I is equal to dq by dt. So tell me what is going to be the answer for this question. Very good, very good, very good. We will be getting 9 ampere. Yena vandu we will be getting 2t plus 5. And adukapran t ki vandu we will be put it as 2. So it will be coming as what? It will be coming as 9 ampere. Now let us move on to the next question. Okay, 4.8 ampere is flowing through a conductor. The number of electrons passing through the cross section per second, n by t da we need it. Okay, so current order expression vandu we know it is q by t da, q vandu we know ne by t da. So actually vandu we need n by t. So adukku vandu I can go for I by E. So current is given, E value we know. So now tell me which is going to be the right answer. Which is going to be the right answer for this question? Everybody quick let me know da. Quickly let me know. Very good, very good, very good. We will be getting option A. Till this it's fine. Please give me a yellow heart everybody. Till this fine. Okay, till this ma'am fine da. Okay, enakku vandu first introduction part ellame vandu clear ah irukke. Then please give me a yellow heart everybody. So now we are moving on to the next question. If current 8 ampere is flowing in the x direction through a cross-sectional area of 2 meters square, what will be the current density? Equation, current density or equation. Can you please let me know nama current density or equation? Current density. I by A, then let me know the answer. Yes, there is no confusion. It will be option A. Right, Ada? Another simple question. A charged particle having a drift velocity which is given, electric field is also given. Mobility da find pannanom. What is going to be mobility? Idellame vandu nama equations ellame vandu we just need to go through it one more time. Adikaga da I am just explaining it all, okay? So try to understand. Don't think like okay NEET ku vandu ivlo easy ana questions ah vara poradhu illada. Actually vandu we have studied some equations concept. Adu vandu we are again applying. And current electricity oda detail ah irukra lecture different questions ellame vandu we have did it already. So you can just check it out that as well. Okay va? Yes, perfect. So which is going to be the answer for this one? We know mobility which is equal to VD by E da. So we will be getting option D. Very good. We will be getting option D as the right answer for this question. So next one then nama Ohm's law da. What is Ohm's law? Ohm's law na very simple ma'am. It is nothing but the potential will be directly proportional to the current, right? And the condition is the physical situations, which means nama temperature ellame vandu constant ah irundha mattunda we can say the Ohm's law, which is coming as V is equal to IR. Illana it is not going to be constant. Appadina quick I'm just going to plot it da. Okay, I and V. Okay, so here we have A. This is what another material B. Now tell me which one is having the highest resistance. Yeah, if I am plotting I versus V, what is going to be the slope? Everybody tell me. And tell me in the case which one is having the highest resistance. A material A ka illa B ka. Which one is having the highest resistance? Everybody. What is the slope? Tell me da. In the graph order slope yenna? In the graph order slope, yes, good afternoon da Pravina. What is the slope? It is nothing but 1 by R da. So slope is less, which means the resistance will be high. Appadina I can say that material A ku da resistance vandu high ah irukka porum. Correct ada? And in the resistance vandu actually depend pannirukkiradhu 3 factors da. Actually vandu 4 factors. Directa vandu sollumbodhu I can say length it is depending, area it is depending, the material it is depending upon, and also it is depending upon the temperature as well. So resistance, which is resistance is actually depending upon 4 factors: length, then area, then the material, and also the what to say temperature. Purinjudada? So right now we know nama resistance oda expression vandu rho into L by A da. Okay, rho it is nothing but nama resistivity da. Adoda expression vandu m divided by n e square to da. And the expression vandu you have to study. In the resistivity oda expression vandu you guys have to study. Ena idu base panni da we are actually discussing about the temperature. Till this it is clear. Give me a yellow heart everybody. Let me see how many of you are present right now. Okay, or went for sleep illa what you guys are doing adu vandu correct ah enakku puriyanumla. And initially in the beginning la few people have told me, ma'am, in the 8 hours I will be with you ma'am and the madri solli irukke. So let me see anyway. Okay, yes, again few people were missing in the beginning la promise panna and the students ellame vandu missing ah irukke. Okay, let me see anyway. So resistivity vandu m by n e square tau da. And also another relation nama Ohm's law oda vector form. Okay, what is the Ohm's law oda vector form? Can you give me the answer? Can you give me the answer? Vector form of Ohm's law. It is nothing but J which is equal to sigma E, or let's say E by rho. Okay, wow. The vector form will be coming as J which is equal to sigma into E illana E divided by rho. In the expression kuda important da. Purinjudada everybody? Yes or no? Now we are going for the temperature part. So the temperature, resistance is actually depending upon temperature, and this is how it is. Okay, RT na at some, when we are increasing the temperature, what is the resistance at that particular temperature, which is equal to nama initial temperature into 1 plus alpha into delta T. Okay, so alpha vandu nama temperature coefficient da. So in the alpha value will be positive for the conductors and negative for the semiconductors da. So which also you have to study. For insulators and all, it is going to be almost 0 value da. Same equation you can use it for resistivity as well. Wherever you kept R, that you can replace it as rho. So resistivity or equation will be coming as rho T, which means at a temperature the resistivity of a material will be equal to initial resistivity into 1 plus alpha into delta T it will come. Understood ada everybody? Please let me know. Quick, please let me know. Then we can just discuss how the temperature varies in the case of nama what to say conductors la eppadi it will vary. That is what we are going to discuss after this. Okay, so right now for in case of conductors, I just wanted to know nama resistivity oda expression. What is resistivity oda expression? M divided by n e square tau. Do you guys remember this equation? Yes or no? You guys remember this equation? Yes or no? Please let me know. Yes. Appadina nama conductors la sollumbodhu there will be more free electrons, right? Okay, there will be more free electrons, and the mass value, number of free electrons idellame vandu constant values da. Appadina nama resistivity is actually depending upon 1 by tau. Okay, 1 by tau. Tau na relaxation time da. So when I'm talking about the temperature increases, okay, hey, why it is happening like this? Okay, the temperature increases. When I'm saying the temperature increases, what will happen to the free electrons? Adukku vandu extra vandu kinetic energy adhigama irukum. Correct ada? When temperature increases, adukku vandu extra kinetic energy, it is going to get extra kinetic energy. And the kinetic energy kadachena definitely nama relaxation time vandu increase aguma illa decrease aguma. Let us say you and nama உங்களோட siblings and you are going to make a fight, okay? So actually வந்து you are not had anything and your energy level is very low, okay? அந்த டைம்ல definitely அந்த collision இல்லனா the slap, the fight, everything is going to be little slow, right? ஆனா வந்து you have enough amount of energy. அப்படினா how will be the fight, okay? அந்த ஃபைட்டுக்கு இருக்கிற அந்த small timing இல்லடா அது வந்து அவ்ளோ small ஆக போறே கரெக்ட்டா? So definitely நம்ம tau value, the relaxation time, the collision initially in the energy in the temperature க்கு முன்னாடி actually வந்து இப்படி தான் it will go. ஆனா வந்து temperature கிடைச்சிருக்கு free electrons க்கு வந்து extra energy கிடைச்சிருக்கு, so it will be go like this, which means நம்ம relaxation time வந்து it will be get reduced. Am I right or wrong? Nama relaxation time oda value increase. How it will increase da? How it will increase? Are you guys getting what I'm saying? Temperature increase ஆச்சு, அப்படினா kinetic energy increase ஆச்சு, அப்படினா நம்ம relaxation time வந்து reduce ஆகும். Relaxation time வந்து reduce ஆச்சுனா நம்ம resistivity will increase, okay? When temperature increases, what will happen? Nama resistivity will also going to increase. Now in case of semiconductors, okay, semiconductors la what will happen? So again I'll be just go with, hey, why this is like this, okay? M divided by n e square tau. It's making me irritating, okay? So idhula vandu paathena semiconductors la usually வந்து நம்ம what to say usually வந்து இந்த what to say da number of free electrons ஓட number வந்து கம்மி தான். So அதனால இந்த relaxation time வந்து சொல்றதுக்கு அவ்வளோ relevance கிடையாது. So I'll be just ignoring m e square and tau. So the resistivity will be completely depending upon the number of charge carriers. Semiconductorsல சொல்லும்போது அங்க வந்து holes இருக்கு, free electrons இருக்கு, அதுதான் வந்து number of charge carriers. So when temperature increases, can you please let me know semiconductor chapter வந்து I hope you guys are good in it. So tell me temperature increase ஆகும்போது what will happen to, okay, what will happen to temperature increases, what will happen to the number of charge carriers? Will it increase or decrease? As per semiconductors we have studied, adilirundhu what you will get? Number of free charge carriers, temperature increase aachuna covalent bond will break, அப்படினா free electrons and new holes will be formed. எப்படிடா decrease ஆகும்? Number of holes வந்து definitely it will, number of free charge carriers வந்து it will increase, okay? அதுதான் வந்து semiconductor and the beginning part we are studying it, no? Okay, what we are studying, covalent bond will break, so on the time free electrons and holes will be formed. I mean this is how it is happening, correct? So இப்போ வந்து இந்த value increase ஆச்சுனா what will happen? Resistivity will decrease, okay? So இந்த ஒரு thing கூட you have to study. Now can we go for the next part? Can we go for the next part? It is nothing but the series and parallel combination da, which I think you don't need to get any what to say special coaching for it. My students are very good in the series and parallel. So let us quickly go for the first question, okay? Yes, first question lana, a wire of resistance 4 ohm is stretched to twice of its original length, okay? Length வந்து n times increase ஆச்சு, அப்படினா what is going to be the new resistance da? It is nothing but n square r. இல்லனா you can just go for this what to say, we know that whatever happens the volume will be same, okay? Volume will be same, அப்படினா r dash will be coming as n square r da, n square வந்து 2 da, 2, so it will be coming as 2 square, so 2 square into 4 it will come. Very good, very good. Illana I have shown you here, we have the proper calculation. So we know that exam ku vandu hardly vandu we will be getting 1 minute. So in the madri question ku if you are just going for this method na, definitely it is going to consume a lot of time. So please don't go for that. Please try to study the shortcuts, okay? Yes, another question. Find out the relation between rho alpha 1, rho 2, alpha 2 such total resistance of the system depends upon the temperature. Can you just find it? Can you just find it? Find out the relation between rho 1, rho 2. So we have two resistors, we have two wires. Okay, va? So adula the first one oda resistivity da rho 1, adoda coefficient da alpha 1. And second one oda vanda rho 2, then second one oda coefficient of temperature vanda alpha 2. Now the total resistance of the system depends upon temperature. We know it. So how we can just do this? We know that we can just use this expression. The initial resistance will be equal to the final resistance. Am I right or wrong? So initial resistance it is actually kept, okay, it is actually kept in series. So I can go for rho 1 L1 divided by A1 plus rho 2 L2 divided by A2. Everybody understood till this? Yes or no? Yes or no? Yes or no? Please let me know. Da. Everybody please let me know. How will be the paper? Be so scared, ma'am. No worries. Don't be scared. Because if you are getting scared also, the question is not going to change. Question paper is also not going to change. So let us face it. That's it. Yes. So right now I'm just going to substitute the value for rho 1, rho 2 and everything. Okay, wow. So after some time when we are giving the temperature, how it will change? We know that the equation, what was the equation? Rho naught into 1 plus alpha into delta T. Correct? Okay. So rho naught, it is nothing but what about length? Length ellame on the same da. Okay, so L1, L2 is not need to specify. Area is also going to be same. So I'll also add like this. Okay, so rho 1 into L by A. This is the rho naught into 1 plus alpha 1 into delta T plus rho 2 L by A into 1 plus alpha 2 into delta T. Understood till this, everybody? Just I am putting after some time the temperature will also increase. Appadina number resistance will be varying like this. Correct? So now you can just find the relation LA will be get cancelled from everywhere. Now you just make a relation connecting rho 1, rho 2 and alpha 1 and alpha 2. So in the relation you have to find it. So which is going to be the right answer? Check again. L by A will be cancelled from each and every term. So in the left hand side we will be having rho 1 plus rho 2 and right hand side rho 1 plus rho alpha 1 delta T and we will be having rho 2 plus rho 2 alpha delta T. Now you can make the relation. Yes, very good. Others, please give me the answer quickly. Please give me the answer quickly, everybody. Yes, perfect. We will be getting option A as the right answer. Ready for the next question? Now give me a fire. Ready for the next question? Give me a fire, everybody. Yes. So இப்போ இந்த ஒரு சர்க்யூட்ல இருந்து we need to find the effective capacitance முடிஞ்சிருக்கு மேம், இது resistance. Okay, so we have to find the resistance. Can you find it for me? So இப்போ பார்க்கும்போது let me just redraw this. So இது starting from A. Okay, அதுல இருந்து 2 branches இருக்கு. இது 20 ohm தான் and this is nothing but 40. Okay, so next in the 20 ohm one side la irundhu, in the 40 ohm other side la irundhu, we can just say 70 ohm is also there. Next one paathena, in the 70 ohm one direction la irundhu, we will be having this 50 ohm and here we have the 100 ohm. Correct ada? So this is what our B. Okay, so is it a familiar structure? Is it a familiar circuit? Can I say this is a balanced Wheaton bridge? Because here not 20 by 40 will be coming as 50 by 100. So what will happen? Idu balanced da. So this we can just remove. Now 20 and 50 will be in series, 40 and 100 will be in series, and that will be in parallel to each other. So now let me know what is the right answer for this question. Right answer for this question, everybody. And guys, don't forget to like the session. And also let me just tell you one thing da. Okay, just give me a minute. Okay, very important information. Many students they are struggling with this. Okay. Engada poche. Yes. So, இப்போ வந்து நம்ம session பார்த்தேனா, okay. So, okay. So, இங்க வந்து பார்த்தேனாடா, நம்ம description boxல there are many links are there, correctா? So, இந்த links எல்லாமே வந்து very important links தான். So, நம்ம re-NEETக்கு வந்து இன்னும் கொஞ்சம் days மட்டும்தான் இருக்கு, correctா? So, இந்த கொஞ்சம் daysல if you need to prepare very well and you have to be competitive, அதுக்காக we are providing the free re-NEET crash course, okay. So, அதுக்கு வந்து you can just see here, you can just buy it from here. Right now it is showing ₹2 and all, maybe some technical glitch da. So you can just buy now for ₹0. It is not even ₹2 da, it is actually ₹0 da. They will update after the class, so don't worry about it. So adukapram pathena you will be getting, okay, you will be getting adila வந்து in class doubt solving இருக்கு, and you will be having a lot of features. அது மட்டும் இல்லடா, here you can see all India test series. இதுல வந்து click பண்ணிட்டேனா you will be directly going to the Amazon page. Okay, ₹549 da. Don't think like, okay, I'm going to waste ₹549. Okay, you are wasting a lot of money, but I'm telling you, இந்த ஒரு $549 you are spending na, you are going to get the most probable, okay, the most important repeated questions oda ஒரு collection da, solved question oda collection da you are going to get. Along with that, you will be getting 20 OMR sheet. In the next days la ellame vanda mock test pandrathu, it is very important. So adanal nama 20 OMR sheet kuda you will be getting from it. So idu vanda I mean in very few days la you are going to get it in hand. So don't be so late, because 2000 more than 2000 questions were there. அதெல்லாமே வந்து solve பண்ணனும். அதுக்காக தான் இந்த all India test series we are providing. So again, if you are getting late na, definitely that will affect you. So ₹549 தான். நம்ம வேதாந்தோல many teachers worked together and they made this book. So I mean, do not miss this chance. அதுதான் வந்து எனக்கு வந்து I wanted to tell you. Okay, so right now we are going for the another part of this class. Okay, so where is that? Yes. So tell me what is the answer for this question, everybody. Tell me what is the answer for this question. I want the answer for this question, everybody. Please let me know what is the answer. And guys, don't forget to like the session. Don't forget to like the session. Saravanan, right? Sorry, Aradhya, you do one thing. You just, I mean, you are in 9th grade, right? You just do the 9th grade preparation. And இப்போ வந்து நம்ம வேதாந்தோட foundation materials எல்லாமே வந்து available தான். So if you can manage, okay, அப்படினா you can just go for solving the foundation books. ஏனா வந்து நம்ம state boardல ஒரு problem என்னன்னா, நம்ம syllabus வந்து கொஞ்சம் I mean deep-ஆ இருக்கு. ஆனா வந்து examல questions எல்லாமே வந்து expected தான். So definitely the competition will be less comparing with the CBSE. So right now the thing is like you have to prepare from now onwards and try to get the foundation materials and start your preparation. Okay, we will help you with your preparation as well, don't worry. Okay, so what is the answer? Option B. Very good. Okay, so this is what the one. Okay, now we are going for the Kirchhoff laws. Okay, current electricity we have just few days back we have done this. That is why I'm just skipping all this simple question, simple concept, and I'm just going like this. Just 2 days munadi, I think so, right? Current electricity we have done. So now Kirchhoff current law, or let's say junction rule. What is the meaning of that? The current leaving the junction should be equal to the current entering the junction. And the junction la total current paathena, it will be coming as 0. Okay, next வந்து நம்ம voltage law da. What is voltage law? The total sum of the, okay, the total sum of the potential energy, or let's say the potential, will be, for a closed loop, it will be coming as 0. Okay, the change in the sum of change in potential will be coming as 0 for a closed loop. Understood that, everybody? Yes or no? Yes or no? Please let me know. Can we go for a question? Ready, everybody? Can we go for a question? We have the meter bridge and the Wheatstone bridge. Wheatstone bridge already we have discussed. Okay, balanced Wheatstone bridge na nama resistance order ratio vandu it has to be same, and meter bridge sollumbodhu it is nothing but same as the application da. Okay, nama Wheatstone bridge oda application da to find the unknown resistance. So adukkaga we will be going for S by R, which is equal to 100 minus L divided by L. So in the S da nama unknown resistance, using this we will be keeping, okay, we will be keeping the jockey towards one point. So we will be get some point, we will get the potential will be, or the galvanometer will show 0. Okay, which means there is no potential, which means it is balanced. Okay, so then we will be again using the same equation, we will be get it. So now here is the question. Consider the circuit shown in the figure. What is I3 equal to? Where is I3? Yeah, I3 equal to. So can you just find it, because we did this question multiple times. Okay, multiple times we have done this question. So first one, what we should do? We should mark the current direction. So I'm just taking this I3 order direction, I'm just doing this. Okay, so now I'm just considering this loop. So what will happen? I'm just taking in the clockwise direction. Okay, wow. So the potential across, okay, the potential drop across 28 ohm, adu vandu positive illa negative ada? Is it going to be positive or negative? Please let me know. Current order direction which we choose here, and nama clockwise direction kuda it is going in the same way. Appadina that should be a negative one. So minus 28, let me say this is nothing but I1. Okay, I1. Okay, then next this one, higher to lower potential, again negative, minus 6, again higher to lower, minus 8, which must be equal to 0. Understood till this one, everybody? Yes or no? So ipo vandu current order direction and the direction which we chose, which is same na, definitely adu vandu negative arukum. And in case of this batteries or cells, it has to be, okay, idu vandu higher potential la irundhu lower potential, the direction which we chose, it is coming as clockwise. So adu vandu paakumbodhu higher to lower potential da. So definitely that should also come as negative. Ipo vandu if I am choosing, okay, idukapra I will show you with the anti-clockwise as well. So now we should do it for I1. So in the case illa, what is going to be I1 da? 28 I1 minus 14. So that will be coming as plus 14 over here. So I1 will be coming as minus 1 by 2. Okay. Next one, here I am going for the another one. Again clockwise I am choosing. So how will be the values? How will be the values? How it will be? Can I say that this is going to be I2? So this is same. So 54 I2. Okay. This is going to be plus 12. And this is going to be again plus 6, which is equal to 0. So 54 I2 will be equal to 12 plus 6 will be 18, correct? So what is going to be I2? Can you please let me know? What is going to be I2? Can I say it will be 1 by 3 ampere? Can you please let me know? Everybody? Yes or no? Please let me know. Please let me know. Yes or no? Yes, 1 by 3 it will be coming, 1 by 3 ampere it will come. So now the thing is, like, we know that I1 is the current which is entering into the junction. So I1 must be equal to I2 plus I3. So I1 minus I2 will give me I3. Can you just find the answer for me? Can you just find the answer for me? What is I3? What is I3? I1 minus I2 it will come. I1 na 1 by 2 da, I2 na 1 by 3 da. So what is going to be the answer? What is going to be the answer? Option D. Yes, perfect. So option D the answer. Now for the similar question I will take the anti-clockwise. You guys have to give me the equation. Okay, proper equation. And the loop oda proper equation da you guys have to give. So this is what the anti-clockwise. and current order direction வந்து we will be choose like this. Okay, so this is how it is. Now for this loop, can you just give me the equation? Can you just give me the equation? We will be doing it tomorrow. Tomorrow sharp at 10 o'clock you can join the session. We will discuss. Okay, so இப்போ வந்து இது வந்து anti clockwise தான். So இப்போ வந்து நான் பார்க்கும்போது இது வந்து lower to higher potential. So 8 will be positive தான். Here also it is going to be positive. Yena lower. I'm just going like this. So negative to positive. Again 6 will be positive. And what about this one? Current order direction ippadi da. The direction I chose was in the opposite direction. So it will be again plus 28 I1 da. Okay. Here it is I2. So this will be coming as 0. Can you give me the equation for the second loop if I'm choosing the anti-clockwise direction? Can you please let me know the equation for the second loop? Can you please let me know? Naleki vanda we will be completing the whole mechanics, which means we will be cover kinematics, we will cover the laws of motion, we will cover work energy power, gravitation, and we will cover the rotational motion as well. Okay, so guys, you have to attend that session. 5 chapters we are going to, not just 5, more than 5 chapters we are going to cover in that session in hardly 3.5 hours. So quick vanda you can just finish everything. Okay, so everyone should join the session. Yes, very good, very good. So idu vandu paathena in the current order direction ippadi da, the direction which we choose in the opposite direction. So this will be coming as plus the 54 I2 it will come. Idu vandu higher potential to lower potential, so minus. Here also it will be coming as minus, which is going to be equal to 0. Understood? How it will be? Everything is going to be positive. We have mentioned no, higher to lower na, definitely it has to be negative. Correct? So we will be taking like this. No, so this is how the direction. So higher to lower potential da. So that is negative. This is also coming as negative. Understood na? Give me a yellow heart. If you understood, give me a yellow heart. And don't forget to like the session. Marakama channel subscribe panniko. Everybody. Yes, very good. Just check it. Okay, I got only 3 response, others. Yes, very good. Yes, perfect. So now we are, even if we are doing this way or that way, we will be getting the same answer only. Don't worry about the answer will be wrong, ma'am. Will change irukku ma'am. Appadi edu illada, don't worry about all those things. So next on the number cell, EMF and the internal resistance da. So tell me, what is a cell? What is a cell? My chemistry students inge irukke, correct? Chemistry la neenga vanda detail ah study pannirukke. Adoda oru 0.1% da inga vanda adoda 0% one knowledge da we need it here. So tell me, what is cell? Cell na adu vandu oru device da ma'am, and the device is actually making the chemical energy, it will convert into electrical energy. Correct ada? If I am wrong, you should correct. Ena neenga da vandu chemistry la avlo study pannirukke. Okay va? So ipo vandu in the cell related we should study 3 terms. One is EMF, another one is internal resistance, and third one is nothing but the terminal voltage. Okay, so now I'll be starting with internal resistance. Internal resistance and ஒரு termல you will get to know what is internal resistance. Internal resistance na internal ah irukkiradhu. Okay, ipo vandu இந்த charge is not just flowing outside the cell. Inside also adukulla anode irukke, cathode irukke, electrolytes irukke. When it is flowing through all those things, what will happen da? There will be what? There will be the potential drop will be there. And due to this resistance provided by this electrolyte and all, this is what we are calling it as internal resistance. Understood? Give me a yellow heart, everybody. Understood? Give me a yellow heart, everybody. Okay, so this is the internal resistance. So now another thing is nothing but EMF. Enna in the EMF? Ipo vande the circuit la current edum flow pannala. Yena current flow pannita mattum da in the current will be going through anode, cathode and all this electrolyte. Ana ipo vande current flow pannalena, which means adu vandu open circuit na, definitely, thank you guys, thank you so much. Okay, so definitely what will happen? Current vandu not flowing na, definitely there is no potential drop due to any of the factors. So the potential across anta oru time illa and the cell across irukra potential difference illada adha vandu nama EMF. Ana vandu ipa current has started flowing, appadina definitely what will happen? Yes, more current flow, the potential drop will happen through the external resistance and the internal resistance. So obviously nama potential across nama cell paakumbodhu it will be a kammiyana value da varaporum. Okay va? Thank you da, thank you da, thank you da. I will adjust with the red heart, no worries. Okay, so this is what the thing. Okay, terminal voltage சொல்லும்போது it is nothing but current வந்து closed circuit ல. Okay, closed circuit na current will flow from one point to another point. Okay, அந்த ஒரு டைம்ல potential drop இருக்கும். Okay, through the internal resistance, through the external resistance. Second point is like, okay, இப்போ வந்து இந்த external resistance எதுவும் connect பண்ணல, it is actually an open circuit. இதுக்கு வந்து current flow பண்றதுக்கு there is no other option. அப்படினா அந்த டைம்ல இருக்கிற terminal voltage தான் actually வந்து EMF. Okay, EMF and terminal voltage both are same. ஆனா EMF we will say specifically when it is a open circuit, when there is no current flow, and equations are like this. The EMF will be, I'm getting step by step confidence. Very good, very good, very good, very good. Thank you so much, thank you so much. And my energy is also losing step by step. That is what another factor. Okay, so இப்போ வந்து charging and discharging இருக்கு. Discharging na, let us say இப்போ வந்து நம்ம we know that correct let us say நம்ம battery ல இருந்து தான் flow is actually, இல்லனா cell ல இருந்து தான் current is actually coming. Okay, இல்லனா let us say while we are charging the mobile இல்லனா laptop, what is exactly happening? Outside source ல இருந்து தான் current வந்து இந்த செல்லுக்குள்ள வரப்போறேன். So this is what charging and discharging. So charging illa definitely in the terminal voltage illa and the external source oda voltage da it should be the maximum. புரிஞ்சுதாடா everybody? Got it? Yes or no? So now we understood while charging V has to be very big value, while discharging E has to be a big value. Like and subscribe guys. Yes, Sanchu, I'm with you. Okay, I'm also supportive. So right now this is one the thing, and this is the equation for the current and this is for the equation for internal resistance. Idukku vandu separate you don't need to study this equation and all, you can just study this equation. Okay, you can just study this equation. Idhula irundhu you can find all the rest of the equation. Next vandu nama combination da, combination la ovvaru equations ume important. Okay, we can expect questions also. Least priority da, but definitely we have to expect. There are years they have asked these questions. Okay, so ipo vandu cells are connected in series na, it will be coming as NE divided by R plus NR da. When it is connected in parallel, it will be coming as ME divided by MR plus R da. And two different cells in parallel na, it will be coming like this, E1 R2 plus E2 R1 divided by R1 plus R2, and adoda R equivalent, adu vandu internal resistance ah irukadum external resistance ah irukadum, parallel and series combination la same equation da nama vandu follow panna porom. Okay, so these are the important things, and nama energy power, electrical power energy equation da. So these are also very important. Idu vandu you already know it. Okay, nama energy sollumbodhu it is nothing but V into I into T. V into I into T da energy oda expression. Yena V into I na adu vandu power da. Okay, power into T da actually vandu energy illana work done. Okay, okay, so these are the important equations and everything. Now let us just do some more questions. Adukapram we can just go for the next chapter. Okay, let us go for it. Yes, everybody. Guys, marakama like panikoda everybody. So what is the question? Internal resistance of a 2.1 volt cell gives a current of 2 ampere through a resistance 10 ohm. Very simple. We know nama equation vandu E is equal to V plus IR da, correct? So appadina E minus V divided by I will give you the R value. Now tell me which is going to be the right answer. I will definitely Kritika illana nama Re-NEET exam la You need my support, right? So definitely I'll take care of my health. Sure. V value na, it is nothing but IR da. Sure da Pravina, sure. V na I into R. Tell me which is going to be the right answer for this question, everybody. Everybody quick let me know da. Simple ana oru calculation. D, check again. 2.1 minus 20 divided by 2. அது வந்து 21 ah. It is actually 2.1 da. Not 21. Question wrong ah. Oh my god. Question wrong ah varudha. Question wrong. Who has mentioned that? Very good. Question wrong da. Okay. You won't be getting the answer, so let us just take it 21. Now I think it will be, options are wrong. Either it will. Okay, anyway, this is the method we have to do. Okay, so that is what we need to know. So idhula vandu 21 na, maybe you will be getting the right answer. So illenalum method vandu purinjiruchilla everybody. Everybody got the method, yes or no? Yes, IPL bro. Thank you da. See, I have accepted. Okay, perfect. So now let us move on to the next question. 2 bulbs irukke. Okay, it is connected in 440 volt line. Which one is likely to fuse? This is the question. So how we will be doing this one? So right now the thing is like we know that power is given. So the thing is like I have already mentioned you. This is what the rated values. Okay. Ipo if you are applying in 220 volt, if you are giving na, it will be giving you 25 watt power. And the second bulb if you are giving in 220 volt na, definitely it will be giving you 100 watt. Ana right now we are going to give 440 volt. So definitely it cannot give 25 and that cannot give 100 watt. Purinchidada? Everybody understood, yes or no? Everybody understood, yes or no? Please let me know. Everybody. So what I was saying, so if we are giving, okay, in the bulb on the 220 volt apply pannitena, it can provide 25 watt and this can provide 100 watt. Ana right now I am going to give 440 volt line. Appadina the power will be different. So now you can just find the power in both the cases. So now you can just go for the maximum current which can, okay, the maximum current which it can go. So we know that power is equal to V by I da. So we can just go for power divided by V will be giving you the maximum current. So it will be 25 divided by 220 and also 100 divided by 220. So இப்போ அந்த values பார்க்கும்போது definitely 100 watt can have more current, correct? More current. So definitely we can say that the 25 watt will definitely fuse before the 100 watt. புரிஞ்சுதாடா? Yes or no? Please let me know guys, please let me know. Understood? Illaya? On 29th da, 29th illana tomorrow you can join, tomorrow Deva. Tomorrow வந்து half of the 11th portions we will finish. Perfect? Yes, fine, fine, fine. So this is what the thing, power is equal to VI. In the equation use பண்ணி maximum current வந்து we will be finding. So on the equation, on the values வந்து பார்க்கும்போது obviously we know that அந்த 100 wattக்கு வந்து it can have more current அதில் வந்து pass பண்ண முடியும். ஆனால் வந்து 25 wattல் அது வந்து முடியாது. So definitely this will fuse immediately. So in the given figure, the zero deflection in the galvanometer of the meter bridge, find the length AB. Find the length AB. So how we will be doing this? How we will be doing this? We know that the resistance across AB divided by R1, which is equal to the resistance across BC divided by R2. Correct? Yes or no? Can I write it like this? Can I write it like this? Idhilirundhu we have to find the RAB is given, sorry, R1 is given, R2 is given, and RAB vandu you can just substitute as L, and this one is 100 minus L. Adilirundhu you can find the L value. Find it and please let me know. Please let me know, everybody. Detail நம்ம current electricity oda lecture வந்து I have done before. So if you wanted, you can go for it. இது வந்து அவ்வளோ simple we have done in 1 hour. Sharp, I mean in 55 minutes we have done the current electricity part. Okay. So now we can go for the next set of chapters, which I'm going for modern physics. Yena magnetism kuda I have done in the last class. So I have planned to take at the end if we are getting time. Okay. Just yesterday or day before yesterday I have taken magnetism. So I will be taking at the end of the session if we are getting time. Okay, I wanted to finish the lecture by 7 o'clock, 7:30. So let us see da. So right now it is already 3:45. Okay, yes da, very good, very good. Option B da, option B da. Okay, so now we will be going for modern physics. Adukapram ray optics, I mean optics completely we will cover. Adukapram all the small kutti chapters we will finish. Okay, that is what I have planned, and whatever we can finish, that we can do it. Okay, so let us go for modern physics. Ready? Ready, everybody? Please let me know. Ready? Tell me da. Are you guys ready for the modern physics? Yes or no? Yes. So let us go for it. Okay. So, yes. So first one, we can just go for the dual nature. In the modern physics, we can just again go for a little long break because I too wanted to have something. Okay, so just hold on da. Let us just finish this modern physics also. Adikapram we can just relax. Okay, for some time. Adikapram we can again continue. Ready? Give me some fire if you are ready. Give me some fire if you are ready. Yes, perfect. So appadina now we will be starting with dual nature. Dual nature la first vandu we should know what is this emission. Okay, so electrons over metal lume irukra electrons ku vandu if they are getting enough amount of energy, what they will do? They will escape. Okay, they will escape. Okay, so the enough amount of energy we can give it in different modes. So now tell me what is thermionic emission, what is field emission, and what is photoelectric effect. Okay, so basically in the three processes lume electrons vandu sufficient energy kadachena they will escape. So thermionic emission na adula vandu energy will be given by the thermal energy illana nama heat da. Second one is nothing but nama field emission, strong electric field da nama vandu we are going to give, and nama photoelectric effect illa light with suitable frequency da we are going to provide. Understood everybody? Please let me know. Please let me know, everybody. Got it or what? And in the beginning, a few people have told me, ma'am, na irukku ma'am, promise ma'am, I will be there from the beginning to the end. I will be there, ma'am. And the madri solla students, when they right now, can you just give me a fire? Yeah, a few students when I cannot find it from here. That is why. Ma'am, na irukku ma'am, appadi da promise panna. Yes, Hajar. Yes, Padmav. Okay, very good. So அப்படினா first வந்து we understood about this emission. Next வந்து I am just becoming more specific about photoelectric effect. ஏனா நம்ம dual natureல அந்த ஒரு chapter தான் actually வந்து அவ்ளோ பெரிசா இருக்கு. இல்லனா photoelectric effect தான் we are actually discussing more. So in the photoelectric effect ila light with suitable frequency. Why we are saying light with suitable frequency? ஏனா நம்ம photon-ஓட energy என்னன்னா h𝛎 தான். So basically in the photoelectric effect ila இதுதான் வந்து let us say இதுதான் வந்து நம்ம what to say டா நம்ம metal. Okay, இந்த metal-க்கு வந்து metal-ல definitely நம்ம valence electrons இருக்கும். அந்த valence electrons-க்கு sufficient energy கிடைச்சேனா it can escape. So இந்த electron அது என்ன particle தான். So இப்போ வந்து இந்த லைட் வரும்போது அந்த லைட்டுக்குள்ள ஒரு பார்ட்டிகிள் இருக்கணும்ல அந்த பார்ட்டிகிள் தான் ஆக்சுவலா வந்து நம்ம photons. Okay, so definitely இந்த photon லைட் வந்து fold பண்ணும்போது what actually happening இந்த photon தான் இந்த electrons interact பண்ண போறோம். So இந்த photon-ஓட energy depend பண்ணி தான் இந்த electron-ஓட emission. Okay, understood everybody? Please let me know. இப்போ வந்து I'm telling you. Okay, I will be giving you some exactly. Okay, நம்ம NEET exam-க்கு what is the தேவையான topics இல்லனா questions வந்து I will give you. So if you are getting enough amount of questions or enough amount of content, then only you can prepare well for the exam, right? So அந்த மாதிரி நம்ம electrons-க்கு sufficient ஆன energy கிடைக்கணும் from this photons. So இந்த photons-ல இருந்து they will be getting some energy. அந்த energy அந்த energy கிடைச்சேனா definitely this electron will escape. So இந்த photon-ஓட energy-னா that is nothing but h𝛎 தான். And ஒவ்வொரு மெட்டீரியல்லும் இருக்கிற electrons-க்கு அவங்களுக்கு தேவையான ஒரு minimum energy இருக்கும். அந்த minimum energy is called as what is that minimum energy da? Can you please let me know what is that minimum energy? What is that minimum energy? Please let me know. Lots of love from Tirunelveli. Okay, okay, so Pravina is from Tirunelveli, right? Okay, yes. So right now what is that value? Very good, Soumya. அது வந்து work function தான். So ஒவ்வொரு மெட்டீரியல்லுமே இருக்கிற work function depend பண்ணி தான். Okay, work function depend பண்ணி தான் ஆக்சுவலா வந்து what to say நம்ம ஆக்சுவலா வந்து word டா இதுதான் வந்து I have lost the connection. எனக்கு ஒண்ணுமே புரியலடா. Yes. Okay, so work function. Yes, work function. So இப்போ வந்து அந்த work function அந்த அளவுக்கு எனர்ஜி கிடைச்சா மட்டும் தான் ஆக்சுவலா வந்து இந்த எலக்ட்ரானுக்கு எஸ்கேப் பண்ண முடியும். So the condition for photoelectric effect, why we are saying the light with suitable frequency na in the energy of the photon should be greater than the work function. And the work function விட energy இருந்துச்சுனா definitely there will be there will be photoelectric emission will happen. So now next point is இப்போ வந்து yes இந்த electronக்கு வந்து 1 unit energy போதும் and I have given 3 units of energy. Where this 2 unit will go அதுக்கு தான் நம்ம ஐன்ஸ்டீனோட ரிலேஷன். Okay, இப்போ வந்து energy of the photon will be utilized for two purposes. First வந்து priority நம்ம work function இந்த electron வந்து escape ஆகணும்ல அதான் வந்து நம்ம first priority. Second thing is nothing but இது வந்து இதுக்கு அப்புறம் இந்த escape ஆனதுக்கு அப்புறம் it has to move, right? It has to move. So definitely yes, very good Yokita, very good Sanchu, Padmav and Samiksha. So the kinetic energy it will be converted as the kinetic energy. So adha vandu inge irukke E which is equal to the energy of the photon which is equal to work function plus the maximum kinetic energy. Illana kinetic energy will be converted as potential energy when we are changing the polarity. அப்படினா நம்ம energy of the photon will be coming as h𝛎0 plus E into Vs. E into Vs na அது வந்து nothing but நம்ம potential energy da. Till this understood everybody? Please let me know till this understood? Of course Kritika, I will teach. Of course straight line irukku ella chapters me irukku. I have mentioned no nama straight line, plane, laws of motion, work energy, gravitation, rotation edachu chapters miss pannirka illa. Okay, so இதுதான் வந்து actually வந்து நம்ம பேசிக்கான கான்செப்ட். Okay, Next வந்து few relations we should know. Okay, which means இப்போ வந்து I'm just increasing the intensity. Intensity increase ஆச்சுனா brightness is increasing. அப்படினா currentல ஏதாச்சும் ஒரு difference இருக்குமா? Which means இப்போ வந்து இந்த electron is escaping from the metal surface and it is moving na definitely electron ஓட flow. அது வந்து current தான். அது வந்து specifically we will be call it as what? Photo current. Okay. Units and measurements எல்லாமே வந்து 29th குடா 29th க்கு again class 11 ஓட complete revision இருக்கும். Okay. I'm actually weak in physics. Now I started to like physics. Thank you so much. Thank you so much, Praveena. Thank you. Okay. So right now, okay, I think everyone's confusion, everything is sorted, right? Let us continue. Yes or no? Yes or no? Yes or no? Quickly, you please let me know. Yes or no? You know, sometimes I'm losing the connection. I'm just thinking like, what is happening right now? Yes, Pumati. What is the meaning of Pumati? Poo, which means flower, right? Yes. So அப்படினா இப்போ வந்து இந்த photo currentல ஏதாச்சும் ஒரு change இருக்குமா? Intensity increase ஆச்சுனா what is your opinion? Definitely there will be change, ma'am, because intensity increase ஆச்சுனா number of photons is going to increase. Number of photons na one photon will interact with one electron da. So when there is more number of electrons, more number of photons na, more number of electrons will be ejected. Flower moon. Okay, very good. Okay, so definitely we can say that intensity is proportional to nama photo current. Adudha vandu inge irukke the first one. Okay, current and intensity we have plotted. Now again I'm going to ask you, ipo vandu intensity increase aachuna edachum oru difference irukuma? Nama stopping potential la edachum oru difference irukuma? Definitely not, ma'am. Yena vandu potential energy is completely depending upon the extra energy da. Energy வந்து extra வரணும்னா நம்ம frequency வந்து அதிகமா இருக்கணும்ல. So frequency change ஆனா மட்டும் தான் actually வந்து நம்ம stopping potential change ஆகும். இல்லனா it is not going to change. Intensity changes but the saturation current will change. ஆனா வந்து stopping potential remains the same even if you are increasing intensity more and more நாலும் there is no nothing. Okay. Yes. But I'm noticing for the first time, Bhumadi, sorry. Okay, so next வந்து இப்போ வந்து frequency increase ஆச்சுனா what will happen to photocurrent? Can you give me the answer? Frequency increase ஆச்சுனா what will happen to photocurrent? Frequency increase ஆச்சு, what will happen to photocurrent? Please let me know da. Everybody please let me know. Frequency increase ஆச்சுனா yes, there is no change. Why? Because frequency and photocurrent is having no dependence. Okay, it will be just, okay, it will be just, we can say that, okay, 1 second. One second. Yes, da. So right now we can say that it is independent of frequency. Very good. So next one is nothing but in the frequency increase aachna stopping potential la edachu change irukuma? Stopping potential la edachu oru change irukuma? Please let me know. Of course, ma'am. Of course, frequency increase aachna stopping potential kuda it is going to change, and that is what you can see in this figure. Okay, next one vanda, if I am plotting frequency versus the stopping potential, now I will be getting straight lines like this. Okay, this is again another important statement. Okay vada. Next vanda ipo vanda I have discussed about, okay, in the light illa irukra particle behavior patti da I have discussed. So ipo vanda nama matter kulla edachu oru body I mean if you are considering na adula vanda definitely wave properties irukum. Adha vanda we are calling it as matter waves, illana we can just call it as de Broglie waves. And the wave oda wavelength vanda h by p da. H na Planck's constant and p na nama what is a momentum da. Okay, wow. So that is nothing but momentum. So we can just rewrite in different format. Lambda is equal to h by p. or h by mv or let's say h by root of 2 into m into nama kinetic energy. Okay, so this is what about the waves. Next வந்து நம்ம photon discuss பண்ணும்போது we should understand what is radiation pressure. ஏனா radiation pressure, radiationக்கு pressure exert பண்ண முடியும். Okay, இந்த lightக்கு actually வந்து pressure exert பண்ண முடியும். அந்த pressure ஓட value வந்து we have to study. So இதுல வந்து two equations இருக்கு. One is nothing but let us say இப்போ வந்து it is actually, okay, the light is actually falling on a reflecting surface, which means the photon will come and it will just stick over here. அதுக்கப்புறம் it will reflect. அப்படினா அந்த radiation pressure வந்து 2I by C தான். What is I? Can you please let me know what is I? What is I? இப்போ வந்து the photon will be come and it is on the reflecting surface, it will reflect back. அப்படினா அதோட radiation pressure ஓட value வந்து 2I by C தான். I னா intensity தான். Next வந்து absorbing surface. Absorbing surface என்ன? இந்த light will, okay, இந்த photon will come and fall. அதுக்கப்புறம் no reflection. அப்படினா radiation pressure வந்து I by C தான். புரிஞ்சுதாடா everybody? Please let me know. Please let me know everybody. Till this understood, give me a yellow heart. ஏனா வந்து we have completed dual nature. Okay, dual nature completed. Okay, so let us go for a question. Ready? Yes, perfect. So in the dual nature I'm just going to ask you a question, so you can just do it. Meanwhile I'll be just take some water and I will come. Okay, just do this, I'll come. Okay, and also those who want to take water and all, just go and take and then solve the problem, because now we have to be hydrated. Everybody got the answer? How you will be finding it? Simple or question, right? Which equation we can use it here, da? So our work function or expression da we need it. So it is nothing but h is E by lambda da. So lambda one that is given in the question, 400 nanometer. So yes, very good, very good. We will be getting option B as the right answer. Very good, very good. So another question, quick up, please let me know. What is the answer for this question? Everybody? The work function of a metal is 4 electron volt. If the light is 400 nanometer incident on it, then we already got it. Okay, in the previous question, we already got the, what to say, nama work function order value, if it is coming like this, it is coming as 3.1 electron volt. அப்படினா இங்க வந்து work function 4 electron volt da. So definitely we can say that this is not going to happen at all. So we can say option A is going to be the right answer for this question. Now let us move on to the next question. What is in this question? When a light of wavelength falls on a metallic surface of stopping potential is given, if the second light is having a wavelength twice that of the first light used, what is the stopping potential drop to 0.7 volt. The wavelength of the first light is. This is the question. Okay, va? So let us just do this da. Light is given wavelength falls on a metallic surface of stopping potential. So let us just write the equation. Hc by lambda, which is equal to work function plus E into stopping potential. So that was nothing but 3.2 E into V da varaporu. And if the second is having a wavelength twice of the second, okay, twice of this first na, so this will be coming as Hc by 2 lambda, which is equal to work function plus 0.7 EV. Okay, now the thing is, like, you can just see that in the two equations vandu paakumbodhu, you can just see one thing, you can just subtract both the sides. Okay, you can just subtract. Appadina what you will be getting on the left hand side, you will be getting Hc by 2 lambda, work function will be get cancel. So 3.2 minus 0.7 electron volt you will get, and Hc order value one you know it, you can just substitute and tell me which is going to be the right answer for this question. Everybody please let me know. What is going to be the answer? Others, everybody please give me the answer. Everybody. Is it time consuming? Check again da, check again. Maybe calculation error. H வந்து 6.6 into 10 to the power minus 34, C வந்து 3 into 10 to the power 8, divided by நம்ம value வந்து we can just substitute. இது வந்து 2.5 electron volt it will come this side. Okay, 2.5 electron volt, and in the 2 வரும்போது we can just say 1 by lambda, which is equal to 5 electron volt divided by Hc. So lambda will be coming as Hc divided by 5 electron volt. So please let me know. Yes, very good, very good. We will be getting option B as the right answer for this question. Very good, very good, very good. Super. So now let us move on to the next question. The de Broglie wavelength of oxygen at 27 degrees Celsius is given x into 10 to the power minus 12. The value of x is, okay, so that is what we need to find. So the mass is given, Boltzmann constant is given. So right now we know that the wavelength will be coming as h by p da, correct? H by p da. So now we can also write it as mv, or otherwise we can just write it as root into 2 into m into kinetic energy. Kinetic energy I can just convert as potential energy, which means I will be getting q into v, correct? Or otherwise in case of gas, okay, in case of gas I can just rewrite this energy as, okay, I can just rewrite this energy as 2m into 3 by 2 kBt, okay. So 2 gone, so I'll be getting h divided by root of 3m kBt. All the values were there, right? Mass is given, kb, nama Boltzmann constant is given, and nama temperature on the 27 degrees Celsius da. So temperature will be coming as 300 Kelvin. Can you find the answer? Ma'am, can you please reply instead of bank account number, the form automatically uploaded my application number. What should I do now? You just wait, because they will be again gave a time for it. You didn't upload any of your bank account or anything. No one. Nothing has been updated. So we can just check it out, okay? No worries. You just put a comment after the class, okay? I will just check and I will let you know. No worries. So now you can find the lambda value, everybody. What is the answer coming? Yes, approximately you will be get it as option 26 it is coming. So option D will be the right answer. Now let us go for the next question. The energy of a photon is equal to 3 kilo electron volt. Calculates its linear momentum. Linear momentum. What is the equation for linear momentum? It is nothing but energy by C. Energy or equation is already there. Now you can just divide it with C. 3 into 10 to the power 8. Everybody, give me the answer for this question. Yes, very good, very good. We will be getting option B as the right answer. Very good. I hope everyone is getting the answers, doing the calculations, right? Okay. No, Veda, you can leave. That is the only option right now. Okay. No way, no way, no way. Okay. Now, let us go for the next question. Okay. Here we have 2 milliwatt laser operates at a wavelength of 500 nanometer. The number of photons that will be emitted per second. So right now power is given. What is power? Power na energy by time da. Correct? Energy na h mu by t da. What is given here? What is given here? The wavelength is given. So I am just rewriting. This will be hc by lambda into t. So, if there are n number of photons, the total energy will be n times it will come. So, power into lambda divided by hc will give you n by t. So, now you can substitute and please let me know what is going to be the answer. Give me the answer, everybody. Everybody give me the answer. Check again, check again. Maybe calculation error. Why calculation error? Yes. Option A, yeah. Why everybody is getting wrong answers? Yes, I think I got the wrong answer. Option A is the right answer now. Okay. Now can we move on to the another chapter, atom? Atom. Can we go for atom? Are you guys ready for atom? Are you guys ready for atom? Yes or no? Please let me know. Ready? Now give me a fire. Yes. Okay, then we are going for the another chapter, nothing but atom. Okay. So, in the chapter atom, we should discuss about the structure. Okay, again, chemistry students will help me with this. Okay. So, Hajar, actually, nama modern physics, almost all the questions we have discussed in the previous session also. That is why I thought like I can just skip all the questions. Okay. And again, we are almost 4:15. We have few more chapters to cover. That is again a huge thing. So, I don't know. Okay. So, let us see it anyway. Okay. If the end of the session, if we can. And also, I have, modern physics separate. I think we have done a session recently, right? Okay. And anybody is feeling hungry? Hungry, anybody? So, in the atom and the nucleus, we can just go for a little long break. Okay, no worries. So, on the time you can just put your mobile phones on charger, laptop on charger, and you can just explore some time. Okay, you can just go out let us say what to say, good air. Okay, all the what to say, the complete in the study environment you can go for a good environment. Okay, fine. Okay, yes, let us continue. Ready? Even I am feeling tired, but the thing is like we should finish as soon as possible, right? And I just wanted to make sure in the day maximum number of chapters finish pannanom. At least nama high weightage finish pannanom. Apdi I'm just planning, so I don't know what will happen and all. Okay, yes. So, now the first one, we will be going for the Thomson's model, atomic model, plum pudding model. So, the charge will be spreaded out with the space and electrons will be embedded in it. It is something like the plums in the pudding. Okay. So, the positive charge is spreaded and the plums are the negative charges. That is what Thomson's atomic model. Adukapram nama Rutherford model. Rutherford model is actually explained on the basis of gold foil experiment. So, actually, can you please let me know what happened? Super. Yes, Dishant. Aditi is not here. We are here. Okay. So, right now, gold foil experiment. And he is thinking like, who is Aditi? Okay. Yes. Now tell me what happened in the gold foil experiment. Can you just explain? Can you explain what are the things happened in the gold foil experiment? What happened? Amada, enna panna mudiyum. Idukku we cannot do anything. Okay, let us just see and just enjoy after some time. Okay, so right now idellame distract pandradhukku da. Don't even think about those kind of blah blah stuff. Okay, so now we are just going for the gold foil experiment. Gold foil experiment, what is happening? Almost all the particles has reached the target, which means at majority ana space empty da. And atom have nucleus. Yes, only few alpha particle deflected. Very good, Praveena. Very good. Okay. So, which is indicating that there is actually a dense positive charge at the center of this atom, which is known as the nucleus. Okay. Adukku nucleus irukku. And also, he couldn't explain anything about the stability. Okay. He couldn't explain anything about the stability and the spectrum. Right now, adukapram Bohr has given a new theory for this one. So, actually he can explain a lot of things, but still it is limited to hydrogen or hydrogen like ions. Okay. So, first point enna. Okay, first point enna. Actually and the madri oru aale illada. So, he is just imagine. So, you guys just ignore. Okay. So, just listen here. So, right now even we are also exhausted, right? Okay, let us just see the drama. So, right now Bohr's atomic theory. Adula first postulate enna, ipo in the electron is revolving around the nucleus, right? So, and the electron is revolving around the nucleus na adukku stable irukanum. Okay, adukku adu fixed orbit la da actually it is revolving. அப்படினா அதுக்கு வந்து ஒரு centripetal force இருக்கணும்ல அந்த centripetal force is provided by the electrostatic force da which means நம்ம Fe which means நம்ம K into nucleus ஓட charge சொல்லும்போது Ze da and electron oda charge வந்து E da so it will be coming as Ze square divided by R square will be equal to நம்ம centripetal force. And another thing which he has explained is nothing but about the angular momentum. இப்போ வந்து இந்த electron is revolving around the nucleus in a circular orbit na அதுக்கு வந்து ஒரு angular momentum இருக்கணும்ல அந்த angular momentum தான் actually வந்து nh by 2 pi புரிஞ்சுதாடா everybody. And also நம்ம third postulate வந்து it is nothing but the emission and absorption spectra da which means whenever an electron is at the higher energy level it wants to come back. Okay, it wants to come back. Definitely what will happen? இப்போ வந்து it has to release a h-mu photon. Okay, ஒரு photon வந்து it has to remove which means h-mu energy he has to or let's say the electron has to remove. Okay, இப்போ வந்து lower energy state ல இருக்கு it wants to go to the higher energy level na it should absorb a photon which means it should have an energy h-mu அதுக்கு வந்து sufficient அந்த ஒரு எனர்ஜில இருக்கிற ஓகே அந்த ஒரு ஸ்டேட்ல ஒரு ஃபிக்ஸட் எனர்ஜி இருக்கும் அந்த எனர்ஜி கிடைக்கிற வரைக்கும் ஐ மீன் அந்த எனர்ஜிக்கு ஈக்குவலன்ட் ஆன photon வந்து it has to absorb and it will be going to the upper level which means E2 minus E1 which is equal to h-mu. புரிஞ்சுதாடா everybody? Yes or no? Please let me know. Give me a yellow heart if you understood, guys. If you understood till this, these are all theory things. Now we are going for the mathematical part. Ready ya? Ready ya everybody? Ready ya da? Yes, perfect. So idhula vandu paathena definitely nama electrons are revolving around the what is a nucleus, right? So on the nth orbital radius வந்து find பண்ணனும்னா you can just study, don't study all those things, just study 0.53 n square by z. Okay, n na on the nth orbital. Okay, which orbit you wanted to find the radius and the number வந்து you can just put it down. Okay, so Rn will be proportional to n square z da. And also next வந்து இந்த velocity இப்போ வந்து இந்த electron oda velocity find பண்ணனும்னா you can use this equation z by n. And next வந்து நம்ம energy da, energy வந்து minus 13.6 z square by n square da. Okay, so energy will be proportional to z square by n square. In the proportionality relations எல்லாமே வந்து you guys have to மறக்காம you have to study. எங்கயாவது short notes இருந்துருச்சுனா definitely you have to study. Okay, just give me a second da, just give me a second. Okay, 1 second. Okay, so these are the important relations that you guys have to study in this chapter atom. So next one வந்து நம்ம kinetic energy, potential energy and the total energy ஓட relation தான். Kinetic energy வந்து எப்பவுமே பாசிட்டிவா இருக்கும் and அது வந்து it is equal to total energy தான். ஆனா வந்து total energy வந்து நெகட்டிவா இருக்கும். That is the only difference between kinetic energy and the total energy. Kinetic energy க்கு வந்து if you are putting a negative sign na that will become a total energy. Now the thing is like இப்போ வந்து இந்த kinetic energy வந்து if we need to make a relation for the potential energy. Okay, potential energy na minus 2 times kinetic energy da nama potential energy, and in terms of total energy 2 times of total energy da actually vandu potential energy. All these relations are very important. Understood everybody? Please let me know. These relations are very important. Direct ah vandu questions kekkuradhukku chances irukku. Okay, and next one vandu nama Rydberg constant da adoda value da it is written over here 1.1 into 10 to the power 7 per meter da actually vandu adoda value varudhu. Okay, Vada. So these are the things which we should study, and time period is also there. Time period order in the relation kuda you have to study. Okay, in the relations mattum podum, you don't have to study all the values and everything. Just study the relation. In the energy order case you have to study the minus 13.6 and all. The rest you can just skip it. Okay, rest of the values whatever coming you can just study the proportionality relation. Okay, so these are the things in the atom chapter, and also one more thing is there too. Ipo vanda emission spectra, absorption spectra we have studied, right? Ipo vanda in the lower energy level irukumbodhu illana higher energy level irukumbodhu, if it needs to come back to the lower energy level na, okay, lower energy level na, definitely what you should do, you have to, okay, you have to do one thing, okay, yes da, yes. So, okay, so this is what, okay, definitely da, don't worry. Okay, so right now, Nama, what we said, when we are talking about the electrons is jumping from a higher energy level to the lower energy level, na, definitely it has to release a photon, and the wavelength of that particular photon we can just find it, okay, we can just find it using this relation, which means Rz square into 1 by Ni square minus 1 by Nf square. Purinchidada everybody? Give me a yellow heart if you understood, everybody. Everybody please do try to focus over here da. Okay, so yes. So nama 1 by lambda vanda, it will be coming as Rz square into 1 by Ni square minus 1 by Nf square. Okay, so ipo vanda we understood this one, right? So idila vanda when any of the, okay, when any of the electron is jumping from the higher any level, which means from infinity irundu kuda it is possible da, it is coming to the lower energy level na, okay, lower energy level na, facing some network issues da, so sorry for it, okay, just within few minutes it will be sorted, don't worry about it, okay. Okay, so now we will be, okay, we will be going for the, yes da, but this is the problem, I'm again I'm trying. Hello, hello, am I audible da? Yes or no? Okay. So let us just continue. Okay. So right now, ஏதாச்சும் ஒரு energy level இருந்து, okay, ஏதாச்சும் ஒரு energy level இருந்து, if it is coming to the lower energy level and it is coming to the ground state na n is equal to 1. Okay, ground state na n is equal to 1. அந்த ஒரு stageல, if it is coming na, okay, you don't have any other job. Okay, don't have any other job. Please let me know. Okay. Just let us just, what to say, take it as a compliment. Okay, you just say this to everybody. Okay, and I don't know whether you are a student or what. Just keep some manners. That is what, I mean, we are all human beings, right? Okay, just keep some manners. If it is not possible, you just do whatever you want to. Okay, so right now what is happening? It is actually coming to the lower energy level, which means the ground state. Now I will call that as Lyman. Okay. Sorry Srimukhi, I'm just saying sorry on, okay, I'll do it, but facing some issues da. Okay. So right now, if it is to the first excited state na definitely n is equal to 2 da, and that is what we have called it as Balmer. Okay, and if it is to the second excited state, n is equal to 3. Okay, it is coming to any of the higher energy level, if it is coming to the, okay, thank you da, thank you so much, okay. So it is coming from any of the higher energy state to the what to say nama lower energy state, which is nothing but nama second excited state, which means n will be 3 now we will be call it as passion, n is equal to 4 now we will call it as bracket, and n is equal to 5 now we will be call it as fund. Understood everybody? So this is what the major thing that we have to understand, and in all the cases different things. Okay, final energy state is 1 and initial energy state can be from anything. Okay, first excited state la irundhu illana second excited state la irundhu illana infinity la irundhu kuda this is possible da. Okay va. Next one is nothing but inga vandu pathena Balmer final vandu 2 da, and initial vandu again from infinity to till 3. Okay, second excited level varaikkum varala, and if it is from infinity to the corresponding level now what is going to be the lambda value I have written over here. So these are the important facts that we should study in this nama atom chapter la irundhu idudha vandu we need to study. So let us go for solving some of the questions. Ready na? Give me a fire everybody. Ready na? Give me a fire everybody. If you are ready for it, give me a fire. Quickly give me a fire. Perfect. Question irukku, answer kuda irukku. So but we should know how to do it. Okay, so what is the question? The energy required to remove one electron from a singly ionized helium atom. Okay, singly ionized helium atom. Okay, one second. Yes. Okay, singly ionized helium atom is 2.2 times the energy required to remove an electron from the helium atom. The total energy required to ionize the helium atom completely. So this is the question. Okay, va. So energy required to remove an electron from singly ionized helium atom, we can just find it. Okay, what is going to be E1? We know 13.6 Z square சொல்லும்போது helium lada, helium. So what is going to be the Z value? It is nothing but 2 square. And what is going to be the N value here? It is nothing but 1. So can you just find the answer for it? 13.6 into 4. It will be coming as I think 54.4 electron volt. I guess so. Correct? 54. Okay, 54 point. Can you just check it? Can you just check it everybody? Can you just check it everybody? What is the value of coming? E1 which is equal to 13.6 into 2 square. 2 square na it will be 4. So I guess it will be 54.4. Yes, Amiksha, it will be coming as 54.4 electron volt da vandu nama energy oda expression varudhu. Correct? Energy oda expression. Next vandu just read the question da. You can see that ionized helium atom is 2.2 times. So which means I can say that E1 is nothing but 2.2 times the E2. Okay, 2.2 times E2 da. Appadina, can you find this E2 value? Can you find this E2 value? Yena vandu E1 already got it. So 54.4 electron volt divided by 2.2 will be giving you the E2 value. What is that value? What is that value? Can you please let me know? Yes, exactly. E1 and E2 we will find and we will then add. Yes, perfect. Now tell me, what is the E2 value coming? What is the E2 value? $24.7 it's coming. Then after that you have to add these two values, okay? In the value and this value you have to add and you should tell me what is the answer. Tell me what is the answer, everybody. Tell me the answer. Very good, very good. So what is the final answer? Option A, B, C, D, ellame irukku. Tell me what is the answer. Yes, very good, very good. We will be getting 79 electron volt. Can we go for one more question? Can we go for one more question? Okay. So the electron in a hydrogen atom first jumps from the third excited to the second excited state, subsequently to the first excited state. The ratio of respective wavelength of the photons, lambda 1 divided by lambda 2. Can you find the answer for me? Can you find the answer for me? What is the equation? What is the equation? 1 by lambda which is equal to R into 1 by Ni square minus 1 by Nf square. Correct? So, first you have to find 1 by lambda 2. Okay, 1 by lambda 2. Because while we are taking the ratio, lambda 1 will be going on the top. So, this is what the equation we should use. Okay. So, now this is going to be, eventually you are going to get lambda 1 by lambda 2 da. Okay. Now, can you just substitute the values? 1 by lambda 1 we know that fourth to third excited state da. So you can just go for Ni and Nf, and second case it is coming as 3 to 2 da. So you can just substitute and please let me know the answer. Please let me know the answer, everybody. Everybody. Do the calculation and let me know what is the answer. And guys, don't forget to like the session. Don't forget to like the session. Yes. And marakama subscribe panikoda. So what is the answer we are getting? What is the answer? 20 by 7 we will get it for this one. Okay. Now we have, let us do one more question. Okay. So this is actually recoil of atom da. Okay, recoil of atom da actually vandu indha oru concept. So idhula vandu simple ah sollitena, we know that we have a gun recoil we have studied, right? Exactly the similar thing. Instead of bullet and gun, here we have the photon and the atom. So photon oda momentum vandu h by p da. Okay, h by p da should be equal to what? The what is the momentum of the atom, which is m into v. So if we need to find the v now, we can go for h divided by p into m da actually we can just do it. Okay, so sorry, this is h by lambda, sorry, momentum h by lambda. Okay, so this is what the expression for the velocity. So now in the question we have the mass is given. Yes, 1.6 into 10 to the power minus 27. Lambda is also given. What is lambda? What is lambda? 660 nanometer. Now you can just go and find the answer for this question. Yes, exactly. Momentum of the photon and the atom, atomoda momentum vandu conserved aarukanam. So this is how the relation it will come. Adilirundu you have to find the recoil velocity. Exactly similar to nama recoil of gun da, bullet and the gun instead we will be going for this one. Okay, very good. So we will be getting 0.6 meter per second as the answer for this question. Now we have the nuclei. Okay, so yes, 0.6, very good. Okay, so now we are going for the nuclei. So in the nuclei first we should know how to represent a nucleus. So in the representation we will be giving the atomic number as well as the mass number. A is representing, where is A? Okay, A is representing the mass number, Z is representing the atomic number. Now tell me what is the relation connecting the atomic number and the number of electrons, number of protons. How it is related? How it is related? Can you please let me know? The atomic number, number of electrons, number of protons. This is how it is related. How it is related? Can you please let me know? How it is related? How it is related? இதெல்லாமே equal da, correct ah? I mean நம்ம atomic number, number of electron, number of proton எல்லாமே equal da. And what about the number of neutrons? How we will be finding the number of neutrons? How we will be finding the number of neutrons? Very simple. Nama mass number minus atomic number will be giving you the number of neutrons. Purinjudada everybody? Yes or no? So when I'm just talking about a nucleus, adukulla I can see that. Okay, when I'm talking about the nucleus and the nucleus I can see the protons and neutrons. So appadina the total number of the total number of nucleons sollumbodhu. Okay, total number of nucleons na it is nothing but the number of protons plus number of neutrons da. Correct? Number of protons plus number of neutrons. So this is what the first part. Next one is nothing but the size of the nucleus. Size of the nucleus we should know, we will always say in terms of the mass number. Okay, so in the radius of the, or let's say the size of the nucleus will be proportional to 8 to the power 1 by 3 da. So 8 to the power 1 by 3 A ina nama mass number da, and R naught na adu constant value da, which is equal to 1 femtometer, which means 10 to the power minus 15 meter da. And density of the nucleus almost equal for all the atoms. Okay, and that value will be almost equal to 3 into 10 to the power 17 kg meter per second da. Purinjidada everybody till this understood? Please let me know. Give me a yellow heart if you understood till. If you understood till na, give me a yellow heart. Yes. So next one important point enna, let us say we should know, we have studied, okay, we have studied one thing. Nama what to say, mass energy convert panna mudiyum. Adha nama Einstein's mass energy relation. Do you remember that equation? Energy it is nothing but mc square, which means mass will be converted as the energy, which means energy will be equal to mc square. Ipo the mass, okay, the converted mass the value 1 AMU na, aduk equivalent energy will be 1 AMU into c square, which means 1 AMU into 3 into 10 to the power 8 all square, which is going to be 931.6 0.5 mega electron volt. Okay, in the value one, it is very important because most of the cases we will be substituting this one. Okay, so if the mass is given in terms of AMU na, you can go for the 1 AMU. Okay, if 1 AMU is converted as energy na, adik equivalent ana energy will be 931.5 mega electron volt. Understood? Yes or no? Yes or no? Yes or no? Please let me know. 10th English. What? Okay. So next one we know that in the nucleus பார்க்கும்போது இதுல நம்ம neutrons இருக்கு, protons இருக்கு. கரெக்ட்டா? அப்படினா in the total mass of the nucleus actually should be mass of the total mass of the protons plus the total mass of the what is it, neutrons are correct. But ana what is happening, it is actually less, which means there is some defect is happening. This is what delta m. What is delta m? The mass defect, nothing but the total mass of the nucleons. Okay, delta m, the mass of mass defect, which is equal to the the total mass of the nucleons, the total mass of the nucleons minus total mass of the nucleons minus what? Minus the mass of the nucleus. Okay, mass of the nucleus. So now tell me what is going to be the mass of the nucleons. So ipo I have told you mass of protons irukku, mass of neutrons irukku. So mass of proton, one proton oda mass mp da. Appadina how many number of protons are there in the nucleus? Ipo oru proton oda mass mp da. Okay, அப்படினா அந்த nucleusக்குள்ள definitely there will be, okay, definitely what will be there, can you please let me know, and the mass, and the nucleusக்குள்ள there will be some amount of protons. What is going to be that? It is nothing but same as the atomic number. So total mass of protons which is coming as Zmp. Now like this way, can you please let me know total mass of neutrons? What is total mass of neutrons? Zmp da total mass of protons. Appadina what about neutrons? Neutrons will be very simple. It is nothing but A minus Z into mass of neutron. So now I am going to substitute these values over here. So what I will be getting? Zmp plus A minus Zmn minus the mass of the nucleus. This is what our delta m, the mass defect. In the mass defect is actually utilized as the binding energy. Appadina if you need to find the binding energy na, you can just multiply this with c square. Very good Sanju, very good Yokita, very good. Okay, very good Srimukhi. Yes, perfect. Okay, so this is what the binding energy na delta m c square da. Okay va? So next one enna, always over particle kume it needs to get the stability. Okay, appadina it will try to come to the most stable state, which means all the lower mass number irukra ella nucleus what they will do, they will combine and they will come to the high, the what is a stable state. And nama higher mass number irukra nucleus ellame they will split and they will come to the stable state. So in the two process that actually we need to discuss. So in the lower mass number irukra nucleus they will combine, they will fuse, okay, and eventually they will come to the nama energy stable state la. So definitely I can say that process is nothing but the fusion. Okay, ana higher mass number irukra nucleus they will split, which is nothing but fission. And nama what is it, whenever we are talking about okay fission and fusion, nama fusion la da actually huge energy is released. This is what is happening in sun. Okay, so fusion na nama small nuclei they will combine and they will give a huge energy. Okay, nama fission vida compare பண்ணும்போது fusion is having a lots of energy, and radioactive waste kuda it is less in the case of fusion da. Extreme high energy da actually nama fusion process la irukke. Okay va? So now quick we can just do few questions, adukapram we can just go for the small, not small, it is going to be little large. Okay, it is almost 5-6 hours, more than 5, 6 hours almost. Okay, so we can just go for a little longer break. So on the time you can also take rest. I will also have something, and Praveena, don't forget to have something. Okay, you also didn't have the lunch, right? Okay, so those who have not had the lunch now, ungalku vandu indora time you can just have lunch, and you can just I mean, don't stick with the mobile phone and all. Okay, just go out, just have some good breeze. Okay, and that will definitely give you some kind of what to say momentum. Otherwise now what will happen, again you won't come back. Okay, if you're sticking with mobile now, definitely I'm telling you, you won't come back. Okay, so yes, so let us do this question. So tell me the answer for this question in a very simple question. We know R is equal to R naught into 8 to the power 1 by 3. So you can just take the ratio. You can just take the ratio. Very good, very good, very good, very good, very good. What is going to be the answer? We can just take the ratio as A to the power 1 by 3. So alpha by beta it will come. And alpha and beta oda relation kuda it is given. Okay, so you can just substitute and you can just get the value. Okay. Now let me just give you a question which will be having a little bit more calculation. Okay, let me see how many of you will be giving the right answer. This is the calculation konja adhigama irukke, so you have to do it. Okay, if you are giving immediate answer na, which means you haven't done the calculation. Do the calculation and get me the answer. Everybody, everybody, everybody. So now it is taking time, or you left? Ivlo time you guys have completed. Yes, so we will be getting option D as the answer for this question. What about others? You guys are getting the answer? Or please let me know. Please let me know. Yes, perfect, perfect, perfect. So now let us go for one more question. Hey, where are you going? Oh my God. Yes, let us do this. Again, similar thing, the binding energy that we need to find it. First of all, you have to find delta M. Adikapre you have to multiply it with, it needed in what is a mega electron volt. So you can just multiply it with 931.5. Tell me what is going to be the answer for this question. You can solve it and you can tell me which is going to be the right answer for this question. So, first you have to find delta M. Delta M first you have to find the nucleons mass you have to find. So, number of protons 7 da, number of neutrons 7 da. So, you will be getting 7 MP plus 7 Mn minus mass of the nucleus, which is also given in the question, into 931.5 mega electron volt. This is what you should do. Very good, very good. We will be getting option A, 104.67 mega electron volt. We are going to get it for this question. Okay. So very good, very good. So now the thing is like, let us go for a small, not small, I'm just going for a longer break. Okay. So idukapram we can just continue with the optics. Okay. So right now the time is 53. So can you just come at 5:30? Will it work? Okay, and as I mentioned, don't stick with the mobile phone, because if you're sticking with the mobile phone now, after the session, after the break, you won't come back. Okay, so let us resume at So see you guys after the break. We can make. No, my food should reach us. I hope it is reached here. So let me just have it and let me come. Okay. So around 5:30, you guys can come back. Hello guys, am I audible, visible? Let us continue. Give me a fire if you are ready for it. So actually in the beginning, a few people have told me, na ma'am, in the end varaikku na irukkum ma'am. And the students, can you please again let me know in the chat box? இதெல்லாமே என்ன மேம் 8 hours 8 hours வந்து it is easy for us to stay with you ma'am. அப்படி few students has mentioned, ஆனால் வந்து அவங்களை இப்போ வந்து பார்க்க முடியலை. So where are those people? Let me see. Yes, Gautam. Yes. So let us just continue with the optics. Optics first one we have to understand few facts. First one is angle of deviation. Okay, angle of deviation. What is angle of deviation? So let us say we know that if this is the surface. Okay, so this is the normal. So right now the light is actually falling like this. Okay, va? So this is making an angle theta with the normal. Correct, Ada? So if there is no deviation, it has to move in a straight line. Ana vande definitely what will happen, da? It will reflect. Okay, va? It will reflect. So this is what the deviation. Okay, this is what the deviation. And the deviation will be coming as 180 minus 2 into incident angle. This is what the another important thing. Next one is number normal incidence and the grazing incidence. Okay. So what is number normal incidence? Normal incidence na number normal, okay, which means idha vandu surface, idha vandu normal. So the light will be falling exactly in the through the normal. So that is what the normal incidence. And next one is grazing incidence. What is grazing incidence? Grazing incidence na almost vandu it will be perpendicular to the normal, which means surface ku parallel irukum. Okay va? So the light will be passing or the light will fall parallel to the surface, illana perpendicular to the normal. Understood, Ada? Give me a yellow heart everybody quickly. So next one, the number of images formed in an inclined plane mirror. So adala vanthu important, we should understand one thing. Let us say we know two plane mirrors irukku, adu vanthu it was making an angle theta with each other. Okay, theta degree da they are making. Appadina so definitely I'm just thinking about, okay, இப்போ வந்து 360 divided by theta தான் வந்து we are getting. Okay, அது வந்து ஒரு even number na. Okay, புரிஞ்சுதாடா? 360 divided by theta வந்து ஒரு even number na, number of images will be 360 by theta minus 1. Correct? Odd number ஆஇருந்தாலும் same condition 360 by theta minus 1. Okay, when we will be having the difference. So actually வந்து this is the two plane mirrors. Okay, this is the angle bisector. இப்போ வந்து we kept the object at the what is a angle bisector na, in the equations whatever we z is correct. புரிஞ்சுதாடா? Answer, I mean whatever we have mentioned, it is correct. Ana vanda, if it is not along the angle of bisector na, okay, if it is even, there is no problem. Okay, same equation, no changes. Ana vanda, if it is odd, which means number 360 by theta vanda you are getting it as odd na, definitely number of images will be, you don't need to subtract minus 1 from it. புரிஞ்சுதாடா? So simple ah da irukke. Two plane mirrors, அதோட ஒரு bisector இருக்கு. Okay, so அந்த bisectorல தான் I kept the object. அப்படினா there will be two cases it is possible, right? Correct? 360 minus theta. Okay, அது வந்து odd இருக்கலாம், even இருக்கலாம். Whatever it may be, number of images will be. Either it is odd, either it is even, it will be always 360 minus theta. Sorry, 360 by theta minus 1 தான். ஆனா வந்து இப்போ object வந்து இந்த angle of bisectorல இல்ல. Okay, it is actually at some other point. Okay, அப்படினா evenனா there is no issue, 360 by theta minus 1 தான். ஆனா வந்து odd வரும்போது what will happen da? In the number of images will be simply 360 by theta. Okay va? Next வந்து நம்ம plane mirror ஓட properties தான் நம்ம வந்து find பண்ண போறோம், இல்லனா discuss பண்ண போறோம். So first வந்து plane mirror ஓட radius of curvature இல்லனா focal length வந்து infinity இருக்கும். Image distance will be always object distance தான். Can you just give me the other inputs, everybody நம்ம plane mirror ஓட properties? Okay, image distance will be equal to object distance தான், and நம்ம height of the image and height of the object வந்து same இருக்கும், and also in the image will be always erect and the virtual தான், and also lateral inversion. What is lateral inversion? If I am raising my left hand, I will feel in the image, I will feel like I have raised the right hand. Okay, so this is what the important facts regarding the plane mirror. All the points were important in the plane mirror. Okay va? So next one வந்து some of the important things, okay, regarding நம்ம spherical mirrors. Okay, so அதுல வந்து பார்த்தேன்னா நம்ம radius of curvature வந்து எப்பவுமே 2f இருக்கும். Okay, radius of curvature வந்து always வந்து 2 times focal length தான். Next வந்து நம்ம mirror formula. This is again very important. Okay, 1 by u plus 1 by v which is equal to 1 by f தான். Magnification கூட important தான். You can study any of the, I mean basically you need to study only this two, minus v by u or let's say hi by ho. In the v and u வந்து depending upon the question you have to find it from here. Okay, maybe they have given focal length and u. அப்படினா v வந்து we don't know, right? அப்படினா we will be just substitute here, we will be finding it. So in the equations எல்லாமே வந்து by heart பண்ணணுமா? I will say no. Okay, ஏனா வந்து you can just, you know the mirror formula na, so definitely it will be easy. So next one I'm going to ask you few questions. Okay, you people have to give me the answer. Okay, u is always negative. So அதுக்கு வந்து சிம்பிளான ஒரு explanation I will tell you da. இதுக்கு அப்புறம் we will be discussing about the sign convention. அந்த டைம்ல just remind me da. அந்த டைம்ல I will tell you. Okay, so நம்ம magnification வந்து, okay, அதோட magnitude வந்து it can be -1 +1 or let's say more than whatever it may be. I'm just telling you the magnitude மட்டும் வந்து it is greater than 1 da. அப்படினா what you will understand? What is the equation? hi by ho. Magnification is actually talking about in the object விட how big is the image. அதுதான் வந்து magnification. So magnification is more than 1 na, image வந்து it is having high, I mean height வந்து அதோட size வந்து it is going to be very good. Okay, so next வந்து less than 1 na, height of the image வந்து less comparing with the object தான், and definitely இது வந்து ஒரு negative value. Magnification வந்து we are getting it as negative na, what does it is indicating? It is actually inverted, equal to 1. Okay, you are getting magnification order magnitude one, you are getting it as 1 na, same size da. Okay, same size, object and image one the same da, and if it is positive na, that is indicating that is nothing but erect. Okay, so next on the I should go for the sign convention. Okay va? So basically you should understand. Okay, இப்போ வந்து convex இருக்கட்டும், concave இருக்கட்டும், whatever be the mirror, you should understand few of the steps na, all the ray diagrams will be easy. Okay, so அதுக்காக first I'll be going for a parallel line to the principal axis. Parallel line to the principal axis na, after this reflection how it will go? Can you please let me know? Everybody? So this is the focus, this is the radius of curvature, or let's say center of curvature. Okay, now tell me, a ray is actually falling parallel to the principal axis. After reflection, very good Padma, it will passes through the focus. Purinjidada? Now I am just going for the reverse one. Reverse one na enna? Actually வந்து the light is actually, இதுதான் வந்து நம்ம focus, this is what the center of curvature. So அப்படினா light is falling through the focus. After reflection, what will happen? After reflection, what will happen? Can you give me the answer? After reflection, what will happen? After reflection, what will happen? Yes, parallel to the principal axis. Another one is nothing but, okay, another one is nothing but, this is passes through the center of curvature, okay. This is passes through the center of curvature. Then what will happen? Then what will happen after reflection? After reflection, what will happen? If it is passes through the center of curvature, it will retrace its path, which means it will just follow the same path. Purinjidada everybody? Are you guys getting what I'm saying? Yes or no? Please give me a yellow heart if you understood till this. If you understood till this, please give me a yellow heart everybody. Everybody? Yes, perfect, perfect. So next one is nothing but, let us say, this is our principal axis. This is what our pole. Okay. So now what is happening da? So in the ray is actually falling over here, which is making an angle theta with the principal axis. So principal axis this is also the normal at this point, correct? So can I say that theta is the incident angle? Can I say theta is the incident angle? What is incident angle? The angle made with the ray and the normal da. So now tell me what will happen after reflection? This will be making the same angle theta and it will reflect. Purinchidada everybody? Yes or no? Yes or no? Please let me know everybody. So right now the thing is like you need at least two rays to form an image. Okay, two rays should intersect to get the image. Next one is nothing but, so you can use any of the rays. You can use any of the rays. There is no restriction. Usually we will be taking one which is parallel to it and another one is center of curvature. Yeah, we need a NEET diagram we need it. Actually we are choosing this too. There is no such conditions. We need this one only. Okay. So next one the sign convention da. So let us say this is the mirror. Okay. Object okay. Object so important factors like we know that the light is falling in this direction. Correct? Light is falling in this direction. The horizontal distances like u, v, everything, all the horizontal distance we have to calculate from the pole. Okay, the initial point should be the pole. Appadina you can just calculate, you will be calculating in the opposite direction of light, correct? So this time you will become negative. This time you will become negative. So always you have to, basically the problems nama light ippadida varaporo. So if the light, we are calculating any of the horizontal distance in the opposite direction of the light falling na, definitely what will happen da, nama value will become negative. Purinjidada? Everybody understood? Yes or no? Yes or no? Please let me know through a yellow heart everybody. Everybody give me a yellow heart. Quicka, you can give me a yellow heart. Okay, so this is what the important one. Okay, next one is let us say I'm just getting an image over here. Okay, appadina again I will be starting from P. So I will be again getting the positive value. Okay, so next one is the vertical distance. Vertical distance na, if we are calculating upwards, it is positive. Okay, and also if it is like this, then it is going to be negative. There is no much problems. Okay, only confusion is with the horizontal length only. The rest of the cases it is easy. So ray diagram whatever be the rules I have taught you, adu follow pannitena ray diagrathila edho oru confusion edume irukadu. And also over a point whenever we are keeping the object, what will be the image order, properties, adellame you have to study. I kept a table and also I have given the different sets of in the ray diagrams at different position I have given. So you people have to. It can be, there is no, let us say, I am getting a virtual image. Okay, first one or object I am getting a virtual image. And the virtual image, actually, let us say, it's again coming as the object for another one. Definitely that will be again coming as positive. Okay, we cannot say that is not possible. You also can be positive, but still, there are some conditions like this. Okay, if it is a statement coming like this, you cannot just simply write it like that. But definitely this is also possible. Okay, you can also be positive. Got it? Okay, so this is what the ray diagrams, which is very important, you guys have to study. So next வந்து நம்ம refraction தான். Refractionல சொல்லும்போது we know that we should know the refractive index. என்னடா இந்த refractive index? Refractive index is nothing but நம்ம C by V. C na என்ன? Speed of light in vacuum, and V na என்ன? Speed of light in the medium தான். புரிஞ்சுதாடா everybody? Are you guys getting what I'm saying? Yes or no? Yes or no? Please give. So the hearts and all, it's not coming. This is really awkward. Okay, so mu is equal to C by V da. Okay, அப்படினா first வந்து நம்ம what to say law of refraction சொல்லும்போது yes, 10th standard. Actually வந்து நம்ம 12th ல கூட u is always negative da. Okay, problems எல்லாமே பண்ணும்போது we will be get it like that. But actually the fact is, okay, it can be positive also. We cannot always say that will be always negative. அந்த மாதிரி சொல்ல முடியாது. அவ்வளவுதான். Okay va Kritika? Okay, so right now nama laws of refraction da. Laws of refraction la two laws irukku. First one is very simple. Incident ray, refracted ray, normal are in the same plane. And also second one is nothing but nama Snell's law da. Snell's law na sin I by sin R, which is equal to mu2 by mu1, which also, okay, if I'm just substituting for refractive index, I can say v1 by v2, which is also equal to lambda 1 by lambda 2. Okay va? And another important thing is nothing but the let us say real depth divided by apparent depth. That is also coming as the refractive index. Okay va? So this is valid when it is, when the observer is in the denser medium. So if we, the light is coming from, not observer, light is coming from the denser to the rarer na, this is going to be the equation. Okay, refractive index oda equation. Ipo vand light is coming from the rarer medium to the denser medium. Okay, light is coming from the rarer medium to the denser medium na, definitely nama refractive index vand apparent depth divided by nama apparent depth divided by real depth da nama equation varaporom. Okay va? Understood that everybody? So this is what the another one. So now I'm just going for another one more thing. Okay, one more thing irukenda. So ipo vandu neenga vandu paathena here you can see different refractive indices. Okay, and adoda depth kuda different da. So appadina ipo vandu if someone is observing from here, apparent depth, how we will be finding it? Very simple. Just try to find it for individual cases. This is going to be d1 by mu1. Okay, this is going to be d2 by mu2. This is going to be d3 by mu3. If you are just adding all those things, you are going to get the apparent depth. Purinjidada everybody? Yes or no? Please let me know, guys. Please let me know. So simple ada irukke. Refraction la we need to find the refractive index na. Two possible cases are there. When light is coming from denser to rarer, this is going to be the equation. When light is coming from rarer to denser, this is going to be the equation. Okay va? So these equations are, because yena nama in the chapter la complete vandu equation based da. If you know the equations very well na, in the chapter la most of the questions vandu ungalala solve panna mudiyum. Okay va? Next வந்து நம்ம lateral shift தான். Lateral shift என்னன்னா, let us say இங்க வந்து ஒரு glass இருக்கு. Okay, glass ஓட thickness வந்து T தான். Okay, so right now the light is falling like this. Okay, right now light is falling like this. This is what the incident angle. Okay va? So now tell me da, light is, okay, we know that இது வந்து air da, இது வந்து rarer medium, this is denser medium, this is again rarer medium. Correct ada? அப்படினா now tell me, if after this refraction on the first phase, okay, after the refraction, the first phase illa, okay, first phase illa irundha, which means light is coming from the rarer to the denser medium, and the time illa this ray will move towards or illa away, which means light is coming from rarer to denser medium. Will it come closer to the normal or away from the normal? Rarer to denser la, so definitely this will be closer to the, okay, this will be closer to the normal arc. Correct ada? Again I'm just going for the normal over here, and again denser to rarer, it will move away. This is what the emerging angle, this is what the incident angle at this point. Till this understood everybody? Till this understood? Give me a yellow heart if you understood till this. Yes, very good, very good, very good, very good. Yes, perfect. So in the case if it is not, one second, okay, so right now Yeah. Right now, if it is not refracted, it should go in a straight line, right? Okay. If there is no refraction, deviation happen, it should follow a, what to say, or a straight line வந்து follow பண்ணணும்ல. So definitely there will be, okay, these two lines, the emergent ray and the expected, okay, without reflection, refraction, if the ray is going straight na, definitely inga vandu paathena these two lines will be parallel, and this is what the lateral shift, adoda expression da inge irukke, sin into I minus r divided by cos r into t. Purinjudada everybody? So this equation is important, you don't have to study more about it, at least in the equation is very important for right now, and just understand the scenario, what is I, what is r, what is this lateral shift, ellame vandu clear ah neenga vandu purinju vekanum, okay va? So this is what lateral shift. Next vandu nama total internal reflection da, okay, next vandu nama total internal reflection da. What is total internal reflection? Very simple, very simple. Ipo vandu let us say this is what the medium, okay, this is what the denser medium, this is what the rarer medium. Now this is the normal, okay, I'm just taking few cases. Now imagine, okay, I'm just going to ask you, light is actually falling from the denser to the rarer medium. What will happen after refraction? Will it go away or closer? Can you please let me know? Ipo vandu in the ray irukke, okay, in the ray will be, it will go away after refraction, it will go away from the normal or closer. Definitely we can say that this will be go away, okay, I can say that this is what the incident angle na, incident angle will be less than that of the refracted angle. Very good Yogita, okay, away from the normal, very good, yena vandu it is actually denser to rarer da. Now what I'm going to do, I will be again increasing the incident angle, okay, again increasing. So what will happen, this will again bend, okay, again I'm increasing the incident angle, but this time what happened, this will be going along the surface. This particular incident angle da, what I'm calling it as the critical angle. What is critical angle right now? It is nothing but the angle of incidence at which the refracted angle will become 90 degree, okay, refracted angle become 90 degree, or else the refracted ray will be going through the interface. Purinjadada everybody? Give me a yellow heart if you understood. Now another one. So again if I am giving, okay, ipo vandu nama incident angle vandu more than critical angle, now what will happen, it will reflect back to the same medium. This is what actually the total internal reflection. So in the total internal reflection kaga we have two conditions. First condition vandu the light should passes from denser to the rarer medium. What is the second condition da? It should be, the incident angle should be greater than that of the critical angle. Purinjudada everybody? Marakama like paniko all the people. So next one is nothing but about the minimum deviation da. So minimum deviation la I have already written the conditions, okay. So incident angle should be equal to the emergent angle, and the refraction happened on the two surfaces, that should be equal, and also on the value should be equal to the angle of prismathoda half ah irukanum. Appadina we can just say that refractive index of the prism will be sin I by sin r. Sin I vandu it will be coming as a plus delta m. Delta m na nama minimum deviation da, divided by 2 whole divided by sin r, that will be coming as sin a by 2. So in the equation is very important, all the people should study this, okay. And minimum deviation la ray incident on the prism will be parallel to the base of the prism, which means ippadi nama structure irukum, okay. So the light will be falling over here, adukapram this will be parallel to it, okay, adukapram again it will be go like this, okay va. So this is, without deviation it has to, okay, it has to go like this without deviation. Oh, something is happening, okay, without the deviation this has to go like this, but finally it was going like this. So this is what the deviation, and to get the minimum deviation I have already given you the conditions. Already understood? Yes or no? Yes or no? Yes, thank you Srimugi, thank you so much. Okay, so this is what the thing. Now we have to go for thinking about thin prism. Thin prism na, the angle of prism is less than 5 degree na, I can call that as the thin prism. Understood? I can call it as thin prism. So அந்த ஒரு டைம்ல incident angle will be mu r1 and emergent angle வந்து mu r2, and the deviation oda equation வந்து it is very important, it is nothing but mu minus 1 into a da வந்து நம்ம deviation oda equation. Everybody getting it or what? Please let me know da. Please let me know everybody. Are you guys getting what I'm saying? Yes or no? Okay, so right now we are going for the angular dispersion. Okay va, angular dispersion na, let us say இப்போ வந்து the light passes through the prism. Okay, அந்த ஒரு டைம்ல definitely நம்ம what to say, 𝐉𝐵 or it will come, right? 𝐉𝐵 or it will come. So definitely what will happen, the light will be falling on the first surface, then the refraction will happen, அதுக்கப்புறம் dispersion will happen, correct? So அந்த ஒரு டைம்ல the what to say, the deviation happen for violet and the extreme color, that is red. So அதோட difference தான் actually வந்து நம்ம angular dispersion. Okay, angular separation between extreme colors தான் actually வந்து angular dispersion. And அதோட expression வந்து refractive index of violet minus refractive index of red into angle of the prism தான். Next one, the mean deviation, which is again very simple. Yena mean color, usually we will say that is nothing but yellow. Appadina, the mean deviation will be coming as mu v plus mu r, which means the refractive index of two extreme colors divided by 2. That is what the refractive index of the mean color. Next one, the deviation. Deviation or equation what we have studied for thin prism, it is mu minus 1 into a dana. So inga vandu paakumbodhu I will rewrite, instead of mu I will rewrite the refractive index of yellow. What is refractive index of yellow? We already found it from here. Minus 1 it will come. Okay, minus 1 into the angle of prism. Next one is dispersive power. Adu vandu in the two quantities oda ratio da, avlo da. Okay va? Next one, the two cases you should study: dispersion without mean deviation and mean deviation without dispersion. So dispersion without mean deviation சொல்லும்போது நம்ம delta y இல்லையாடா, so அதோட value வந்து it will be coming as 0, which means the yellow is not deviating. Okay va? So next case la mean deviation without dispersion சொல்லும்போது we will be get to know the angular dispersion illaya, that will be same. Okay, these are the two cases we should understand. Okay, so now we will be again going for the refraction at the spherical surfaces. The refraction at the spherical surfaces will be coming as mu2 minus mu1, sorry, yeah, mu2 minus mu1 divided by, sorry, mu2 minus mu1 divided by r, which is equal to mu2 by v minus mu1 by u. So in the equation is very important. Yena vanda next all the rest of the cases we are going to discuss. Okay, the base panni da actually vanda nama lens makers formula, lens formula